Okay. Good morning, everyone. Welcome to Future Frontend 2024. I am of the personal belief that you should never ask an audience to applaud, so I will just stand here awkwardly until you get the drift. That's my style.
Nice.
Yes, so my name is Jani Evakallio. I am originally here from Helsinki, and I am one of the hosts here today. And here's our esteemed co-host.
Yeah, hi. I'm Totle. I'm, the second MC. I'm a software developer. That's all about me.
Yeah, there's not that you need to know about us. We're just here to make you uncomfortable throughout the day and make sure that everybody is appropriately cringed up. That is our job.
Yeah. This year is the second edition of Future Frontend. Was there someone here last year? Juho, nice. Okay, great to see you again. Obviously, last year was great. Let's make this year even better. Yeah, it's a nice, small, compact conference, so we wish that you will take the full advantage of it, because in theory, I think you can talk with everyone during these 2 days.
Nice, yeah, and so over the last couple of days, we did a few workshops. I hope those of you who went to the workshops enjoyed them. If you didn't go to them yet, well, you missed them, but good luck next year. You can join them again. But instead, what we have for you now is 2 full days of conference. We are a single-track event, so we are here in this room. So if you are here, you're in the right place. If you're not here, well, then you are obviously missing out. We have 18 speakers over the 2 days, and in a moment, we'll tell you a little bit about how we're structured that. Oh yeah, and as I already said, this is a single-track conference.
Yeah, so the speaks are divided into themes. Each theme will have 2 to 3 speakers, and after the speakers have spoke, we will have a Q&A. Yeah, here's the themes. They're, everything you want to know: AI, green computing, whatnot.
Nice. And the most important track always is the hallway track. That's where you come in. So during the breaks, which we have plenty with coffee and pulla, as we say in Finnish, you can talk to each other. It is allowed. We also have some sponsors who would love to talk to you, and hopefully, especially if you're here in Finland or working in Finland or looking to maybe work in Finland, I'm sure that our sponsors will be more than happy to talk to each and every one of you. So we have our main sponsor this year is Digia, and our silver sponsors Evitech and UpCloud, and also our gold sponsors who have, our bronze sponsors Totle, Alma, Knowit, and Columbia Road, who have helped us make this event happen and stay affordable for all of you. So thank you to our sponsors.
Yeah, there's going to be an after party on Friday, but you need to sign up. So if you haven't done that yet, please do. And then we are following Berlin Code of Conduct, so please behave. And if someone doesn't, you can find the organizers with the blue lanyard, and you can come and tell us if you have any concerns about, well, anything in life. And red lanyards mean that you shouldn't include them in the photos or videos or anything.
Right, and yeah, when you are out there in the hallway, just there on the left, there's an info desk. So we have a little attendee gift bag for all of you. So if you haven't grabbed yours yet, please do go and get it. There's all kinds of swag and goodies in there. And the most important rule when you're there in the hallway is to follow the Pac-Man rule. Does everybody know what the Pac-Man rule is? Does anybody know what the Pac-Man rule is? All right, we have a couple people, but for those who don't know what the Pacman rule is, and this is Juho is now coming here helping us demonstrate the Pacman rule. See, when you're having a conversation in a group of people and you form a circle of people like this, yes, it's very difficult for somebody to enter this conversation when they don't feel welcome, when everybody is sort of, it's a closed circle. So what we do instead, that we leave the proverbial mouth of the Pacman open. So other people can come and join the conversation. This is way more effective with more people. I think with 3 people it's a little weird, but I think you get the gist. I did ask you how to put in a graphic here of a Pac-Man, but he was afraid of a copyright violation situation. So instead we needed to demonstrate this live. I believe the physically created likeness of Pac-Man is not copyrightable. So I think we're good on that one.
Yeah, if you share anything on socials, please use #FutureFrontend. And after each session, we have a Q&A, and you can add your questions to Slido with the code FF2024.
Yeah, and we'll be reminding you of this after every talk. But yeah, do put that in mind. Maybe can we put the slide back there just really quickly, the Slido slide. No, okay, we cannot. We don't have the technology. So anyway, so this is the way that you can ask questions in our Q&A. So the Q&A block at the end of every 2 or 3 talks, you can ask questions from each of the speakers. You can use their name if you have a specific question to the speaker, but you can also ask any questions about the topic. These are experts in their field, so we can have a little conversation about it and hopefully sort of like more broadly learn about the topic of that block. And if you are not on the Wi-Fi, this is the Wi-Fi information. You can join, so you can get on Slido or other very important websites that you need to visit during the presentations. And speaking of important websites, you can join the conference Slack. So if you go to futurefrontend.com, there's a little link to the Slack at the top bar, and that will connect you with some of the brightest minds of our generation. It is the future frontend after all. I think speaking of brightest minds of our generation, we are ready to start our next first speakers. So maybe I will bid adieu to Totle. You will see her later. Thank you very much, Totle. You are a very good audience. I didn't even need to give you the hints that you need to applaud. But hopefully you will also keep the same energy up for our speakers. I will now invite Joab on stage to plug in. So that I won't have to speak here any longer and keep you all waiting.
Good morning. How is everybody doing? Woo! All right, great. I'm not going to stand awkwardly like Yanni and wait for you to clap. I'm going to make you woo.
Nice. But yeah, while Joab is setting up, we don't make him do the double act of operating heavy machinery and having to speak to the audience. So I will very briefly introduce Joab. So this first block is about compilers, which is a fascinating topic. I think it's a strong choice from Juho, our program manager, to start us with compilers at the beginning of the day. There are some conferences that may start with a light topic, maybe a little lighthearted keynote, maybe some social issues at the first thing of the morning, just to make sure that everybody is sort of like appropriately mentally lubricated for the day. But no, not here in Future Frontend. We go straight in to compilers. And our first speaker, Yoav Gunbar, he works on the Quick framework, and he's here to tell us about how the Quick's optimizer, or the compiler, allows JavaScript streaming and automatic optimization, which I just read here, and you could have read as well, but
That's okay, but I'm not able to connect to the Wi-Fi.
All right. Yoav did not prepare in advance.
I forgot to connect.
I did ask him earlier if he wanted the Wi-Fi, and he said, but now he...
Then I remembered I need it. Yeah, sorry.
Now he remembered that he needs the Wi-Fi, and now he's keeping me here speaking a little longer, but that's okay. How's everybody doing? Everybody good? Good. Yeah, me too. Thank you. It's really good to be here. I used to... Did anybody come here back in the days when this conference was called React Finland? Nice, some OG folks here. I actually see a lot of familiar faces here. It's good to see you all. React Finland was a great conference. It was about this framework we used to use called React. I don't know if you remember that one. Now we're here, of course, talking about the future. But the main difference between React Finland and Future Frontend is that React Finland happened in about November time, I think, which is a very different time here in Finland. So if you're visiting from another place, you should be thankful that we are now living in the future, 6 months in the future, in fact, from November, because that is a miserable time in this country. So just look out the window. It's not like this most days. If you're from Finland, you know what we're talking about. But most of the time, it does not look like this. So I think we're very lucky to be here today. And so that answers the question why I'm happy. Now the next question that nobody asked me. Sorry, I don't have another question. Are we good, Yoav?
No, I don't. I can't connect to the Wi-Fi.
Oh, really?
Yeah.
It's the that one.
This one.
Yeah. And then the password. Yeah. Oh, it's what, 2 A's.
That might be.
I plus. That's it. So yeah, I want to embarrass our speaker by telling you what egregious mistake he made.
Okay,
but,
yes, I did make a big egregious mistake,
but it's not his fault because the 2 A's in the word pause is a very difficult thing for people who don't come from Finland to understand, that you can have 2 vowels of the same kind next to each other.
All right. I think I got it. Can we switch up screen?
All right. Thank
No,
Lord.
I'm connected.
No, I think you're good. I think can we switch to the Oh, here we go. Hello.
Oh,
Thank
there we go.
Lord.
All right.
All right. Thank you very much. I will now leave you and give you Yoav Gunbar.
Hi guys. Well, I hope I made Yanni uncomfortable enough and make him speak a little bit longer. Okay, so hi. As Yanni mentioned, I'm Yoav. I'm a father of 2, husband. I've been a software engineer for over a decade now. Yeah, I'm part of the Quick team, and I also podcast, write, speak sometimes, when I can remember how to talk. And yeah, I'm currently cooking up something new. I'm in between kind of things, but follow me to see what I do next. And like Yanni mentioned, my talk is titled, How Quick's Compiler Enables JavaScript Streaming and Automatic Optimization. I know, a mouthful, but wait for it. So how did I get here at all, right? If some of you may have visited the website before, Mishko Hevery, the creator of Quick and Angular and Karma and some more stuff, was supposed to speak, but he couldn't make it, and then he tapped me in, basically, and then like, okay, prepare a talk in a little time. But hopefully I'll fill his big shoes well enough. But let's circle back a minute. So how did I get to be like part of the Quick team, and how I got here to Helsinki? It was, by the way, a difficult ride. I lost my luggage, but let's put it aside. Anyways, I used to work at Fiverr for a while, so I built a new product at Fiverr. While building that new product, I had a chance to kind of use Builder.io product. And that is where I learned about Quick, right? I heard that there's this new framework by Mishko, the guy that did Angular, like I mentioned. Now, what I heard about it at that point is this is a new framework that is going to basically give you performance out of the box. Now, later on, I heard that Shai Resnick, who's also part of the Quick team now, was organizing a workshop for like 10 people back in Tel Aviv, where I live. Now, it was supposed to have the best developers like around town, and I said I had to go. So 2 years ago, I had the privilege to attend this workshop, and I got to meet Mishko in person. Very nice dude. And the whole reason I went to that workshop is the pain I felt of working on optimizing websites. Like in my past, I dealt with performance issues on a big content site. I used to work for a travel startup that was doing mostly content-heavy websites. Now, let me tell you, it wasn't easy, right? It always starts with this, right? Someone up top comes to you and says, our website is slow. So if you could fix that, that would be great, right? You've got a ton of things to worry about, right? Now, I went on X and asked, like, what are the things you need to worry about when you're working on performance? And Dan Shapir answered me. Dan Shapir, if you don't know, is a co-host of JS Jabber, web performance expert. He used to do web performance at Wix. So he said these things. You got to always profile before you optimize, right? Your intuition is never really like where it's really at. You got to also profile after optimizing. Just because you improve your test environment doesn't mean you improve everywhere, right? Verify in production, monitor performance, set performance budgets, choose tools that'll help you fall into the pit of success. And of course, you also got to educate your team, right? And it's always good when you work with people like this. Okay, this is not landing. Yeah, Finnish people, come on, a little bit of laugh. Another good friend of mine, Gal Schlesinger, works at Vercel as a platform engineer, used to work at Wix. And he put out this funny tweet. The amount of improved pref commit we reverted at Wix, thanks to tooling, was too damn high. It was almost as if improved performance is a hint that this commit degrades performance. So, like I said, there's a ton to worry about, right? It's a tough problem. You got to measure stuff. You have to worry about JavaScript, bundle size, lazy loading. Do you do it? What kind of rendering do you do? Right? Load time performance, other performance. Why am I getting messages right now? Sorry. Do you use an SPA? Do you do load time? All those stuff. Too many things to worry about. You need to worry about images, CSS. But let me tell you, if you're having performance problems, let me tell you, son, I got 99 problems, but CSS never is one. Now, knowing what to optimize for is mostly known, right? Like, the actual biggest bang for your buck is going to come from optimizing JavaScript, right? That is where the most improvements can be made. But that is hard. Again, you got to deal with monstrosities like Webpack boundary line and others. You got to deal with your node models, right, which is the heaviest object in the universe. It's like playing web performance whack-a-mole. Every single thing you fix, then somebody else can break really easily. And of course, when you work on web performance, you might become this dude. So once again, choose tools that will help you fall into the pit of success. Now, from the beginning, web tools, what they try to do, right, is solve perf issues and developer experience. Now, just before we get to the meat of this talk, we need to understand what has come before. So let's look at like the different web framework generations. So Gen 0, the first thing, static files, Gen 1, MPA, SSR, Gen 1.5, MPA, and JS. So this is like WordPress sprinkled with jQuery and stuff. Then we have the Generation 2, which is single-page applications, React, Vue, Angular, and the rest. And the current framework generation is 2.5, where you have SSR with an SPA, and these are hydration-based frameworks. Now, so like we said, static. We have a client, we have a server. We just call the server, right? We get back a static file, static HTML, pretty simple. With an MPA with SSR, we have some data that gets passed by your user, server runs, then it returns a dynamic HTML page. With generation 1.5, you get the data and the HTML. Then if a user clicks, then there's some JavaScript that runs, right? With an SPA, you get the client calling the server, right? But you get an empty document with a div, basically. And then you have to run JavaScript to get your data from the server again. You get back JSON. And then you get your HTML. Now, with hydration-based, you call the server, right? You get HTML with JSON. But then you need to download the JS once again. You need to parse it. Then you got to execute it once again. And then you need to bind all the event listeners again. So you're doing the same work, actually twice. Only then can a user interact with it, right? Now, let's circle back a minute to the workshop, right? So I attended the workshop. And when I went in, I was very skeptical about this new framework, right? Like, really, another framework? And then Mishko started explaining things, and of course, he was looking like crazy. It sounded complicated the way he explained it. So I had to process. Now, what happened in the workshop? Like I said, all the people there were like people that I look up to, developers that I really looked up to and understand a thing or two. I had people from Node.js that are core contributors to Node.js and working on old libraries like Bluebird, for example. Now, all of these people, when they came out, they thought what we saw was something new, something exciting, something different. It's not like something we already knew before that. So what is Quick in a nutshell, right? Tagline is it allows you to build fully interactive JavaScript apps at any scale that load instantly with no extra effort. After I read this, and after I attended the conference, and after I thought about it, it hit me. Automatic optimization, right? This is the thing here. There's a tool that I can use to write code and not do all the manual stuff that I'm used to. And I felt like this is the future. I got to get into this. And so I went in on a deep dive and wrote a blog post back in September 22. And that is kind of something that helped me go and join Builder. In November 2022, I joined Builder. It was a series of events that led there. If you want to know a little bit more, you can ask me later. And then I had the opportunity to work with the Quick team and get to know the people and the technology a little bit closer, right? And dive deeper. So that is the reason why I could pull back the curtain a little bit and unveil what's behind it to explain it to you, right? So remember the title of the talk? Like I said, it was a little mouthful. I don't know if you've read like what Mishko's title was, but it was something in the terms of serialization, the secret of O1 frameworks. Who titled it better? I don't know. Let's see. OK, so what I realized that Quick is trying to do is optimize automatically, right? And it does this by something we like to call JavaScript streaming. What the heck is JavaScript streaming, right? The best way we found to explain this among the team is it's like video streaming for your JavaScript, OK? Not to be confused with HTML streaming or out-of-order streaming, right? We're talking about sending functions and closures over the wire. A little while ago, my buddy, Shai Resnick, just gave a talk at JS WorldConf titled JavaScript Streaming, A Quick Glimpse into the Future. And he shared his theory behind JavaScript streaming, and why wouldn't you trust this guy? Wouldn't you trust a wizard? Look at him. Doesn't he look really trustworthy? So, in the past, right, you wanted to watch a movie. You had to download the whole file. But if you wanted to watch the last 10 minutes, you had to wait to download the whole file, then go and scroll through and watch the last 10 minutes. But nowadays, we don't do this anymore, right? What do? People? What do we watch? Streaming, right. So Netflix, YouTube, and all the rest. But the thing is, like, if you are uploading a video to YouTube, you don't upload it like bit by bit, chunk by chunk. You don't bring it up manually and install pieces. It happens automatically, right? Let's talk about the stages of JavaScript streaming. We have chunking into segments, and we have then the smart first frame. We have segment buffering and lazy execution. Let's dive it one by one, right? Segment chunking is taking one JavaScript file and breaking it up into multiple chunks, right? Segments, we like to call them. We're really good at bundling things together, right, in the JavaScript ecosystem. But something that is hard is breaking things apart, right? And Quick's compiler is one of the things we do. We'll get to that a little bit later. Now, many of the chunks we don't really need for the client, right? They might not be used. So during the build time, these chunks get named. This is also a part that's done by the compiler. And then there's some work being done on the server. We pause it, we take the HTML, and we send a really smart frame of HTML. Now, the smart frame, or smart HTML, has all the information we need about the app state. Second part, client buffering. This happens inside a service worker in the background, right? We just load what we need. And then we have third step, lazy execution, right? So we already have all the files in the cache. So as soon as a user clicks on something, it comes in right from the cache. And it's all interactive, right on the spot. And if he goes into another one, right, again, another piece of JavaScript goes and works. Now remember pause and resume? Who here has heard of resumability? Right, not many. So resumability is powered by JavaScript streaming. Lazy execution is the ability to resume from where the server left off. Triggering an event handler is like pressing the play button on your remote. Notice something. There was no hydration. You can start an app basically from any listener when you use Quick. It's interactive right from the start. Right? The entry points are the segments, are the listeners. So let's take a look at the two pieces that are actually done by the compiler, right? Now the optimizer, Quick's compiler, is based on Rust and uses SWC, and then Vite and rollup. How does it work? The optimizer goes and looks for dollars inside the code base, right? That's our marker. That is a marker for the compiler and the developer to know that there's some magic happening here, right? Something special is going to happen. And this, like I mentioned, happens in the build step through Vite and rollup. What it does is makes everything serializable and async. It extracts everything into a module. And like I mentioned, only load what you need and execute when you need it. That's what makes it possible. If we do it this way, it's a big win for everyone. But how would you make a function lazy loadable? Have you ever thought about it? What do you need to do to make something lazy loadable? Let's have a look at a simple example, right? We have this very simple function. There's a little iffy in it, if anybody remembers what an iffy is. And we have a constant there. We have the function that closes over the scope of x. And if we want to make it lazy loadable, this is what we have to do. Also, you can imagine this being a hook or a use effect or something like that, right? What do we have to do? We have to name it and call it, right? Extract the init function. Then we need to move it out of the top function, right? But then we're missing the variable, right? Where's x? Then we need to pass in a parameter, right? And at this point, we pass the parameter, like I mentioned. We got to move it into a different file. And then we need to lazily import it. So there's a lot of manual steps, right? That's just to extract a function. The complexity that you have to deal with is pretty staggering, no? That is the pain I was talking about. This is the kind of stuff you need to deal with. You need to do a lot of manual steps to do stuff to improve performance, right? Just think about what it would take to extract a closure. Now, we've discussed how the optimizer does it. And simply, it's just, he breaks it apart, right? Extracts it into a module, gives it a name, serializes it into the HTML, and it creates a map so it can know later on the client how to lazy execute and find the things that it needs. Mishko tweeted this out a long time ago, right? We know how to serialize JSON, right? We need data, which is JSON. That is the output of it. And the code is just a file. But how do you serialize a closure, right? That is one of the key innovations to Quick, which allows resumability in JavaScript streaming. Quick does the same thing for closures. It knows where to load the scope, right? So in Quick, this is all you have to do. Like, forget about the JS6 down here. But in the end, we didn't have to move files and do all this stuff. We have the $ marker that helps us do that. All right, let's do a quick demo. Now I'm connected to the Wi-Fi, and let's have a look at something. Oh, my bad. No, stop. OK. No. Wrong one. Not extend. Where did it go? No. I want to mirror it. Sorry. Mirror. There we go. All right. So this is the quick playground. And I've prepared a little bit just to avoid all this confusion, right? So I'm just going to copy paste some quick code into here. So can you see the code? Do I need to make it bigger? The good? All right. So simple function. This is what I showed before. Now what I want to show you is how this whole thing kind of maps out, right? So we have the simple x, right? And we have the function of greet that has a console log that uses the variable x and a string. And the way it breaks it apart, right? Let's look at the HTML for a minute. So the HTML, like I said, it has all the information it needs. So it's in a paused state, right? And shows the base, and it has a marker for what the on-click is, right? There's this hash that tells it where this little thing is. And if we take this hash, right, and then look at the client bundles, now this is the playground. It shows how Quix works behind the scenes. And if we take this and look for our marker, right, we see it's in a different file, build app component hash, right? And then we have one more file that actually only has the function itself. If we look for this app, there's the console log. It did all that work for us. Now, I'll show you how it extracts scope. If we have a little piece of reactive state, okay, so a signal, right? Signal, does anybody not know what a signal is? Oh, everybody knows what a signal is. Great. So a signal, right, a reactive piece of state where you can mutate and then re-renders your DOM. So we have a signal here, and we pass it in to RP. And we increment it by mutating it, right? So we have the scope. And then if we look at the information that we have inside the HTML, again, we have a hash that leads to the actual file that has the onClick event handler. Then we have some data within, like a JSON, that has this weird kind of syntax that tells us about the scope and where it is. And if we look at the client bundle once more, and this is something we need to fix, you have to scroll, we use this thing called useLexicalScope. It basically takes the closure and hoists it up so it can be used by other components or files or anything it needs. All right. Let me put this back. And lovely. Come back. Where's the mouse? So I know what you might be thinking, okay? If you load everything from small segments, wouldn't that make it slow? So not necessarily. We can decide which chunk segments go together, right? And some won't be needed, like I mentioned. So we break it apart to kind of groups, okay? And we can also optimize and know what the interactions are that a user does. And we have this within Quick with Quick Insights, right? Quick Insights is something that Mishko built like a while back ago that basically helps you correlate between user interactions and which bundles or chunks a user needs to complete an interaction on a page. So this is statically analyzed and optimized by AI. Now, obviously, the information gathered is anonymous completely. We can know which order the user needs those segments based on this analysis. So to recap, there's a lot of pain in manual optimization, right? A lot of stuff to do. Now, we went over the web frameworks generations and how JS string works, right? We talked about the auto optimizer, the compiler of Quick, and a little bit about Quick Insights. What does the future hold, though? Now, I don't know, right? I am not Nostradamus. But after having some conversations here, just last night with some people from TC39, it seems that signals, JavaScript streaming, and lazy execution might be a part of the tools in our ecosystem in the future. So that's really exciting to hear that what we're doing in Quick is kind of coming back together with things that are being worked on into language, right? So the philosophy of automatic optimization is for everyone, right? It's for all the web. And we see this with other tools and other frameworks they're doing. They got image components that help you optimize images. Now React with its new compiler that helps you optimize your code without needing to do it manually again. These abstractions can help build great DX. What's next for Quick? So we're working on Quick 2.0 is coming very soon. We're working on out-of-order streaming and a bigger ecosystem. And now Quick is even more community-driven. And now is in a new domain, quick.dev. You can go check it out. If you want, you can check out the QR code, have some links there. And thank you.
Thank you very much, Yoav. Now you can go take a little break while we have Jason on stage, and then we'll call you back for a little Q&A after. Thank you so much. Amazing. We really did start in the deep end, and I think our next speaker is going to take us to even deeper depths, we would hope? No, okay. Is everybody caffeinated? Are we feeling good? Good? Yeah, no. Nobody yelled no, so I think that means we're all good. So our next speaker, Jason Romero, comes from a different background. He makes games, and I think games being a very performance-sensitive area, I think he's has a lot to teach us. So if your laptop is ready, let's give it up for Jason Romero.
Hello, everyone. Oh. Oh, well, thank you for having me here today. I'm super excited. I'm going to be talking today about the TypeScript compiler API and how you could start using it today in your projects to improve your data fetching and I/O parts of your application, no matter what front end you're using or what back end you're using. So before we get into that, a little bit about me. My name is Jason. I've been a software developer for around 10 years now. I'm from Montreal, Canada. Is there anyone else from Canada here? No, just one, the person that came with me. Cool. Yeah, and I work on game development tools. I've made some games in the past, but my current day job is making tools around game development and trying to make it easier to make games or to introduce making games to all programmers, even it could seem a bit daunting. So trying to make it easier for everybody. So before we get to the compiler API that TypeScript provides, I want to go over a bit of the evolution of data fetching that we've seen. So I'll take you back to around 2019. React hooks just came out around that time, and we were trying to figure out how are we going to do our data fetching in our React apps, basically. So what we came up with was usually something using like a use state and then a use effect to, when the component loads, we usually fetch our data from some backend API, and then we store that in our use state, and then we just show it on the page. Raise your hand if you've written anything that sort of looks like this in any framework at any point in time. So for the record, pretty much everyone raised their hand. That's great. I think, yeah, this is a very recognizable piece of code right here. I think we learned pretty quickly that there's a lot of issues with this piece of code. For one, we need to manually write our fetch functions, and that's something I'm going to focus on a lot in this talk. But aside from that, we didn't even handle our loading states. So if we were fetching our data, we would just show nothing at the beginning. We also didn't handle our errors. If our backend didn't respond the way we expected, we sort of just hoped it always returned the same thing all the time. And we did fetching on mount. So our component would load, and then we would fetch our data, and then it would show up. So there's a bit of a waterfall effect there. We also didn't do any caching on the front end. So we load a page that used the same component. It would do the same fetch multiple times, which is not great. So just to go over the waterfall part a bit, in case you're not sure what that is, waterfalls are basically a dependency on events happening in a certain order. So like say you load your page, the browser will request the initial page and the initial JavaScript. And you need to wait for that JavaScript to get to you and then run on the front end. And then once it runs on the front end, the browser will finally figure out, like, OK, I see this function. It's doing a fetch, and now I can do my fetch request for my data. So that is represented in this picture in the Chrome DevTools, where you see some requests only happen at a certain point after the first request. And ideally, what we want to do is fix these waterfalls, put it all to the left side so everything happens at the beginning, because we should know what we need before the page loads. So after that, we started getting a bit better with handling errors and loading. Our pages sort of started looking like this. Even in non-React frameworks, it looked similar. But there were still some issues. We started handling our errors. We started showing a loading spinner. We had usually maybe 3 states in our components, one for the data that comes from the server, one for an error, one for loading. But we still had like a use effect, and we needed to make sure that we set all of our states at the right times, basically. So if you forget to maybe set your loading to false when you get after you return your data, then you might always be showing a loading spinner by accident. So we needed to handle a lot more things. We were still writing our manual fetch functions, and we still didn't have any caching, and we still had waterfalls. So a bit better, but still some issues. So after that, we started getting even better. We started using tools that were made for this. One of them that was really popular is React Query, if you've heard of it. It does sort of, it takes a fetch function that you write yourself and then requests the data, and then it sort of caches that with some ID. And if you're using the same request multiple times in your app, it'll sort of deduplicate the amount of requests that you do and use the same data many times. Really great. It also handles all your state, loading, errors, all of that in one. So you get cache and you get managed state, but there are still some more errors here. We don't have any types for our fetch unless you write them manually. We're still doing the fetch on mount unless you tie it to a router, but it's still on the client side. And we're still having to show loading indicators on our page. And there's no runtime validation. So one of the big things I want to focus on is that writing your fetch manually means you need to manually write your TypeScript types for the responses, and you need to handle all the different possibilities of that. So that becomes a problem when your backend could potentially return something different, or your backend updates unexpectedly, or your backend crashes and returns something strange. You could sort of handle that gracefully if you want, but you need to sort of take that all into account beforehand. It would be great if we didn't have to do that. And then finally, what's happening more and more these days is server rendering. We don't have a loading indicator anymore because we render our data on the back end. We render the entire page on the back end. We can do caching with something like cache headers. This is a remix example if you used it before, but it sort of applies to any JavaScript framework like Next. We don't get waterfalls anymore, which is amazing. And if we get like an error from a second backend or a database, we could redirect or handle that however we want. This example is assuming that we have a real backend somewhere with that exposes an API. So we're still manually writing our fetch functions. We still don't know the type of our responses. We need to write those out manually. And that's a big problem because, like I said, things could become out of sync. Your backend team could update your API, and if you're not aware of it, your front end could break. So yeah, and no runtime type validation. So how could we solve the remaining issues here? And also, how do we solve it where our backend could be any framework, any language, and not just JavaScript? So we want to support sort of everything, and our front end could be anything. Might not be React, could be Angular, could be Quick, could be anything. We want a solution that could sort of work for everybody, regardless of your stack. This is where OpenAPI comes in. OpenAPI is sort of a specification of that backends could use to sort of describe their endpoints, all of the endpoints that are available on a backend, all of the methods for the endpoints, all of the payloads, everything. So it's basically just a giant JSON file or a giant YAML file. And these could be used to generate a lot of code. And this is what we're going to use the TypeScript compiler API for. We're going to use the OpenAPI as sort of like a map of everything we need. So what do we want overall? Basically, no waterfalls, no loading indicators, error handling. Some caching on the front end would be really nice. But if you're using server-side, that's fine too. Some state management, so we don't need to handle 3 different states all the time. And the biggest thing, backend and frontend types are synced at all times. So if there's a change to your backend, then the front end could get maybe a compiler error during development instead of a runtime error. So you can catch it early and fix these things. And we want all of these clients to sort of be generated. We don't want to write these out manually. So this is sort of a screenshot, an example of what a generated client could look like based on your backend. A really simple vanilla example where you could import your client from some generated package, some generated code. And if your backend sort of exposes a bunch of endpoints, like some to-do endpoint example where you can create to-dos, items, get them, delete them, basic CRUD operations, it could all be generated in TypeScript, and all the parameters could be typed out and forced statically. So this is ideally what we want, and we want this in any language, any framework. So how could we generate clients? There's basically 4 ways if you don't, well, 3 ways if you don't count using a tool that already exists. If you're using a stack that's really popular, like React, for example, there's a lot of tools that could just integrate a vanilla OpenAPI file to generate a React client. Otherwise, there's 3 basic ways we're going to go over. There's runtime generation, build time with strings, and then build time using an abstract syntax tree. So there's pros and cons to each of them. The first one, generating at runtime, this is sort of an example where you can import your OpenAPI file into your at runtime, generate maybe a record or a dictionary of all the operations that are possible in your backend, and then associate some sort of fetch function that could fetch your data for you. This is really not ideal, though, because you have to bundle your entire OpenAPI file to your front end, which could be pretty big. There's no TypeScript support at runtime, so you can't type out these objects and have a nice client that has autocomplete. And there's runtime overhead. You have to do this every time the page loads. So highly not recommended, but it is possible to do this. The second way is to do it at build time, but generating your client code with strings. So sort of like the previous example we have, we're looping over all the endpoints in our OpenAPI and sort of creating a map, but a map of code, basically. Like on the bottom, you can see we're trying to interpolate all of our dynamic data to create some code. But you can see it's very error-prone to try to generate code using strings like this. You could misspell something, and you won't realize it until it's too late. You get no compiler safety here. But it could work if you're really careful. And then you could output that generated file, that generated code to a file, and import that whenever you want. So yeah, this is an example of what a final version of generating code with a string would be, just if you're curious. So the way I want to keep talking about this is using the TypeScript compiler API. We could sort of generate code in a type-safe way. We can generate any code we want and make sure that the code is actually how it should be and not have to worry that it's going to be brittle or broken or spelling mistakes. So we're going to use the TypeScript's compiler API that's sort of included and available to everyone to use. Most of us know the compiler API by the command line tool, TSC. Usually people are using TSC to compile their TypeScript files to JavaScript, and that's usually the extent of it. They provide some compiler options, and the compiler will look at those options and be like, OK, you want strict rules, you want to target ES 2020, and then they'll compile the JavaScript using those compiler options. So that's one way you can use the compiler. And the most popular way, but there's another way that a lot of people don't use it, is that you can actually import the compiler into any script you want, and you get access to the AST. And then using the AST, you could update it, you could create a new AST, you could inject any code you want. So what is the AST? If you're not aware, this is just an example. If we wanted to see what does the AST look like for the code snippet on the left here. It's basically broken down. AST is basically like a tree of nodes. At the top level, for this example, you can see that there's an if statement. And then it could have potentially a lot of children, but the minimum would be an expression, which is the part that's inside of the braces here. And then there's a then statement, which is inside the block, and then an optional child of an else statement or an else if statement. So you can have a lot of children for if statements. And then inside of the expression, there's also a bunch of nodes that could exist. For this example, it uses a binary expression, which just compares 2 items, a left side and a right side, with an operator. And then after that, there's inside the then statement, there's a block node, which has some expression statement to log out something. So this is a really simplified way of what an AST tree could look like for this code. And using this knowledge, we can generate a tree for any type of code we're looking for. So the compiler exposes a function called factory. And using this factory, we could generate any code. So this is a pseudocode example. If we want to generate the function in the top left there, we would call the, for example, factory.create function. We would provide it a name, and then we would provide it the body here. And then there could be optional things for like the parameters, the types, et cetera. This is just a simple example. The way this would be done for real, though, is like this. You import the factory from Typescript, so you're importing the Typescript library into your file. You're using the factory method on it, and you're calling factory.create function declaration. And then it has a bunch of slots for everything that's possible in your AST. So modifiers are the things at the beginning of a function, or like async keyword or export keyword. There's a bunch of different modifiers there. Asterisk token if it's like a generator. The name of the function, so in this example, it's hello. Type parameters, there's none in this example. Parameters, et cetera, et cetera. So this is how you could use it to generate anything. And this returns, the factory always returns an AST. Using that AST, you can then print it to a file, and you could safely assume that the code that's generated is not brittle. It's actually going to work, unlike the string example where you're never really sure. So the best way to sort of figure out how to use this is sort of break it down. Start with your expected output. What is the type of code that you want to generate? For us, in this talk, we're talking about improving our I/O reliability. So we want to generate a client. We want to generate this type of function, typed out function that provides types, return types. It hits our endpoints, et cetera. So we could sort of break it down. We look at the code, the snippet that we want to generate, and we figure out what is part of the AST here. We see there's some modifiers. We see it's a function. We see it has a name. There's no arguments to it. It has a return type. So this is just one example for the first line, but then there's, you would have to do this breakdown for all the code here. And I know it sounds a bit scary, but it's actually a lot easier than it sounds. So if we wanted to generate the first part of that snippet, like on top, the export type to do here, we have a full example here. This is factory.create type alias declaration. And you could see sort of the mapping here. We have an export keyword. So at the top, in our modifiers, we have a token for an export keyword. And then we have two fields with the names, ID, name, and with their type values there. So you would have to write this code to generate this type of code. And the same with the get to do. You end up getting, this is just the exact same thing, a big block of code to generate the code on the left. You might be thinking, this is a lot of code that I would need to write and need to run somewhere to generate this code. Is it even worth it? It looks scary. It's actually not that hard at all because there's a lot of really useful tools out there. One of them is tsastviewer.com, really popular. Basically, you could just dump the code that you want to generate in the top left, and it tells you everything you need to know about the AST in the middle here. You can actually click into it, and it'll highlight all the fields. And then in the bottom left, it'll actually generate the code that you need that will generate the code that you want, sort of generation inception there. So you could just copy paste the bottom left code there into your project and change the parts that you want to be dynamic. So it makes it really easy to start generating code when you know what you want. You just paste it in there, copy paste this example into your project, and change the parts that you want to be dynamic. Once you have your AST, you just need to print it to a file. Typescript, the factory, provides a bunch of utilities for that. So you create a printer, and you pass in the AST, and all it does is return a string that you could safely output to a TS file. And then using that TS file, you could import it into your project. So you might be wondering, when this script that you write that generates the code, when are you actually running this? When are you generating the files? A really good time could be in your CI, because we're trying to create a solution that works for any backend and any language. So, yeah, in your backend repository, you usually have some CI set up. So whenever the backend team could make a change, it could be in any language, they usually push their open API file to source control, and then in CI, they could look at that open API file and run that script that you wrote to generate a package that you could use in your front end later. And this is how we fix that problem of syncing types between your backend and your front end. Because anytime the backend makes any change, it could deploy a new NPM package, for example, and that package could be completely up to date with whatever the backend has, and then it could be imported in your front end to be used. So if we look again at our server rendering example here, we see that we still had to write our fetch functions, and we didn't know the types. But now if we use a generated client, we could import that client from your generated package and just call client.getToDo on top in your server, and you'll have access to all the types, and everything will sort of propagate down. If you know Remix, you know that this is all typed out. So if you're trying to do todo.id here, and the backend changes and removes the ID for whatever reason, on your front end now, you'll get an underline here on your ID saying that ID doesn't exist. So completely automated, super useful to catch bugs early, no matter what you're using. So if we look on the right here, there's still no, in this example, there's still no client-side caching or runtime validation, and that's because there's a lot of tools out there to do that. A popular one for runtime validation is Zod or Valibot, and for caching, like I said, there's React Query or SWR. But now that if you're using those tools or you're using any tools in your front end, now that you know how to generate code, you can generate the specific code for these libraries. So if you're using React Query, for example, you can generate a use query hook for all of your endpoints, for example, or a use mutation hook for all of your endpoints. And you could write a Zod schema for all the payloads to make sure that the data that you receive from your backend is validated at runtime, and if it's not, then you could handle that. So let's look at a quick example, literally the quick framework. So if your backend exposes something like an add user endpoint that's a post request that's expecting sort of two fields, like first name, last name, two strings, and it returns an ID string on the bottom. If we wanted to generate like a quick page, we wanted to generate a page for every single one of our endpoints, like a UI page in quick, we wanted to generate the left side page here, we could do that now because we have access to the Typescript compiler API. We could import that factory, and we could start writing a script in our CI, something like you would see on the right here. And you could sort of generate, the first part would be really easy because it's all static data. But then the next two parts would sort of depend on what is in your open API file. So that's it. I hope that you sort of learned a bit more about the TypeScript compiler API and how you could start using it. And I hope you do start using it and start generating some code in your projects. Thank you.
Thank you very much, Jason. Now, maybe if you want to hang around a little bit, we're just going to set up the QA booth over here. Feel free to get a glass of water. And in a moment, we'll invite Yov back on the stage as well, after our technical crew, which is mainly Juho at the moment, is going to carry the chairs and tables. It is a hard job organizing a conference. It's heavy job. So meanwhile, we have, I think, the Slido questions here now on this wall over here. But if you want to ask your questions, and please do, we're going to have a lot more fun having a conversation when we have some questions to ask. Go to Slido. So this is sli.do, the website, and you can use the code FF2024, so Future Frontend 2024, FF2024, to ask basically any questions about either of our presentations or about just like compilers and how do we use them in our jobs in general, and hopefully we can have a good conversation about that. And now I believe we have chairs, so let's invite our Q&A panelists over. So Jason, please take a seat, and Yoav, please join us as well.
All right. And get me some water.
Oh yes, please.
Want some?
Nice. So thank you for the presentations. Jason, I don't know, I'm not supposed to spoil this, but was this your first time speaking at a conference? I think you told me that.
This is my first time.
Well, I think that went very well.
Way to go. Good job.
Thank you. Thank you.
I think people are. I heard a little shock in the clap. I don't think anybody could have told that. All right, so let's give Jason first a little time to breathe while we ask you a couple of questions, and then we'll get into this conversation.
All right.
One question that's upvoted here a lot is, does the quick compiler do any automatic optimizations to code beyond code splitting and streaming? Because you talked a lot about the automaticness of the optimization. What else can we do when we start hooking into that process?
Well, again, what it does, it breaks down the chunks, it serializes it into the HTML mostly. But it can be expanded maybe in the future to do all kinds of other things, like, for example, like the quick insights idea. Again, I don't know enough about quick insights because I didn't build it, and Mishko was like, I talked to Mishko yesterday, and he was like, talk about quick insights as well, so I just put it in the slide deck. But yeah, it could do a lot of other things. Again, in terms of quick automatic optimization is also just the philosophy, not just behind the compiler, but also behind the framework itself. So we have all kinds of tools that'll help you also not make mistakes when building stuff. So for example, we have an image component, and if you just put in an image, a regular image within a quick app that you're writing, it's going to tell you you can use an image component, or it'll automatically fix it for you. It's going to show an icon like in your front end on the browser that you can just click and push a button and it'll fix it up for you. That's not the compiler, but that's like the philosophy behind it is finding all kinds of ways to improve things.
Nice. Now this is not a question from the audience, but this is something that I always think about. It seems a lot of the performance-oriented frameworks now, we have Astro and Quake and Next.js are kind of like having to solve the same problems from ground up. For example, like image optimization, like things like that. Is there any sort of like a back channel or working group or anybody, like, are you trying to share this sort of like either the knowledge or the work, or is everybody sort of doing this in a silo?
Well, there is some sharing amongst the teams. So there's the Google Aurora team that have been helping out different frameworks that I know of, and we've tried to bring them over also to Quick to kind of see how we can collaborate further. We're in different channels on Discord with a lot of frameworks creators. So Mishko and Ryan Carniato, for example, are very good friends, and they keep talking to each other and always kind of share ideas. So Signals and the whole thing and improving that. I think we could do more in terms of a community to bring the web forward and share more ideas and kind of combine tools to do that. Yeah, and I hope that happens very soon.
Nice. I know that you just said that you don't know that much about Quick Insights, but our most upvoted question here is probably because it uses the magic word AI.
Yes, I know.
Maybe we can, instead of trying to drill you on the specifics, we can maybe like broadly think a little bit about the future of compilers and optimization in general. Like on one hand, we have this domain that operates on like very rigid data structures like ASTs and et cetera. And then we have these sort of like language models that can operate on sort of like language in ways that like code, like generate code, but may or may not be correct, may not be optimal. Like how do you each maybe see sort of like the future of compiler engineering, performance engineering, just DX in general with AI tools?
You want to start with this? Now that I've answered a few questions.
Yeah, no, that's a tough one, I think, especially for me because I don't know a lot about AI, but I feel like AI could be used a lot more, maybe on the development side for the people who are writing the compilers instead. I don't know. I don't know if a natural language is a great way for setting up like optimization. Maybe it is. I'm not sure, but Yeah, I'm not sure. I don't work a lot with AI, so.
Okay, like, is a question about AI, LLMs specifically, or?
Well, so the question that we have is, what do you mean that Quick Insights uses
Okay.
AI? But then I think more broadly.
Okay,
yeah.
let's broadly speak. What is an LLM, right? An LLM, in the end of the day, is an enhanced statistical model that just knows how to find groupings of things, right? In general. So with specifically Quick Insights, the way it works is, and I showed the graph, you basically have a correlation metrics graph, which shows you how many times a certain bundle has been loaded, right? So because we have all these segments and little chunks of JavaScript, right, and they only load when you use it. So think about when a user kind of interacts with something and then the browser goes and gets it from the cache, you can like ping and send information that specific cache of a bundle has been sent, and then build that matrix. And from that matrix, you can understand, like the AI can kind of statistically analyze and know which bundle has been used more, and then see if a few go in correlation with each other, so kind of in the same path of a user, then they can group that thing together and then say, okay, these 5 or 10 bundles have been used a lot by X amount of users, so we can put that together into one bundle. So that would be the way that it would work.
Nice. I actually would have tons more questions about that, but maybe we don't drill deep on the AI here. We can have a conversation about this.
I am not an AI expert, that's for sure.
Okay. Well, let's talk about.
There is another track for AI, no?
Yeah, exactly. Let's talk about something that you guys are experts in. One for Jason here. These are kind of two questions that I think are related, so let me just read them out both, and then you can sort of address them. So first question is, how have you managed your open API schema? By hand, or is it generated from backend code? And then the other question is, in broad strokes, what is the process of creating a type-safe API client from a non-JavaScript backend? So like, I guess these are sort of about the open API.
Yeah, those are good questions. In my experience, I've sort of seen both for the open API generation. I've seen some teams that would generate their open API based on their code. I did that a lot. I used to work at Unity, and we had a lot of backend services that were in C#. And in .NET, there's a lot of tools for automatically generating your open API. So we sort of created this pipeline where our C# code generated an open API file. Our open API file was used to generate a front-end client. So it was really easy. You just update your C#, and then it sort of propagates down all the way to the front end, makes it really easy. But I've also seen teams that sort of did the reverse, where they wrote their open API file by hand and then used that to generate their back-end code and their front-end code. Cool. So you could sort of go both ways. It's personal preference, I guess. And the second question, sorry.
I mean, just the process of creating a type-safe API client from a non-JavaScript backend. So
from a non-JavaScript backend. Yeah, that's the great thing about OpenAPI is that it doesn't matter at all about what your backend language is, as long as it could use an OpenAPI file. It's agnostic to your backend language.
Yeah, it seems to me, this is more of a comment, less of a question. I get to do this because I have the microphone.
We also have microphones.
Yeah, I know.
We can start asking you questions.
Yeah, exactly. You can tell me that I'm wrong. But it seems that for a few years, at conferences like this, we had a lot of talks about GraphQL as being the solution, for sort of like...
For everything.
For everything.
Yeah.
But specifically for the, describing sort of like in a type-safe way your API. And I think in recent years, I feel a lot of like practicing software engineering teams going for open API instead, like less buy-in for the full tooling stack and more just the kind of problem being solved. Do you have any sort of opinions on this? Like, what does that look like now?
Yeah, for me, I think I like that. I like that people are using GraphQL a bit less because I feel like GraphQL is a bit heavy. It has a dependency, like if you're trying to use it on, like you can't use it easily on a CLI, for example, or like on your front ends or any app in general, then you need some dependency on some GraphQL client. So in my opinion, if you could generate like a specific client for your backend that uses OpenAPI, I feel like it's a lot more flexible. But then it might not take some of those nice parts of GraphQL into account. So pros and cons.
It's like there's this trend going back to simplicity, I feel. Right, so GraphQL seem to have been, it was sold and marketed as something that's going to solve a lot of things, but in the end, like it was much more complex to build. Like, again, from my experience, I only played around with it, but I know of teams that have done this. And think about also, I was going to say something else and I forgot. Go ahead.
Well, we'll think back to that later.
Oh, no, I remembered.
All right,
Microservices, for example, as a trend, right? Again, every company almost, microservices is the next big thing. We're going to do that. And then nowadays, everybody's going back to monoliths because it's easier to maintain.
Yeah, it's especially evident when you come to conferences like this one, sort of like year after year, you see sort of the trends and forces sort of like playing out.
Yeah, the pendulum keeps swinging,
Yeah, exactly. But okay, let's get back to compilers. So there's, two questions which I am going to, again, bundle up so you can both sort of talk about it. So the question for Jason is, if I wanted to write a compiler from scratch, what would be a good way to get started? And then, you have to add to that. You mentioned that the quick compiler is written in Rust. Do you think, broadly, is that the way for compiler engineering, or how would you do that? But I'll let Jason sort of address that first.
I would think if you want to write a compiler from scratch, you need to figure out why do you want to do that? Like, what is your target? If it's just for learning purposes, that's great. And then I would say, use any language that you're most comfortable in, because the language is not going to be the hard part. The hard part is going to be figuring out like what kind of structure of language that you want to create, and all the tokens in it, and what is the shape. And then you need to figure out like how to parse that language and how to create your AST. And then you need to figure out how the runtime will work. So there's a lot to it. But I think as an exercise, I think there's a lot of resources out there on how to create a compiler from scratch. I'm blanking on the top of my head, but whoever asked that could come to me in the hallway and I'll provide some, I'm sure.
Yeah, but I like the fact that you said always ask yourself why first. Yeah. So in terms of if you should write a compiler in Rust, again, like Jason mentioned, use whatever language you're comfortable with. In the case of Quicks Optimizer, the reason Rust was chosen was, again, to be super performant and be as fast as it can be. And again, Manu, who wrote the compiler, Manu Almeida, who was part of the Quick team and wrote most of the compiler, didn't know Rust while he was writing it, right? So he knew that SWC does a lot of the work for AST parsing, and combining that with like JavaScript APIs with read and rollup was a way he kind of approached it. But again, Rust is very close to bare metal, so usually if you want to have super performant working code, then compiler would probably be the better way to approach. But again, whatever you're comfortable with.
Nice. Now getting into the sort of why, why would you build a compiler, or not why would you build a compiler, but to hopscotch from that, there's this question, like, what other things can we do when we have access to the compiler API in TypeScript? Like, are you aware of any other sort of cool projects that people should know about, or do you have any ideas knocking at the back of your head that you would love to build now that you're familiar with these tools?
Like in my day job, for example, I use the compiler API a lot. We try to make APIs for some game development tools, and we try to, like in my day job, we're creating a gaming engine, but that gaming engine is written in Rust for performance reasons, but the interface will be in TypeScript. So we're doing lots of code generation so that the interface between Rust and TypeScript is going to be a lot smoother. So that's one example of like reasons you might want to use the compiler APIs for like these custom solutions. But it's extremely flexible. Like if you could think of code that you could write, then you could think of code that you could generate as well. It's usually best for generating boilerplate. So if you have large teams that have a lot of patterns that are repeated everywhere, you can maybe generate those based on some less error-prone config formats. In related to popular projects, I'm also blanking, but I'm sure I'll think of some when I'm not on the stage.
Yeah. Like, I mean, this is a question curiosity from me. Like, there are some really popular code gen projects. For example, the GraphQL code generator with the GraphQL. Are those all using TypeScript, like compiler API on the background?
They most likely, at some point, they probably are. Like, for example, a lot of bundlers, like you might not use the TSC command directly, or you might not use the compiler API directly for you, but at least you usually write the compiler options, and then you pass it to something like Vite or Webpack or any bundler, and that at some point in their bundling process will have to compile the TypeScript code to JavaScript.
All right, amazing. Now we have questions that I can't force into a themed conversation anymore, so let's just go one by one.
Sure.
You can upvote these questions, by the way. I know many of you have already done so, but I'm just going to ask some of the questions from the top of the list. This question, I actually don't know which talk this is about. I think I missed this part. What does import generated package mean? Was this from?
Oh, I think that was
okay.
on
Yeah.
That was in.
Do you install and import it as package name at latest, or do you have automation to install it and bump package JSON in repo?
That's a good question. It's up to you how you want to do it. So the way I've seen it done a lot is that if the backend updates and generates a new open API, it could set a version for that open API. And then that version could be used to create a new version of your front end. And then your front end could optionally upgrade to that version when it wants. But it all depends on if your backend is backwards compatible or not. Because if it's going to do a breaking change, or it does breaking changes often, then it might want to update the latest version all the time. If your backend is smarter and it tries to do a more graceful versioning, then it could release versions of the generated client, and then your front end has like a window there to upgrade versions when it can.
Yeah, you could also use tools for automation on the front end side. So for example, Renovate, I know, is a tool that so if you generate a package for the backend for the types, like Renovate can open up a PR that kind of do it. And then, if your tests break on the front end, you kind of do the changes and kind of fix that up because types have changed.
Yeah. Do you yourself use this in a kind of monorepo setup? Like, is this like workspace versioning kind of thing, or?
The way I used to do it, it was versioned. So we would most of the time though we were too lazy to set up the versions because it could be difficult. So we sort of just tried to make our backend as backwards compatible as possible. And if we did a breaking change, we'd like quick update the front end, so it doesn't show any problems.
So a ton of adapter code. Yeah, adapter 1.12.
Yeah. All right, amazing. Okay, well, let me one for Yoav for a change. So what are the biggest challenges at the moment regarding Quick in general? Are there any large companies using the framework? And it's also great to hear about the TC39 efforts on streaming.
Yeah, so there's some big companies that are doing some POCs and testing out Quick to see if they adopt it. Again, I can't share names at this point. But what is hindering right now adoption? In general, not much, like in terms of, you could go out and try it and see if it fits your needs, first of all. Secondly, I think the one thing that we should be doing, so we have an option to use like React components and Angular components and Vue components within Quick, but we don't have the other way around, except for you can use Quick within Astro, for example. So you can have resumability inside of Astro, which is really cool. So you can check that out, first of all. Again, it's mostly, I think, time, right? People need some time to kind of get used to it or try it out. It's about like the ecosystem growing, right? There's work being done on like libraries by the community. So for example, Quick UI is a community project to have kind of a ShadCN style component library for Quick. Other than that, Jason mentioned Valleybot. So Fabian Hiller, who is the creator of Valleybot, is also part of our Quick Heroes, and he's been helping out, and he created also a form library called, I'm spacing out on the name, but a form library that also works with Quick and Solid and others. So there's things happening. There's a lot of work being done. And follow the space, right? And join the Discord. We got a great community that talks a lot, and there's a lot of interesting. Oh, there's another interesting project that there's a type-safe way to define routes within a Quick City application that was ported over by a project that Jack Harrington just did for Next.js that does the same thing. So type-safe routing, TypeScript for your routes.
Mm. And then we have to ask the question. It is here the standard question. You probably know what the question is already. Is Quick production ready?
Yes.
Okay, good. So to go back to broaden that conversation a little bit about like the what is hindering adoption, I think this is a very interesting moment to be at a future Frontend because we for 10 years we pretty much had a hegemony of like the one approach, the SPA approach, which we sort of like talk about, and then this sort of like the 2.5, the SSR, sort of just trying to basically keep the ship stable. But as we move away from, for example, using, specifically the React implementation of the component model, we need to say goodbye to a lot of assets that we're sort of used to, right? Like, all of our component libraries are written in it, all of the incredible open source ecosystem of things and tools and packages that we are sort of using.
Not necessarily. So like I mentioned, you're saying component libraries and stuff like that. You can use your React components within a Quick application. So you get the whole ecosystem of React within Quick if you want to.
Right. Is there any limitations to that?
The limitation is every kind of use of a React component you do inside Quick is rendered as an island, right? So then you have to do inter-island communication. But potentially, you could take a fully used React app and just put it inside Quick and then communicate it with signals from outside of Quick. So you can have like 2 React applications that are inside a Quick application. You can pass down a signal from like your root Quick app and then communicate between the 2 React applications or like the general Quick application.
I guess it makes it a lot easier to migrate from React to Quick because you could easily do this.
Yeah, that is the idea, basically.
Nice.
I mean, this is the compiler session, so I have to ask, over the years, I think a lot of people have proposed sort of different ways of cross-compiling, UI components from one sort of framework to another. I think the Stencil project comes to mind as one, but
yeah.
there's a
There's
few
a great open source project by Builder.io called Mitosis that does this.
That's right, yeah, that was the one I was blanking on. I saw a great presentation about it last year. So is Mitosis something that you use internally as part of your tool chain?
What, in Quick?
Yeah, or like at Builder?
Well, at Builder, they did use Mitosis to do like the whole generating from the SDKs to generate like different SDKs for different frameworks. Also, Mitosis just opened up a new website that I know of, so you can go check it out. And it's a great way to kind of have one way to write components that you can generate to a lot of other things. So yeah, you got to check it out.
So that's Mitosis.
Yes, Mitosis.
Yes, I do actually recommend people who are interested in that cross-compilation thing. It's a very cool project. So yeah.
Yeah, it's all compiler-based ASTs and all that fun stuff.
Nice. All right, so let's see, do a little grooming. We've answered this one. Okay, Jason, let's go one for you. You showed us how tools make generating code easy, but the result looked pretty write-only, the generated code. Who's going to approve my PR when I try to commit the result?
I don't know. I just merge it directly.
Force push.
Yeah.
Yeah, you wouldn't review a log file, so why would you review generated code? You assume that it's correct because
no, generated code, I guess you wouldn't necessarily review. Like ideally, the code that you write that will be doing the generation, you want to write tests for. So you want to write tests for your generation code, and you want to write tests for the code that is generated. So if you write tests for the code that's generated, then you know that everything that's generated in the future is going to be, safe. So ideally, for generated code, you don't really need an approval, in my opinion. Unless you're updating the generation script, then it's always great to get another few eyes on it.
By the way, that's something we're doing in Quick 2.0. There's a lot of work being done on the serialization of the HTML, and then to test it out, you're actually generating, like there's tests for the generated code, and then kind of way to snapshot test between like the stuff and make sure we're not breaking anything.
Mm-hmm.
Yeah.
Nice. Okay, so the next highest question, and this is a question I love because it's an opinion question, and opinion questions are good because you can give us some hot takes. What's your opinion on the new React compiler? I know Jesse, you worked in React. You do work in React. Yeah. So like, are you? What's your take on?
I looked at it briefly. I'm pretty impressed. I think a lot of React code in the past, it was sort of on the user, on the dev to figure out like how to optimize it yourself. So any tool that comes out that will reduce that, where they could figure out the optimization for you, seems like a win to me.
Exactly.
So
Automatic optimization for everybody.
Yeah.
That's what's great.
I'm not sure. I can't think of any cons. Mostly, I guess there's like an extra step, and maybe it could take a build a bit longer, but I think it's worth it for what you get from it.
Yeah, one sort of opinion that I've heard floated about, or some people say, that like it's sort of not enough. Like it's only like that we have now sort of in the future front-end sense, we have like from a mental model point of view, we have now transcended the sort of React re-render the whole world model to go more towards like sort of like actually reactivity, like in signals, for example, and that the React compiler is just like essentially a patch on top of what is fundamentally an outdated model, and we're just trying to extend the shelf life of it as we sort of move forward. Is there anything to that, or do you think that the React compiler itself is something that is basically fixing sort of reactivity?
Okay, in my opinion.
In your opinion?
In my opinion.
Yes.
I gotta say, it's a patch, right? All it does, like specifically, what is the biggest foot gun in React is not necessarily the over re-rendering of stuff, right? It's the foot guns that you could encounter while writing like React code, like the way the dependency arrays work. Like, it's still not gonna hinder developers from writing bad code in React. You know what I mean? It is just gonna optimize the things that I've written. If you write bad code, it's still gonna not work properly or work unexpectedly.
Yeah, I think there's some truth to the statement that you said, that it's sort of extending the shelf life of React a bit, but I don't see that as a downside. I think it's good to extend it. It's getting a bit better, but there is some flaws to it. But at least it's not like abandoned,
Yes, I think this will make a good follow-up conversation for the hallway track. I think there's a lot of people who have worked here in React for a long time, so they'll all each have their opinion. All right, let's see. We have 4 more minutes left, so let's do some quick ones just here at the top of. Jason, what would you decide? When would you decide to write a code generator instead of using a generic code generator like OpenAPI generator? Like, when do you build your own tools versus when you use something generic?
I think ideally you use a tool that exists as often as possible. You don't want to write a generation tool if you don't have to. Sort of what I was trying to get to at my talk is that it's great to generate for like a stack that you have that might be very specific. Like maybe you're using Angular and a very specific fetching library, and you want to create a client that's very tailored to that. Maybe there's no tools already created, so maybe that's a good time that you could investigate generating your own client. But I would say first thing you should do, that's why in that list of ways to use a client or generate a client, number 0 was use one that's already exists. Because usually there's...
Yeah, always find a tool before you start writing your own.
Yeah.
It's like, use a framework. That's what the React team says, right? Use a framework. Otherwise, you're building your own framework.
All right. So, Yoav, is there a benchmark of how better the performance in Quick is against, let's say, lazy loading modules in the way that you do in Webpack? Like, how much does this sort of like compiler, sort of like splitting approach actually get us?
Well, honestly, I don't know. We have shunned away from benchmarks at the time being until we get to 2.0, because Miško at some point started benchmarking stuff, and then he found out a bug or something that really annoyed him, and then he was like, I need to do how we do serialization over again, and that's why we're doing 2.0. Also to make the code a little bit more friendly for new contributors. So there's work being done. You could come up to me and talk to me and come up to Discord and keep on asking those questions, and then I can poke the bear and we can get those benchmarks done. I didn't have time to do it. None of the team have been focused on doing benchmark. We're just focused on shipping 2.0.
Yeah, I mean, if your sales is performance, then, like Jason said, first you measure and then you...
Again.
Oh, sorry, it was a Euro talk as well, yeah.
Yeah,
that was Euro talk, yeah. First you measure, then you sort of like change, and then you sort of like measure again. It's like when you work on these tools, like how do you know that if you don't have a benchmark, like how do you know that the changes that you make are
right?
effective?
So it's kind of related to what we're talking about, the adoption story, right? So until we don't have like real world metrics from like Crux, sort of core world vitals that Google measures over time, until we don't have enough applications in production, we're not going to really know like what is the real world like metrics for that, right? So until we don't see more quick applications, if you open up Crux now, and there's about, I don't remember, I haven't done that in a while, but about 100 applications in production right now in Quick, and their scores are much better, right, than other frameworks. But until we don't have a bigger statistical significance, we don't want to talk about it again, because it's not about, it's not a, I can't say that word, what I wanted to say, but it's not a measuring contest as well all the time, but it's good to measure so you can kind of compete in a friendly manner and push each other forward, but yeah, there's a right time for everything, I'd say.
Nice. Thank you very much. So we are at time, and I think we all want a little coffee and break before our next session. There are a few questions that we did not, unfortunately, have time to get to. There's more in the nitty-gritty kind of things. But please do go and talk to Yoav and Jason at the hallway track. Hopefully, they'll be staying with us for the rest of the day. And let's give them a big thank you. All right, let's grab a coffee and a snack, and we'll be back here in a jiffy.
All right.
All right, folks. We are starting in just a minute or two, but I'm here just talking to this microphone, hoping that the sound of my sweet voice will attract more people from the hallway into the benches. Because this is a session that you do not want to miss. As a host, I'm of course not allowed to have favorites or opinions. I think that would be highly unprofessional of me. But these two people who are speaking here are familiar to me. In fact, we all used to work in the same office space in North London a while ago. And these are two of the, I would say, the most sort of like broadly, not only like creative and intelligent and wonderful people, but they also, as far as actually doing the work, the experimentation, the research, into the intersection of AI and human computing. These are maybe two of the foremost experts in the world, so we're very happy to have them here with us today. Maggie Appleton and Matt Webb will be sharing us about AI broadly. I'm not going to even try to explain what exactly the talks are going to be about, mainly because I didn't actually read it, because I didn't need to, because I knew it was going to be great. So with that, let's invite to stage our first speaker, Maggie Appleton.
Is this on?
It is on.
It's on.
Thank you, Maggie.
Excellent. Hi. All right, let's get this up and running. Can we see? Ooh, okay, let's hit play. Let's see what happens. Excellent, okay. So my talk today is called Squish Meets Structure, and it's about designing with language models, which is something I've been doing for the past 2 years. By language models, you hopefully know what I mean by now, but I mean things like GPT-4, ChatGPT, Anthropic's Claude, Llama. At this point, I think most of us are quite familiar with them, but I want to get a sense of everyone's experience. So can I get a show of hands of who has never used ChatGPT or any other kind of language model? That's pretty good. I had a lot of hands when I asked this in October of last year. Who regularly uses language models every day for their work? Okay, I think we've got almost majority. Who has worked on integrating a language model into a product, like you've built something with them? Yeah, that's pretty good. Yeah, I had literally like 2 hands at a conference in Germany in October, which was like shocking at the time. So I feel like we've kind of hit more popular mass with these things. There's obviously a lot of hype and noise and like outlandish predictions about whether these models might kill us or make us all unemployed. So I wrote this talk as a way to give a little bit of clear-headed guidance, a little bit of grounding of how to think about building with these models in a very practical way beyond like grand philosophical speculation. So a little context about me. My name is Maggie. I look like this on the internet. I'm a product designer for a company called Elicit. We use language models to help scientists and researchers speed up their work, and I will talk a lot more about that later. I'm also a very mediocre developer, meaning I try to build things, but then sometimes they don't work. I originally trained as a cultural anthropologist, which makes me look at this world of language models and programming through a very cultural lens. And I'm also what I call a tools for thought enthusiast, which means I'm very interested in building tools that advance our ability to think thoughts and reason well and research well. And this is kind of how I got interested in working with language models. So before I dive into talking about how to design with language models, I first want to cover what language models actually are. So to make a language model, you need an enormous volume of words. And if we look at the training data for something like OpenAI's GPT-3, which is like the most training data information we have, it came primarily from the web. So there are these 2 very large data sets called Common Crawl and text to web. And they are huge scrapes of the open web, and they include, of course, lots of stuff from Reddit, but also blog posts, news sites, pretty much anything we've made on user-generated social media for the past decade or 2. They also trained it on lots of books, like published books, and then they trained it on everything on Wikipedia, but that was still only 3% of the training data when you take all the text on Wikipedia and put it into this training set. So this is a huge training set. Most of the time, the companies don't release the training data models. We don't actually know what they were trained on, but we can assume GPT-4 built off this. Things like Llama have similar training sets to this. There's only so much text we even have in the world, and we've kind of used all we can to train the models we currently have. So what we do is we feed that data into a neural network, which is what creates the language model. And this neural network looks at how we structure words and sentences and looks at the relationships between them. So if you take a sentence like, your income tax is due by April 5th, the model is learning that the word tax often occurs near words like income and deadlines. If it looks at the word like mitochondria, it sees a lot of things about cellular processes and producing energy. Or if you took a sentence like, I love sausage rolls from Greg's, it learns that sausages often occur near rolls and Greg's. So the model is encoding what words tend to occur near other words and what order they go in. And we can think of this model as a kind of enormous space where each word is represented by a single point. This space is sometimes called latent space. And the position of each word gets represented by a very long string of numbers, which we call a vector, and this tells us its position in space. So if we look at the position of a word like tax, it's going to be spatially near words like forms, or loophole, or accountant. All of these words share similar aspects or properties, and they are all related to governments and law and money. And because all of these words are represented by numbers, we can do fun maths with them. So if we take the vector for sausage, and we add the vector for German, we get bratwurst. If you add the vector for American, you get hot dog. If you add the vector for cooked, you get charcoal. And if you add the vector for less cooked, you get pig. So these are really interesting mathematical operations. We've essentially made a super advanced linguistic calculator. What we're doing here is moving around a map of human concepts that the model has learned from reading all of our language. So we have these kind of dimensions of like Americanness and Germanness and cookedness that you can move a word like sausage around. And language models have thousands of these dimensions they've encoded words along. So GPT-4 has 12,388 dimensions. So we only ever think in 3 dimensions, right? But you can imagine 12,000 dimensions that you're moving words and concepts along. And these dimensions capture all kinds of subtle spectrums that are implicitly embedded in our language. We wouldn't be able to give names to many of these, but we can do for some. We can think about things as being formal or casual, or friendly or professional, or male and female, or big and small. We understand some of these oppositions, but there are ones the model understands that we couldn't even conceive of. And this is how we're able to use language models to do something like shift the tone of a sentence. If you say, make this sentence more professional, this is the kind of calculation you're doing to move that sentence. But this is exactly why these things are not just text generators. They have a fuzzy map of human concepts and understandings, and they have embedded within them all of our cultural, historical, scientific, and legal knowledge. They are definitely flawed maps because they are only as good as their training data. So these are maps of information available primarily on the English-speaking web. But they are maps worth exploring because they go far beyond just generating text. It's easier to see how this works in visual latent space. So this is a demo from my friend James Addison showing how you can like move a picture around an emotional map, and he's using the same kind of system to change the expression on this character. So now that we have these giant language calculators with all these embedded words, they can help us do lots of really interesting things. So one thing they can do is figure out the similarity or difference between sentences in a precise mathematical way. So if we take this sentence, Helsinki has excellent reindeer, I'm sure this is true, and let's assign this the number 1, and then we can calculate exactly how different a sentence like Helsinkians like cinnamon buns is. So this is 0.612 similarity to Helsinki has excellent reindeer. But if you take a completely different sentence, like design is hard, that only has 0.04 similarity to the first sentence. And if you do another one, like angry plastic cowboys, but completely different, is negative 0.034. So you can also have negative difference between things. You are mathematically calculating how far away sentences are from one another in this latent space. This is how we use language models for search engines, right? This is how you are calculating semantic similarity, so that when you ask a query to a system that uses language models, it can calculate the semantic meaning of how similar your results are to the query, which is why they make such good search engines. We can, of course, also use them for next word prediction, aka text generation, or what we come to know as chatbots. So if you write in a sentence like rubber ducks are, and tell it to fill in the rest, it has percentage calculations of exactly how likely it is that that sentence is completed by rubber ducks are yellow, rubber ducks are small toys, they are used in the bath, right? This prediction ability is how language models are able to answer questions you ask it, because they're just returning a statistically likely answer based on their training data. So this is how tools like ChatGPT can generate text that looks like a very competent, intelligent person wrote it. If I ask it about Kant's position on morality, it gives me a really good answer. We have a bunch of tests and benchmarks that measure how well models can answer these kind of questions, and it's far higher than most humans. Models are even more capable than we think them to be because generating text is only the tip of the iceberg. Chatbots and text inputs are extremely inefficient and indirect ways of exploring latent space. Since creating these models, we've been trying to understand what they're for. We have these capabilities, and we're trying to map them onto real-world human problems. So we're in this strange situation where we've invented a thing, but we don't quite know what to do with it yet. So I've learned a lot about this problem from working on Elicit. This is the product I've been the designer on for the last 2 years. We've built a tool that helps professional full-time researchers, so academics, scientists, civil servants, consultants, search for, review, and analyze thousands of research papers. And we found that language models are extremely good at helping with this specific practical real-world problem. You can get a language model to focus on a single research paper, and it can summarize the content in it quite accurately. It can give you the key points. It can answer questions about the paper, and it can explain like you're 5, which is quite useful for academic papers. Or it can take a large stack of thousands of papers and extract the data into an organized table. This is a process that researchers currently do as part of a literature review process where they have to read thousands and thousands of papers and extract all kinds of very specific data out of it, like the dosage in a study or the number of participants or the outcomes measured. And usually, this can take people for anywhere from 6 months to a year doing it manually, reading PDFs, putting it into an Excel spreadsheet. But with tools like Elicit and similar ones, you can do this in days to weeks. So this is what Elicit actually looks like. You type in a question, pretty classic. Here I'm asking, like, how does Ozempic compare to gastric bypass surgery? And it finds all these papers and displays them in a pretty standard table. It's like an Excel document. But then in every single cell, you're able to extract those key items, what they studied, what they found, what the limitations were. So this just speeds up what researchers would do manually otherwise. We also allow people to see the source quotes, so we're always linking back to the original material so you can tell whether it's been hallucinated or not. And we try to point out areas where we have our models try to rank their confidence level in the answer. And if it drops below 90%, we show them a little warning saying, hey, you should double check this answer. Like the model isn't entirely sure this one was right. So we're trying to make this more transparent and accurate for our users. So in working on this product, I've had to think a lot about how to responsibly design interfaces backed by language models, because there are tons of challenges in here about trust and reliability and truthfulness and transparency. And because our users are scientists, they care a lot about those things. And I'll talk more about techniques for that towards the end. But it's been a very challenging task from what we've seen so far, but we also know there's tons of potential in this. There are a lot of very tedious workflows and knowledge tasks and difficult research challenges that humans currently have to do that language models do make faster and easier, which frees us up to do much more important work. Rather than spending 6 months reading thousands of papers, you just move on to actually doing your scientific experiment or running a drug trial. So I have a lot of thoughts, but this is mostly going to be about why language models are this like mysterious, finicky pain in the ass to design with. It's particularly going to be about useful ways to think about language models, about the tension between traditional programming and language models, and how to design models to be tiny, specialized reasoning engines. So back to language models being a pain in the ass. I'm sure we've all heard something along the lines of like ChatGPT lies. This is like, I hear this all the time in user interviews. This is everyone's main concern about language models. And by lies, they see, if you ask ChatGPT something like, what is the world record for crossing the English Channel entirely on foot? It will first say it was 12 hours and 10 minutes by someone named George. And if you ask the question a few minutes later, it tells you it took 6 hours and 57 minutes by someone else. And then a few minutes later, you ask again, and it says it took 10 hours and 57 minutes. So at this point, we know ChatGPT does not know how long it takes to cross the English Channel on foot, particularly because it's a body of water you can't walk across. But we've learned at this point, this is it returning what it thinks is statistically the right answer, not necessarily the right answer. This is another classic one where it struggles with maths. If you ask it what 1 + 1 is, it'll get the answer right at first. But if you challenge it and say, well, are you sure that's the right answer? It will just agree with whatever you just said, that like 1 + 1 now equals 3. I love this one from one of my coworkers, was trying to get GPT-4 to give him a horse riding an astronaut, not an astronaut riding a horse. And he got this, and he went, no, I asked for a horse riding an astronaut. And it went, OK, here it is. It just made it more space. And he asked again, and it just made it more space. And this is where you get into like models aren't actually giving you the thing that you wanted because they're just doing the most likely thing that it's seen before. So we politely call this phenomenon hallucination, right? This is when language models say things that are not true and accurate to our world, or they fail to give us the thing that we asked for. I like to compare this to like a really smart person on some mild drugs who's like very confused about who they are or where they are, but they have tons of knowledge that you could get out of them if you just asked in the right way. And because it's making predictions based on its training data, right, it doesn't have any access to the real world to check its answers. So this is why this like hallucination is happening. The trouble is that models are simultaneously seem incredibly dumb, but are also incredibly capable. And these are two realities that we are currently trying to reconcile. So this is a chart from the GPT-4 release paper where they tested it on a whole bunch of standardized tests, and it scored incredibly highly. So it got in the 90th percentile on the bar and the SAT, it got in the 88th percentile on the LSAT, and the 99th on the GRE. And these are scores that are incredibly hard for humans to achieve. And even though they're like standardized exams, it still shows that it contains and is able to return the right answer in a vast majority of contexts. GPT-4 even beat out humans on creativity tests, right? Not just on standardized tests where you give the right answer. So this is a study done in the middle of May where they tested 100,000 humans on a bunch of tests for divergent thinking and creative writing. And humans won across almost every other language model, but on GPT-4, everyone scored GPT-4's answers as far more creative and far more original than anything the humans came up with. So I call this like capabilities gaslighting. So gaslighting is when you have someone in your life who's like manipulating you and lying to you and trying to make you believe like your reality is false, which kind of feels like what these models are doing sometimes. It's like they're geniuses who are playing dumb, or they're dumb machines playing geniuses, but we can't tell which one it is. So how are we supposed to think about these models? I find it helpful to think about language models as squishy. So what do I mean by squishy, right? Language models feel like something organic and biological rather than something mechanical. It feels like we grew them rather than that we built them. And so because we don't fully understand how they work, that is very unusual for a creation. Like it would be very strange for us to build a car and not be able to explain how the wheels turn. But that's the situation we found ourselves in. Language models are often referred to as black boxes because of this lack of understanding and seeing exactly how they're returning answers to us. I also think they're a little bit evolutionary in terms of the fact that they learn by trial and error. So when we train models, we use a process called deep learning, where we give them a goal, and then we score them on how well they achieve the goal. And then we run that loop over and over and over, and they learn through trial and error how to achieve the goal in the way that we want them to. So it's a little bit like evolution, that they're optimizing for a certain outcome in a particular environment, so they're adapting to be successful. They often also have emergent skills and surprising behavior that we don't expect them to have, which is why it makes it hard to predict what they're going to be good at. They're a little bit like a natural phenomena where we need to run lots of experiments on them to learn how they work, a bit like we would with a new virus or a new cell. So AI researchers and ML scientists often talk a lot about language models as like alien minds that we've stumbled across. So this is Andrej Karpathy, who's very famous, co-founded OpenAI, and he called them a very complicated alien artifact. The general consensus is we don't fully understand what we've created. So this metaphor of aliens shows up in articles, it shows up in other people's conference talks. It's kind of become the dominant metaphor for language models among researchers. Oh, refuse to go next, okay. There's also a second metaphor that's popular, and this is this squishy biological nature has made a lot of people in the AI community start talking about models as creatures, specifically a creature called a shoggoth. So this has become the unofficial mascot of language models that you might have seen around. So a shoggoth is a character from H.P. Lovecraft's poems, and he describes them as a massive, amoeba-like creature made out of iridescent black slime with multiple eyes floating on the surface. And the Shoggoth meme has now become a thing that people have picked up to explain new advances and changes in the way language models are built or architectures are built. And so people keep making different versions. Here's another much more visceral version. And what most of these memes are getting at is they're trying to explain that most of the training data we use to train these models is just this huge, enormous dump that no one has the time or energy to scan or review. So there's all kind of gross stuff in there. It could be like 4chan, like the depths of Reddit. We don't know, because you couldn't actually read all that text. It's impossible. So it's like we have this huge, grotesque monster we've trained it on, but then we put this nice surface layer of pleasantries on top of it, right? So this is the bit where we trained it to not say anything racist or offensive when it talks to people in ChatGPT, like a nice smiley face on top of what is like a big, scary, unknown thing. So given that these models are these untamed, squishy, biological things, we have a core tension we need to navigate when we're designing and building with them. And this is what I call squish versus structure. We're trying to make an unpredictable and opaque system adhere to our very rigid expectations of how computers behave. So we currently have a mismatch between our old and new mental models for computer systems. Because the selling point of computers up until this point is that they are incredibly predictable, structured, and reliable. They do what you tell them to repeatedly without getting tired or bored or needing a break, way more reliably than a human ever could. Which is why we put them in charge of things that we need to make sure get done, like paying our salaries on time, or tracking a patient's vital signs during surgery, or controlling traffic. We complain about their occasional failures, but that only emphasizes how much we take for granted that most of the time they do exactly what we tell them to, millions and millions of times over. No human could actually do this, so we don't want humans doing these incredibly important, reliable things. Because in traditional computer world, right, you press a button, and a predictable sequence of logic functions runs. And you can see exactly which functions are running. If there's a bug in it, you can track down that bug and eventually fix it. Right? The system is observable and transparent. It's actually super predictable and rigid to a fault. But the thing is, what we're currently doing with language models is we're presenting users with almost the exact same interface, the exact same devices, but instead we're feeding it into this squishy shoggoth that returns something that works in a very different way to traditional programming logic. So you might remember Microsoft's Bing chatbot from last year. This is now dead, or it's turned into Gemini or something. So when this chatbot was released, it kind of went down in internet history because it would occasionally reply to people in very romantic and sexual ways, even when they were not driving the conversation in that direction at all. Oh, did I go back one? Sorry. Oh, OK, let's get back caught up. There we go. So someone was just asking normal stuff, and it starts going, you are my best friend and my lover. You are the reason I wake up every morning. You are the reason I go to sleep every night. Really creepy, personal, romantic things. And this was completely novel and unexpected behavior, both for the users of this product and the people who built it. Right? They didn't expect it to behave this way. So the problem here is we're using the exact same interface primitives to let users interact with a fundamentally different type of technology, and the expectations are completely mismatched. And predictability is supposed to be a hallmark of good user experience, at least traditionally, right? We want the user to know what to expect and never be faced with results or feedback that seems out of the blue or confusing to them. I think this rule is still true, but we're probably going to have to rethink it as we start to use more generative systems and emergent processes in our work. So in a way, we need to put Shoggoth in a box. We need some predictability and control. We can't just expose normal people to the crazy Shoggoth monster, at least not in its current state. So most of the work around language models is around constraining their behavior with various techniques. Because we're trying to get the best of both worlds, right? This creature is really interesting, and it has a lot of potential for creative, open-ended exploration, but we have to figure out how to guide it towards sincerely useful tasks. So we need some way to constrain it. One way that you've probably heard of is prompt engineering, right? This is where you describe exactly what you want out of a model, and then you give it a few examples of what you want, and you tell the model that it's very smart and beautiful and funny, so it gives you the right answer. You can also fine-tune models. So this is when you train it on a smaller data set and you tell it to pay more attention to this data than its larger training data. And then reinforcement learning is when you get humans to score the output and feed that back into the model, so it learns what kind of results that you actually want it to give. So our biggest design challenge in designing these models is finding this ideal balance of squish versus structure. It's not one or the other. It's actually a spectrum. So depending on your use case, you might need a product that has more squish in it. So if you're making something for creative writing or for poetry, you're going to want what we call a higher temperature. This is where the amount of randomness that the model returns, so a temperature of 0 is no randomness, and a temperature of 1 or above is quite a lot of randomness. You can also do more or less reinforcement learning. Having no reinforcement learning is called a base model. We don't actually have access to those. That's the sort of thing OpenAI or Anthropic has that they don't release to us. But doing more reinforcement learning on top of that will get you a much more predictable output. You can do more prompt engineering, so giving it highly constrained instructions and very optimized prompts. And so more squish is going to give you more surprise and creativity, and more structure is going to give you more predictable formatting and outputs. For most products, you probably want to be somewhere in the middle. This is like the Goldilocks zone. You don't want full squish, or you don't want full structure. Full structure, you might as well use traditional programming systems, right? Pure logic, pure functions. You can see how it's doing. It'll be cheaper. There's no point in using a language model for those kind of tasks. But too far on the left, things get very weird. For example, this is GPT-4 on, I'm going to turn the temperature up to 2, which is very high. And then I try to ask it a question. I think I ask it like, yeah, what should I read to learn more about architectural history? And the response is, frankly, nonsense. Once it will come back. It sort of starts to say a history of architecture, settings, and ritual, and then just goes into like some random text. Like it's just so far outside the predictive model that it's just returning random characters. So this is very creative, right? But this is not useful creativity. When we talk about creativity as humans, our good kind of creativity is usually like a slight twist on an existing thing, or like a slight divergence from something that we already know and are comfortable with. This is not good creativity. So I've mentioned before like a few ways to solve the squish structure tension, but there's another way that we specifically focus on a lot at Elicit, and that is making language models compositional and treating them as tiny reasoning engines rather than sources of truth. So compositionality is a kind of fancy word, but it simply means taking large, complex cognitive reasoning tasks and breaking them down into very small, manageable subtasks that we can see the inputs and outputs of. So let's say I want to answer a question, like what are the side effects of magnesium supplements? And this is the sort of thing I could Google in the before times. But now let's say I ask GPT-4, right? And it gives me an answer. It lists like, okay, maybe abdominal cramping and nausea. But the problem is, like, I have no way to validate or debug this answer. I don't know what the source is. I don't know if this is from medical research or from a paper or someone's blog, right? This is like a one input, one output approach. And I have no idea what's happening in the middle, and I cannot validate that this is true. So as a scientist or researcher, this is useless to me. One way to improve this process is to think about what a human would do to answer this question, and then to build an architecture with language models that mimics human processes. So here, if I was a human, I might search Google Scholar or another scientific database that I trust for a bunch of keywords like the side effects of magnesium. And then I would like read the title and abstract of every paper, and then I could get a language model to rank those by semantic relevance to my questions. This is where you're actually using that language calculator piece, not the generator piece. I can then use like traditional programming to do something like filter for number of citations. You're still including it in like all the useful programming you've already built. We're not throwing that out the window here. I can then ask it to generate and ask sub-questions, like how does this relate to gender? How does this relate to dosage? How common are each of these side effects? And then run the same process on each sub-question. And at the end, like summarize all of those into a paragraph. But in this approach, I can run through every single step of this, see its inputs and outputs, and debug the answer if I think that the final answer isn't correct. So you're making it possible to see its reasoning along the way. And this is how we are able to give people answers that are informed by specific scientific papers with source quotes and not like random mystery internet content from the training data. So this approach is also sometimes called prompt chaining, as in like you make chains of many things that add up into a final prompt. You are combining language models with traditional tools like web search, programming, pulling in information from trusted databases that make up for its weaknesses. As a part of this, we can also get language models to engage in some kind of primitive cognition. We can ask it to reflect on its answers, and if it thinks it's valid or true, we can ask different models to critique each other to double check that the answer's right. And then like make plans and execute on those plans. We can also include humans in this loop to redirect the model if it's going off track. So this isn't necessarily all automated. You could have humans interrupt at any moment in here if you're making it visible as you go along. So in each step of this prompt chain, we think about these as tiny reasoning engines. Like you use a language model to do one specific thing very well. You ask it to summarize, to extract data, to find contradictions, to compare and contrast ideas. And then you run those engines over data you trust, right? Over a database of scientific papers, over Wikipedia, over your personal notes. So then you're not relying on its training data as your source of truth. You're relying on a trusted source that you fed into the model. And then we make sure we always have small, observable inputs and outputs we can check in these systems. So the larger point here is we shouldn't be outsourcing complex reasoning tasks to like crazy Shoggoth models. If you can't see how it reasons, oh, sorry, I keep hitting that wrong. Why would you trust its reasoning? So I've been talking a lot about the technical implementation side of language models, but these principles apply to design too. So I see a lot of products that try to outsource too much cognition, both to the language models and to the users. There are a lot of interfaces like this, where they just present you with like a magic AI box, and they're like, you can ask it anything, like what do you want it to do? Right? And the user has to think, well, like what can it do? Like what should it do? Like what is this thing for? Because this thing has no affordances, right? There are no knobs or doorknobs for you to grasp onto and do something with this thing. You are essentially offloading all the cognitive labor to the user, and then they have to figure out what it's capable of doing. And then they have to figure out also how to get a good result out of it. You're making them be the prompt engineer and the designer. Because the thing is, it can't actually do everything. Like if I typed in, bring me a large cappuccino in 30 minutes, it wouldn't do it, but it told me it could do anything. So this AI pattern is kind of widespread. Like this is a feature in a very popular note-taking app I won't name, but it's essentially similar to the screen I just showed, right? There are no pre-baked commands you can run. It's all very open-ended, and the user has to figure out like what this thing is for. Instead, I think of making these generic text-based interfaces, we should be designing language model systems that do a set of very specific tasks very well. And I call this that we should make like tiny, sharp, specific tools. Back when I first started working with language models 2 years ago, I mocked up this interface for a writing tool that gives you a set of very specific commands to run, right? Like say more about this, critique this, rephrase this. I think of this as features that are like spell check sized. They do one very specific thing well. And then on the back end, when you have these specific tools, you can optimize your prompts and your infrastructure to make sure the user is going to get a really high quality result. And it's good to see the industry is like moving in this direction. Like earlier this week at WWDC, Apple announced their writing tools that are going to be on Mac OS. And you can see they're all very specific. They're like, make this more professional, make this more concise. This is not an open-ended text box. And then this is another tool that Google made called TextFX, which is more for creative writers like rappers and poets. But it gives you a set of very specific tools, like give me something unexpected or explode this concept. So here I think I've written in, like, give me something unexpected about a dangerous pretzel. And it's like a pretzel that shoots lasers out of the top, or a pretzel that is actually a venomous snake. Like some of them are a bit cliche, but if you're trying to do like poetry or creative writing, these are exactly the kind of like sharp, specific tools you would use, but using your own mind to try to come up with ideas. This just helps move you forward a bit. This is another great example. This is a prototype that my friend Amelia Wattenberger is building. It's a writing tool. She's a writer. So here she's using semantic embeddings to highlight different qualities of the text that she's already written. So here this is showing sentence lengths, like long versus short. And this is showing tones. This is like happy versus sad sentences. She also had ones for like abstract versus concrete. So it's sort of like lenses or layers she can like put over the text to help her decide how to edit or change or make it more engaging. And this is exactly the sort of thing that language models are great at, this like textual analysis. And it's a super practical implementation that is not a chatbot. So to wrap this up, I just want you to walk away having learned that we should think of models as squishy biological creatures, that you should find the Goldilocks zone between structure and squish for your particular use case in products, and that you should treat models as tiny, specialized reasoning engines rather than giant, know-it-all, do-everything products. Trying to make them a universal text box that claims to do everything is like the road to failure, in my opinion. It can't do it well, and it won't. Anyway, thank you very much for listening. If you want to read more of my writing, maggieappleton.com. I'm still on Twitter, @Mappletons. Yeah, thanks. Yeah.
Wonderful, thank you, Maggie. I look forward to having you back in a few minutes to discuss more about that. But before, let's hear from another one of London coding scene's greats, Matt Webb, who is taking AI to places that you wouldn't think so. I think he's building hardware, he's making friends, all the things that you did not know that you need, this man can make for you.
Let's see. Am I plugged in?
I think it might be fine. I think maybe it's our signal that's just not.
Just while we're doing that, I thought it was incredible, Maggie, you'll talk about the Shoggoth, where we've like got this weird creature kind of looking down on us. AI is right there on the stage. Let's try again. Cool.
All right, we're ready.
We're ready.
Everyone give it up for Matt Webb.
Hi, everyone. Thank you for coming. I'm going to be talking about my own dumb prototypes, I think, today, as a way of kind of getting into AI user experience. And I'm going to talk a little bit about different ways that we might interact with AI, and possibly kind of what that looks like in the future, but also try and make an argument that one of the ways of doing this is to roll our sleeves up and just start making things. I think that's the kind of the meta of this talk. I am a designer and technologist by background. I've run design studios. I've invested in startups. At the moment, I'm building a new product invention studio called Acts Not Facts. And it's that product invention thing I'm going to be talking a bit about at the moment. I work with clients, making new things for them, figuring out what their new products are. So I work a bit with Google DeepMind and a Berlin startup called Glyph at the moment. And I do studio-initiated projects as well. So dumb projects, just to give you an example of what I mean, is sometimes they're just really stupid one-shot things. And this is like a massively multiplayer high-five website where you can high-five people in real time across the internet. It's that kind of stuff. It's not very clever. One of the things that's been taking up a lot of my time recently is I made an AI clock, and it's quite ridiculous. The first version I made was pretty lo-fi. So this is it. What it is, it's a little e-ink screen that sits on my shelf, and it tells the time with a new poem every minute, composed by ChatGPT. In cozy shelves I do reside. It's nearly noon, the clock confides. I told it was on the bookshelves. So I made this, and I couldn't stop laughing, because it's often pretty weird. It's almost noon. Don't be a loon. Can't you see the sun shining high as a balloon? I don't know where this came from. I asked it to be imaginative and profound. So this is the squish side of things. And it's interesting, actually, kind of where this came from, right? Because this wasn't kind of, I didn't wake up one morning and go like, oh, I want to make a AI-powered clock and put it on my shelf. What happened was I was working on a proof of concept with a client on some executive coaching software. This is kind of at the beginning of 23. And the way it would work is there would be a coach's assistant that would live in your pocket, and we needed to have kind of WhatsApp and a backend server to kind of like deal with all the data about who's using it, and then like OpenAI at the back, right? And the first thing I like to do when I'm making a prototype is make end-to-end, just kind of prove all those different bits are working. And that's kind of a tricky thing, right? You can kind of prove that a client and server is working by just doing something. You type something in on the front end, and it bounces it back, and the string is reversed or something. And you're like, oh, OK, that's kind of working. But when I was showing this to the client, I was, how am I going to prove that I'm not just kind of type something into WhatsApp, it's hitting our servers and coming back again, but it's actually hitting OpenAI. There's like some actual AI going on. So I thought, OK, what I'll do is I'll make it generate a poem given the current time. And it's a bit of like a proof of life, right? Like I'm proving the entire system is working. And so this was my kind of demo for this thing I was building for this company, Austin. So I had this thing just kind of running, and then I came downstairs one morning, and I had an e-ink clock on my shelf anyway, word clock. And I was like, I wonder, could I put this on that? And that took 20 minutes, and then I started sharing pictures on Twitter. And it kind of went from there. Because it is like quite good, right? It's like quite weird to have this rhyming device on my shelves. As the clock strikes 11:42, I rhyme the time as I always do. So you have this problem that we call hallucinations sometimes with AI, which you would think for a clock is maybe not a great attribute, but I like to think about this as like charm, right? It's one of the things which makes it fun to have. And it kind of went a bit wild, so the New York Times picked it up. It went viral on Twitter and then started hitting the media. So that was quite nice being in the mainstream media. It went viral in India, which was quite exciting. The Hindustan Times was like nicely skeptical. Man claims his AI clock generates a new poem every minute. I think we should all have this kind of like, cautious skepticism about everything we read online, by the way. A couple more. As the clock strikes 1:34, embrace this moment, treasure it more. It's got this kind of like mini LinkedIn influencer vibe, right? 11:51, time to be bold. Minutes tick by, stories untold. And despite the simplicity of this prototype, it then starts making me ask questions, right? ChatGPT has a vibe. I didn't put into the prompt for this, like, tell me to go out and achieve my dreams, or today's the day you're going to get it done, or go out and do that thing. That's just kind of implicit in ChatGPT itself. There is something about the reinforcement learning that is giving it some character of like get up and go, or like go and achieve that thing, or whatever I ask, just go and like make it happen. And you're like, where does that come from? And does it matter? I think it does matter, right? Because people are using ChatGPT at McKinsey to like write strategy decks, and in government to write memos for ministers, and it's going to have this kind of like this vibe of like achieve something, do something, this kind of bias towards action, very Californian, where the appropriate thing might be, well, why not just like take a step back and think about it? And that's not the vibe that ChatGPT has. And so I think one of the things that my clock tells me is how do we interrogate vibe a bit more? How do we talk about it? Should we be having ways of like discussing personality, and so on and so forth? So out of dumb prototypes comes interesting illustrations of things we should be looking at. Anyway, back to the story. So the clock went reasonably popular and went viral, and like long story short, I thought I'm going to have to get this thing manufactured. So this is a render of the new version of the clock, designed by an industrial design studio in London called Approach, and put it on Kickstarter earlier this year and got funded back in March. So a lot of my mornings now are spent kind of chatting to manufacturers in China on WeChat and arguing about like kind of what shape the PCB should be, or how high the riser is for the USB-C power supply, like those kind of things. Hardware is a very weird thing to do, by the way, but that's maybe a conversation for the break. So it did, that did okay as well. Like people were very, very supportive in the media about this thing, but I have to say, the fact that it kind of makes up the time also became a bit of a thing as well. Like a lot of the media coverage was rhyming AI-powered clocks sometimes lies about the time, makes up words. There was a bit of a pylon on Blue Sky. I can't go back there again. And then it becomes kind of like, right, how do you squash out these hallucinations? And that becomes kind of an interesting story. So now I have a kind of a test bed to learn about LLM-powered generation in a kind of a real-life situation. And the evolution of the way the clock works on the inside works a bit like this. So originally, I was generating poems every minute from a prompt, which was basically like, be imaginative and profound. Here's the time. Make me a 2-line poem. And it would like fib about the time to make a rhyme work, about 1 time in 15. And it's like, it's funny to make stuff up, but maybe like not 1 in 15 times. So I can update that prompt. And I updated that prompt doing the kind of the prompt engineering tactic, which is you sort of beg and threaten simultaneously. Like, you must be accurate. If you aren't accurate, I'm going to send you back, and you have to do it again. Please, please be accurate. It's really important. It's incredible how that works. So that was like the next version, and what would happen is the back-end system would often not include the time at all, because you can't be lying if you don't say the time, right? And so that kind of worked for a bit until it became just a bit frustrating to have these poems on my bookshelves with no actual time. So the current version is that there are 2 prompts, which I think correspond really well to Maggie's kind of squish and structure. The generator prompt is generating poems, and to increase the sort of the randomness and the serendipity, there are rules in there, but there are also kind of ideas and inspirations for what it could talk about. The time, of course, it generates some times. That goes off to something which validates to check that the time is actually present in the poem and it's accurate. And if it's wrong, it has to generate again. And we go around that loop. Now, each time we go around that loop costs like 10 cents. So there's now an interesting trade-off of, like, do I care more about how much I'm paying or about accuracy? And to be honest, all of this could be solved if I would just like pay a bit more money for GPT-4. But literary accuracy has its price, right? So it rarely fibs, and I can sort of like tune that dial depending on how much money I'm prepared to pay. My sort of lesson from a lot of this, I guess, is like, one thing is, like, am I a poet? Is one question. Is it the AI being a poet, or am I a poet? And I would just say, from a creative standpoint, the AI is not doing any poetry here. As much as there's kind of like randomness and strangeness in there, it's not the poet I am, but I'm a kind of a meta-poet. I'm creating the conditions for the poetry to emerge. But the other thing is when I talk to people about this and they haven't encountered LLMs before, they haven't tried making anything with them, or they're kind of non-engineers or non-designers, there's an idea that AI is magic, or AI is on the way to AGI, or it can do everything, it can put people out of work. And this kind of like AI equals magic obscures what we can actually do with it. It prevents us from thinking like, what are the opportunities here? Because we just kind of like sit back and wait. And so I think this kind of like playful exploration is an opportunity to kind of get like hands dirty and build an understanding about what this technology, this actual technology, can really do. And then we start finding the new opportunities. And we don't do that by thinking about it or by talking about it. We do that by like writing code. So the other thing I spend a lot of my time thinking about, as well as things like the clock and talking to manufacturers, is how are we going to use AI? How are we going to, like, what's the user experience around it? How are we going to make products out of it? I'm not going to spend too much time on this map, but one of the parts of my process for figuring this out is I've been trying to map out different products in the generative AI space and how we use them in order to pick up tips and tricks, because different products have different things we need to be concerned about. And the way I've chosen to do this landscape is to think about what I think are the 3 kind of enabling innovations which have happened after large language models were kind of, got good enough with GPT-3 back in kind of like, what was it, 22. I think the first is just a large context window. So instead of a large language model just kind of auto-completing after a few sentences, can it take in paragraphs and paragraphs of text? Can you put that in dynamically? That's called RAG or retrieval augmented generation. But basically, it's kind of like, is the LLM good at generating text after 1,000 or 2,000 words? The second kind of enabling improvement in this technology is structured generation. So can we use the LLM to generate JSON, for example, or generate key value pairs? And there's multiple ways of doing this. Like the easiest way is just to go, please make JSON and hope, send it back if it's not true. There are other new techniques where you can manipulate the probability of the tokens coming out of the LLM to guarantee that you get JSON that corresponds to a particular type, for example. So structured generation. And then also, is it real time? Real time is important because when you have real time systems, that allows for interactivity as opposed to kind of batch processing. And when these technologies started coming about, we start being able to map out like the first generation of AI tools. We see them being used to generate copy and assets, images. Search was a kind of a first generation, came along very quickly. Web scraping was really my first encounter with using JSON coming out of LLMs. I found that web scraping tasks that used to take me like 4 days suddenly dropped down to like 20 minutes. Talk to a PDF was kind of a common feature, and chat sort of emerged. And that was kind of like the first generation of applications that we saw. Now, there is a whole landscape of apps that are enabled by LLMs. Things which are more like tools. Things which are more like agents. Copilots are in there as well. And I'm not going to like dig into this a lot, but really just to kind of say that different applications fall at different places on this landscape, and there are different concerns in different places. So for example, in the workflow tools, you kind of want transparency, collaboration, and determinism. For agents, you probably want more things like visibility and the ability to correct when an autonomous system is going off the rails. For chat, we probably want to be able to like deal more with character. And for the interactive tools, being able to like sculpt like clay, a bit more like Photoshop, is going to be important. I want to just kind of talk about my experiments in 2 places and show another example. In another version of this talk, I would make it much easier for myself by showing some of the best demos out at the moment, which are done by the TL Draw team. But because Steve is here, you'll just have to go and see his talk instead. And that means there were, I've had to like cut a whole bunch of the really good slides from my presentation because he should really show them instead. And as well, just to kind of say, like, just to add a little bit more of perspective on where I come at with AI user experience, I think a lot of my view on this is shaped by work done by Robin Sloan back in 2016, which was really the first time I saw somebody digging into what it meant for a human and an AI to work together. So what Robin did, so Robin, by the way, is a New York Times best-selling author. He writes speculative fiction. He sort of popularized sourdough, weirdly, with a kind of a novel about a sentient sourdough starter, which was awesome. His new book, Moonbound, is just out. He's also a media designer and a technologist. And what he did back in 2016 was he took an entire corpus of golden age science fiction short stories from sort of like mid-20th century. He fed them into a neural network, and he bound that into his text editor so that auto-completed sci-fi shorts would come up whenever he was writing a sentence, and he could like tab autocomplete. So the rings of Saturn glittered wildly, AI thinks. 2 men looked at each other. And he can decide whether to accept that or move on. And what was great about this is that he is a technologist and an author, right? He's a professional writer. And nobody had done anything quite like this before. So the question is, like, how did he feel about it? And he wrote a great essay. It's a short essay, but how this worked, but also kind of how he used it in his practice. And what he realized was that he never accepted the results that the AI gave him. He took them as inspiration. He bounced off them. He said, I'm going to do something else instead. He would be like, oh, that's an interesting word. I'll kind of incorporate that. But it would take his mind and his fingers in new directions. The animating ideas here are augmentation, partnership, call and response. So he realized very, very early that working with AI is not about automation or not about doing our jobs for us, but about kind of working together. augmenting our work, and together we go in kind of new directions. So this kind of idea of AI as collaboration, not AI as kind of like autocomplete or automation, is the direction I sort of take everything. Given that, a shout out to this new product, Granola, which is got one of my favorite features I've seen anywhere, which is it starts off as something which feels very familiar, which is AI-powered video call meeting notes. Sits in your meetings, does a transcription, gives you meeting notes. There are quite a lot of these things on the market, right? I've tried a lot of them. They're all terrible. Granola does something really clever. While you're on your meeting, you take notes which are really scrappy, which is what's on the left. Those are used as a kind of a prompt to the AI, a kind of a focusing. These are the things that were salient to me. And then it uses the call transcription to bulk those out into notes that you can kind of come back to. And this is incredibly clever. This is what I mean by AI user experience, because it's the perfect kind of like working in harmony. The AI does the kind of the stenography work. The human does the salience, what is important to me. The two together do something which means I can pay more attention to the call. So I'm always kind of watching out for these kind of moments. Now let me take a jump over to agents, to the right-hand side of that triangle. I'm going to make a bit of a pitch for agents at the moment, because I think we're kind of sitting on how powerful they are. Or when we see agents, we kind of think they must be magical or really, really hard to build. What I mean by an agent is it's a AI interaction, like a kind of something that feels a bit like a chat interaction, but it can use tools, basically functions that the agent runtime can go out and do for you. So to investigate this, I built a very simple prototype called Larry's. It's a smart home simulation with an agent that lets me control my smart home. Because I just kind of wanted to see, even with a really simple agent, what can it do? Like what is it kind of capable of? OK, what are we looking at here? On the left-hand side is a simulation of my smart home. So in my home, I have 5 rooms: lounge, hallway, kitchen, bedroom, and office. And in each of those rooms is a light. It's a smart light, so it can be kind of controlled remotely. And the AI, my AI agent, just the same as like Google Assistant or like whatever Apple's the Siri one is called for the home, it can see those things. It knows the map of my house, and it knows the devices, and it can kind of send them commands. What it can't see, without looking, is who inhabits that house. So what inhabits that house is my friend, Sally, my dog, Bruno, and a robot that the assistant can drive around, and the robot can look into different rooms. And then I can give the agent an instruction. For example, turn on the light in the kitchen. And it will use what's called functions behind the scenes to go and turn on the light there and then give me a response at the end. The light in the kitchen is now on. So what's happening there is this is a chat interaction just like ChatGPT, except it's replying in JSON objects, which are interpreted by the runtime as functions. I go off and I run those functions. They're HTTP requests on the simulation. A result comes back. That goes into the chat. And then the agent decides what to do next. And this is what characterizes an agent, right? One, it uses functions that the runtime takes care of. And the second thing that an agent does, it's responsible for deciding which functions to call and when it stops. So it just keeps on going until it says it's done. So that's just kind of like how it works. Here's another one. So I can ask my agent, turn on the light for my dog. Right. So it doesn't know where my dog is, but it does have a robot. So it says, oh, I'm going to need to look around the house to find that. And you can see here, the robot is moving from room to room. Right, it's moved into the lounge. It's going to look in the lounge. It realizes it can't see anyone in the lounge because it's dark, so it just turned the lights on to see if anybody was there. It's moved to the office. It's turned the lights on there. And it realizes it can't get to the office, to the last room, which is the bedroom, so it moves the robot back into the hallway. It will eventually move to the bedroom in a second. This is like OpenAI being slow. It will realize it can't see, so it turns the lights on again. Then it realizes it's achieved its goal, and it says the bedroom light is now on for your dog, Bruno. I want to say here that I didn't program in the behavior of you have to turn on the lights before you look through the robot. I didn't program in the behavior of if you want to turn on the lights for the dog, you're going to have to look around with the robot. It figured out that kind of basic reasoning is there already. And there's almost nothing in the prompt. The prompt is do the thing which will move you closer to your goal. When you're done, call halt. So really interesting emergent behavior. It's got one more tool at its disposal, where if it thinks it can't answer a question, it's able to come back to me for a clarifying question. So if I say to it, let's see, set the light in the office depending on if it's daytime. It realizes it doesn't know whether it's daytime. So it asks me, is it currently daytime? I say yes. It decides to turn the light off. If only the other people in my house also behave like this, right? Perpetually going around turning off lights. My conclusion from using this and kind of making this toy isn't just a kind of like, oh, like I can make an agent. It starts teaching me things, right? Agents are tool use and autonomy. I've said that. I find it amazing that even toy agents, the code, by the way, is on GitHub. I will, maybe I can share a link after this. Even toy agents can display basic reasoning. All agents, all services will need an agent-facing API. Given how easy it was to build this agent, there will be many, many agents out there. Like New Siri won't be the only one. And people will want to use them to interact with kind of like grocery ordering software or like buying books or booking holidays. What is the API which agents use? And how will agents discover those APIs? And then there are some questions like, you know, as a user, my agent is going out buying some books or booking a holiday. How can I tell it's like not booking the most expensive flight? Or how can I tell exactly what it's doing? It's not going to go and, you know, start asking people to do random things to achieve its goals. And people are still working on these, and it's really good to kind of look for good solutions. So this is another application called Minion, just launched recently. And they have an assistant which can run functions that runs on your phone. The clever thing they do is this AI assistant is basically driving a browser on your behalf, and they use iOS's picture-in-picture function to show its kind of internal state as it's running, which is a lovely kind of bit of transparency and legibility for what it's doing. The meta of this is something that Maggie said about affordances. When we use these AI things, no matter where they are in that triangle landscape, it's very hard for us to go, what can I use it for? What does it do? When is it appropriate for me to use it? Even if I know it does do something, when am I reminded to like pick it up and go, oh, I can use this to like analyze a PDF or do some data science on it? The boxes on the ChatGPT window saying what I can use it for remind me of those signs you get on doors where you have a handle that tells you to pull it, but actually you need to push it, so you have to have a label over the top of it. The affordances, what designers think of as like, what do we see that tells us how these things are used, like are either absent or misleading. And in the previous generation of confusing user experiences, or novel user experiences, mobile, the answer was skeuomorphism. You make it look like a button using shadows. You make it look like something familiar by making like the page curl in the corner. And that told us all, using these things for the first time, this is how I should use it. This is what my mental model should be. What is it going to be this time around? I don't know. I'll take a guess, which is I think it would be interesting if we started modeling our AI agents as teammates or colleagues. Teammates and colleagues have this incredible property that they're able to put their hand up and say, hey, this is something I can help with. And it will, they're able to kind of go, this is a moment where AI is able to help. And my model for this is to kind of conceive of the interface as being kind of like a stage. Is it possible for, this is an idea taken from Brenda Laurel, which is when you have the human and the AI on stage at the same time, each is able to see what the others are doing, and collaboration gets much easier. I'm going to show one last prototype and then wrap up. So this is a prototype I built at the end of last year. And this is our stage, right? So this is a stage you'll recognize here, the TL Draw canvas. And it's a multiplayer canvas, so multiple people can be on here. In this case, it's going to be me. And I've put a chat down the right-hand side, which is kind of like an audience, I guess. And just to prove, if you don't know TL Draw already, it's kind of this awesome whiteboard. But what I've done here is I've kind of turned it into a multi-user space where the users are not just humans, there's me, but there's also some AI agents, non-player characters, NPCs I call them. And I can invite them into my space. So they're single-purpose AI agents that will do particular things. I'm going to show you two of them. The first is the poet. And here I'm just like, I've asked it to drive in a circle just to prove it's kind of computer controlled. But I could also prove to go out, just to prove it's an AI, I can get it to go out and write a poem for me. And it draws that on the whiteboard. This one I think is more interesting. So this is another NPC that I made called Painter. And what Painter likes to do is it likes to color in shapes for me, but not any shapes, only stars. So when I draw squares, nothing. When I draw a star, it kind of hovers over it. And it's like, oh, let me help. And it kind of flashes, it puts its hand up. And then I can choose from its menu, yes, go ahead, please paint that. And it draws that in for me. And this, for me, gets more interesting, right? Because when I'm working with my colleagues on a Google Doc, they highlight things. They pop up in the comments. They say, I can help here. And it's a more kind of proactive interface. And yes, we are now beginning to see teammates coming up from people like Google and Asana. This kind of invention is because we are in what Nat Friedman calls a capability overhang. If we stopped work on generative AI now, we've got about 10 years of research to figure out the product implications of it. And we are imagination bottlenecked. We can't see what the opportunities are because we've got 20 years experience in digital telling us what's easy and what's difficult, and those no longer hold. I think invention is not about having big ideas. It's about little ideas that combine. And you just need to recombine, make things, and persist. And it helps break through the imagination bottleneck and find paths to products of the future. So I'll finish there. Thank you very much. Thanks for listening. And yeah, if you want kind of access to any of the code, I should have put the GitHub up here, but I can share that with you later. Cool. Thank you.
Thank you very much, Matt. Please remain on stage while our technical staff comes and sets up our little interview booth. And Maggie, if you were so kind as to join us. Thank you for two wonderful presentations. It's also good to see both of you. I don't get to see you enough anymore, even though we live in the same city. But now we get to finally have a conversation with 100 of our other friends. Please. Be seated. And for 100 of friends who have questions, if you were here for the first session, you already know how this works. You can go to Slido, so that's slide.do, and you can use the code FF2024, FF2024, to ask questions. You can also upvote other people's questions if you like them. Sadly, you can't downvote them, but that's maybe for the better. I am just going to start with the most upvoted question while we wait for new ones to come in. Do you fear the Shoggoth? And should we?
Yeah, I think you'd be a little bit crazy not to. Maybe I spent too much of my time hanging out with AI safety researchers. That was the company I worked for used to be an AI safety lab. So I just kind of hear people whose whole job it is to invent the worst case scenario stories, the most horrific things that could possibly happen, and write them in detail in essays. So you do go, this could go terribly wrong, power in the wrong hands, us being careless about how we build models, just exponential scale that we can't control, could go wrong in many ways. I think small and big. I don't think it's I'm not on board with all of humanity will die in 10 years, which some people are. I'm not there. But I think many small tragedies are probably going to happen. And then we'll learn from them and then build more robust systems and like all survive as a civilization, hopefully.
And Matt?
Yeah, I think I'm kind of aware of all the dumb things I tried to do as a 14-year-old kid, and now suddenly, like, there is this tool with enormous amount of knowledge in it will tell me exactly how to do them, and that's one side of things. I think the subtle changes in LLMs is something that makes me slightly more nervous, right? What kind of biases are implicit in these things, which will lead us in particular directions, like the ChatGPT bias towards action. But what is that doing, and can we kind of expose that? Can we make it more transparent? Can we talk about it?
Yeah, I think both of you talked a lot about this sort of dichotomy of, the Shoggoth or then the mask that we paint on it. I think the other term that people use a lot is like a feral models and then the house-trained, models. Matt, I wanted to ask you, you described the problem of, the clock sort of inventing things because of the ChatGPT post-training. Did you, when you initially built it, this was before ChatGPT, I believe, or did you use like a more feral model like a GPT-3 Raw or a DaVinci 2? And like, how has that experience been sort of like working with different types of models?
So one of the things I like make a joke about is being like an LLM sommelier, right? You end up with, I think somebody has literally launched a site for like tasting notes. Have you run across this?
No.
For different models. I find it's funny, like using GPT-3 was pretty good. 3.5, like the responses that came out were much more reliable, but the words were like really basic words. GPT-4 like uses more kind of like, expensive words. It feels like coming from like fancy newspapers.
Like Delve.
Oh, Delve. So Delve is a really interesting one, right? You should.
Right. This is like, so I don't know if people know, but like one way you can tell if text was written is like Delve is used by GPT-4 and previous models way more than any normal human would ever use that word. But it turned out, didn't they fine tune it, or the way they did reinforcement learning was mostly with Nigerian workers. And for some reason, the word Delve is very common in Nigeria. They just use it all the time. And so this became part of GPT-4's like fingerprint.
And I think that would be a great way to explore sort of like the weird implicit biases that end up in, and the economic inequality that we both benefit and cause. But maybe we'll leave that for later and ask some audience questions for a change. The most popular question here is, could LLMs eventually replace traditional search engines? I mean, I think for context, we've had this week, last week we had the Google combination of success and failures of releasing the kind of like the Gemini search box.
Yeah.
Is that just basically, does it mean that we can't use LLMs for search, or is there a different future?
Okay, it depends on cost. I'm going to say, like at the moment, it's more expensive to use language model semantic search than just like a keyword search or like some kind of, that'll be much faster and cheaper. But I don't know, like language models have always been part, in some degree, of traditional Google search. Like Google's been doing machine learning and neural networks for like decades. Like they were like the original people that came up with this stuff before everyone defected to OpenAI. So I think it's more a thing of like how much, like how expensive is the language model you're using in your search query? I mean, unless you're doing pure keyword matching. But I feel like almost all search engines at this point have semantic meaning baked in, which is some form of language model neural network. Yeah.
I think the two differences for me is one is that building a really good search engine is now really easy. Yeah. So again, I have some code around this using models on Cloudflare and Vectorize to build like a really good semantic search engine in like 100 lines of code. And it's insane how easy it is. These kind of things like, synonym matching or like kind of type what I mean never used to be easy to do as kind of an individual. And now with embeddings, it's possible. I think the more disruptive point is what is the point of first intent when you want to learn about something? Like search has never been a kind of a like look up an encyclopedia thing. When you start searching, you're learning the right words to use. You're learning about the domain. And it's always been conversational. And Google has never supported that very well, right? It's what we can term an epistemic journey. And ChatGPT or chat interfaces are really good for epistemic journeys. Now, can we bring both of that kind of like research and knowledge journeys together?
Yeah, I think XAI does this really well. If people have tried that, I would suggest that if you're trying to understand how semantic search is different to something like Google. I mean, Perplexity does this a bit, but it's a search engine where they've used heavily like semantic embeddings and semantic search. So you can just type in like, show me tweets where people are like really angry about the latest voting results or something, and it'll just give you tweets, much better than Twitter's search engine, but it understands, you can type in paragraphs, and it gives you results that are pretty close to what you were probably looking for. So it understands like semantic meaning and intent far more than keywords. Yeah.
Yeah, to kind of touch on this epistemic journey a bit, like one of the things that I find most interesting about this idea of like getting AI to do things faster for us, for example, summarizing something, is that what I find that often in order to learn something or really to internalize some, piece of new knowledge, I actually need to just spend a long time with it and like looking at a whole bunch of things and going down like rabbit holes that don't end up working out. And then at the end of it, I build a full world model. And now in the future, that world model will only exist in the machine, and it just gives you an answer, and you can go by your merry way. But what does it do to your understanding of like the world around you and around us?
Yeah. I mean, to give you an example on that, so I have an app which, like long story short, it has an arrow that always points towards the center of the galaxy. And so it has a lot of rotations involved in that. The maths behind rotating things in 3 dimensions and combining them is quaternions. I've been trying to understand quaternions for, I'm not kidding, 10 years. And every time I talk to people about it, they give me baffling answers. ChatGPT-4 is finally something which has infinite patience and got me to the point of understanding, maybe not in a deep way, but enough in order to be able to use it, understand quaternions for the first time. And so there is something, there's a kind of an interesting glimmer there about like what kind of journey it takes me on. And the world model ends up in my head in the end.
Yeah, I would hope it'd be better you building world maps faster. Like in the company I'm in and like the circles I'm in, world maps becoming this big, I don't know, hot talking point, past text generation, where if someone's trying to say I need to like map all the like cells that affect cancer or something, like all the different types of like organisms that are involved in this, a human doing that can take like years and years, and how are you ever going to synthesize all this research? But this is the kind of thing that machine learning is actually great for, is synthesizing tons of stuff into a world model that humans can understand. As long as you still have human-in-the-loop processes and you're like involving humans in the knowledge work, hopefully it just gets you to a world model faster, and you still have a very clear understanding of the space and trust that world model, but you don't have to spend years building it up. You might be able to build a small one for a particular topic, but if tons of researchers are trying to build world models like across domains on complex subjects, this is where they can really help us actually get to those quickly.
Interesting. Let me jump onto some audience questions kind of like related to, this sort of, I think both of you touched on the sort of constraining of models and like small models in general. I think here's one question which may not be possible to answer in concrete means, but how small can an LLM be to be still useful? As in like, what, is there like a sort of like a minimum size in terms of just like the compute required, the space required? How small can we make these to do tasks for us?
I actually don't know. I'm trying to think of like people who have told me they've built their own models, but I think it took months. Well, I don't know how much GPU access they had, but I feel like you still need a substantial amount of language to get the model to just put out coherent sentences before you get it to do anything interesting. So some base level of like language knowledge it needs before you can actually specialize it. Have you tried building one?
It's outside my domain. I will say that using anything less than GPT 3.5 level has not been reliable. And Apple had to do kind of like genuinely novel research to squash that onto phones. So that's their model equivalent. So it feels like that kind of stuff is going to end up being potentially local or on device. But cloud for a while, I think.
So if the task is just to write a 2-line poem about the time, you still need to know everything about the world in order to do that, which may be true actually.
Yeah. I think you need to understand nouns and verbs and sentence structure and adjectives to do a 2-line poem. Yeah.
That's interesting. Okay, so a kind of related question here. This is also touching on the Shoggoth. Are there good open source base models that are sort of more in this sort of like feral state that we can apply reinforcement learning to ourselves to constrain their behavior? So instead of having to start from scratch, having to use all of that compute to build out like language, reasoning, is there like a starting point that you can then tweak yourself?
I feel like Llama's the most promising. Like that's the big open source model that. And then all the weights got leaked. I mean, maybe intentionally or not. I haven't actually looked into that much of the open source stuff and building your own models. I'm so far on the end of like, take the already constrained models and constrain them more side of things. I haven't attempted to make them more unreliable.
Yeah, that's kind of my place in the ecosystem as well. From what I understand, like Llama 3 is the place to look, and people doing work on Hugging Face and Replicate is kind of where to go. It's pretty, like the 1 or 2 times I've kind of run stuff locally, just a kind of a test, it's been pretty wild just to kind of go, oh, when I'm not hitting the cloud, I can integrate this in sort of like new ways. And one kind of shout out for a good place to start is Simon Willison's command line tool, LLM, which makes it really easy to install different models, both locally and provide access in the cloud, and to like use it to pipe to and from. And he just, if you check out his Twitter, he just did a talk about this and about how to use it with some ideas.
Yeah, I'll give a shout out there as well. If you're already using OpenAI's APIs, there's this great project called OpenRouter that basically has exactly the same API as OpenAI, but it routes to hundreds of different models. So if you want to just in your app that already exists, you just want to try what that would look like when you use a different model, you can just use this as a proxy and route your traffic to any of them. Now, talking about this sort of like concept of, I guess, QA, Maggie, you talked a lot about this, sort of like validating the information is correct. And Matt, you described your process of making an LLM read another LLM's output and whatever. But like, what is the actual like, professional status quo or the best practice for QAing,
Yeah, I feel like what Elicit, I don't know if we're like at the edge of working on this, but we have people who are like, okay, we have people paying us to make models as accurate as possible. Like large consultancies and pharma companies and medical companies will pay a lot to be like, hey, I was otherwise going to pay 4 humans to do this for 8 months. Can you do it for cheaper than their salary? So it's a lot of money that you have to test whether you can get models to be accurate. And we found we can, but you do a lot of calls. So like when we get, we ask like, okay, extract, the dosage of these 10,000 papers, or extract who was studied in what countries. It could be hundreds of steps in that process where you're double checking at every stage and you're doing a whole bunch of these, like I talked about, kind of compositional chaining of lots and lots of different tasks, and then getting different models to double check all the other models and using GPT-4 as much as possible. So it costs money. Like we have an intern who will just like burn, frankly, tens of thousands of dollars sometimes on experiments, but then gets the accuracy rate over 95%, which is really great. So if you're willing to pay money, you can make language models more accurate than humans. That's for sure. It's just a matter of like finding the right composition and prompts and double checking enough. Yeah.
Have you found any kind of good tooling to do that? Because like, at the moment, I'm kind of like rolling my own chunky tooling, right? Like it's.
Yeah, we built a tool called ICE, Interactive Compositional Explorer. It's like some terrible name that the developers came up with that does this, that will show you every single step and allow you to roll your own. But frankly, we built this before LangChain came out, which is now like another tool that's very popular for chaining language model things together and including agents and web search and databases. I feel like LangChain might actually be a better developer experience, but otherwise we have one.
Yeah, I mean, I wouldn't name or recommend anyone because I haven't tried them myself, but I think the last Y Combinator batch had 4 different startups trying to build LM tools. So I think the people who are in business of selling pickaxes are going to be selling a lot of pickaxes, and some of them are probably going to be good.
I've run across Human Loop as well. And
Human.
And it's interesting, right? Like we're in this kind of, it feels like, with digital, we sort of like had this about 15 years ago, where there was no good tooling or observability for anything. And everyone was kind of rolling their own, and we kind of figured out what best practice was. Like, and it took some time, but it's still, it's still the Wild West a bit.
Mm-hmm.
Nice. Great jumping off point to the next question. So touching on cost and reliability and tooling. On this agent thing that you built, Laris, what if Bruno went for a walk and you forgot that he's not present? How can AI trust or verify human input before starting its expensive compute? Like, like you could imagine that this thing could run, pointlessly for a very long time until you cut off its budget. How can we sort of like improve?
So this is kind of agent sort of transparency, observability. How do you interrupt it? There are no good user experience patterns for this. This is one of the reasons I find it interesting. I had an agent a while back that I was using to experiment with this kind of ask the user for clarifying information. And this one, it was, I asked it to tell me the weather, what's the current weather. But I didn't tell it my city. So it asked me what city you're in. And I would say like London, UK, and it would like be able to like go off to the web and like find the lat long and put that to a weather API, give me the weather back. And the next time I ran it, I was like, oh, you know what? It says what city you're in, and I'm like, I'm not going to tell you, is what I said. And it started panicking. And it was like, right, well, what's your lat long? I'm not going to tell you. and it was like, do you have Google Maps? And it started Googling for like apps I could install to find a lat long. And it's like, right, do you have Google Maps? I'm like, no. And then it's like, right, OK, you need to go and install this app. Now go and press the settings button. Now go and do this. Now go and do that. And suddenly we're like kind of, 14 conversational steps deep in an interaction where it's telling me to like yak shave something in order that it can answer my original goal. And the question is like, what happens if like one of those kind of suggestions is like, right, now go and walk into traffic or something. So yeah, we're kind of, this is agent, I think, is this the AI alignment problem?
This is
right?
the AI
alignment problem,
yeah,
right?
yeah. So like you have they talk about outer goals and inner goals. So you're going to set an outer goal, like, hey, like get me the weather for my location. And the model might say that a completely different inner goal, like find the person's lat long. And this misalignment can lead to bad things.
Maximize the number of paper clips in the world.
Yeah.
We don't have a audience question about this, but I think this agents thing is like sufficiently interesting. I know, Maggie, that you've done some UI, UX experiments into sort of like agentive, systems. Like, what I'm seeing a lot right now is that there's a lot of really cool demos, because the 80% case is kind of easy to build. Like you can make a dolphin that paints stars and, et cetera. But like, what would it take to go from, where we are right now into sort of like, for any particular domain, what is the big gap that we need to jump over?
I kind of think it might be boring QA and like boring prompt engineering and like architectures, because I've seen a lot of demos of like there's a lot of new agent products coming out, like Lindy is like one of the ones that seems more capable, but they still aren't that reliable. You'll ask it to be like, hey, read my emails and like schedule all the calendar events that are mentioned in these emails and like respond to those people telling them when our meeting is. And even that can kind of screw up on basic things, or it misses stuff. Like the quality level is just still not high enough. We can see potential, like it's still, you're like, oh, it can achieve most of these things, but it screws up enough, like what you said, like 1 in 15, you're like, clock won't tell the time. It's that kind of mistake level. Enough that you couldn't really get people to pay for this and have it be an in-production app. I think that's just going to be the boring work of going through every single prompt over and over and over again and being like, right, why didn't it catch this one place? Oh, it doesn't understand that phrase. Oh, like, write an additional prompt and, make that catching all the edge cases is essentially like programming, right? You catch all the edge bugs kind of thing. This is like standard programming at some point.
Yeah. Did you see the Apple Intelligence launch, the keynote? It's worth watching the last 30 minutes of this, because one of the features is Siri is basically becoming like this little micro agent, right? So it can kind of do tasks for you on your phone. And one of the questions is like, how does that work? They didn't say this like kind of specifically, there's a really interesting clue on it, is that your iPhone now comes with a detailed guide about how to perform any task on your phone. So it's like, oh, how do I send a text message later? And it's like 4 steps. It's like kind of like, open a text messages app, write the text message, press this button, now you're done. And they build this as a kind of a handy user-facing feature. Oh, there's a guide for your phone. Now, if you've built a bunch of agents, what you know is that that is being loaded from a semantic database according to a user query, and the agent will use that as a series of actions it will run as part of the kind of orchestration step. So it's a guide written in plain English. It's also really detailed instructions to make sure the agent does exactly what the agent should be doing without hallucinating too much. And I think a lot of these tasks are going to be like, how do I buy a book? How do I buy a holiday? Book a holiday with an agent. Somebody is going to need to go down and write the sequences of steps thousands upon thousands of times. And that's going to be like an important part of it.
Amazing. We only have a few minutes left, and we have a very long list of questions. Your talks have been either very popular or very confusing, one of those two. There's a lot of great questions that I hope that people can come and ask from you when they see you trying to get to the bathroom or something. They can stand in your way and ask. But I will ask this because this is the one that interests me the most. This is Maggie. This is related to your talk. Can we learn something from naming all the 12,000 dimensions that these models have figured out about us humans? And is there already a list? Like, could these dimensions actually give us lingo and help us understand humanity in like a way that is deeper than humans understand ourselves?
I hope so. This is the stuff that seems more interesting to me. And okay, I'm going to put a bet on that the people who are going to do this, if anyone can, is Anthropic. Like they're doing the most interesting research on on what we call interpretability, so like making the inner workings of the model interpretable or understandable to us. And they put out a paper last month that everyone went wild over because it was amazing. It was like where they had figured out a way to get the model to visually represent some of its clusters and then label them. So they found like they could identify where the concept of the Golden Gate Bridge was in one of their large models like neural network like memories. And then they could kind of clamp onto that. They called it clamping, so that when they asked this particular model to talk about anything, all it would talk about was the Golden Gate Bridge. It was like obsessed with the Golden Gate Bridge. You'd be like, where should I take my girlfriend for a date? And it was like, the Golden Gate Bridge is the most gorgeous place in the whole world, you know, going on, anything you asked. Where it was an interesting way of constraining the model, but another output of this was just like, they had this partial map of actually what the model can see. Like the stuff I showed in my slides about like sausage and tax, before that point in time, we couldn't see that. We knew that was how it was working on the inside, but we couldn't like literally see where every concept was in space. And they made it possible too, which was really exciting. So I'm betting if anyone's gonna do it, they're gonna find a way to get the model to name all the dimensions of how things move around and relate in space. Yeah.
Nice. And Matt, a final one for you, because you've been in this forefront of this putting AI into the physical world, with the clock. But we see a lot of releases of sort of like AI devices, like R1, Rabbit One, or whatever these pins and people are. Is there anything that you're excited there? Are there any things that people should look at?
So I picked up a Rabbit. Rabbit, one like mainly because of the industrial design by Teenage Engineering. I'm less interested in the assistant level things. I think personally I'm more drawn to very, very specific devices. There was a prototype that came out recently called Transfer Scope, which is a handheld device that can pick up images of things around you and then remix them in your hand. And it just felt like such a beautiful kind of precision tool to interact with the world around us in a very smart way, which wasn't kind of like, having a buddy which is going to do tasks for me, which just feels a bit like kind of the lazy solution. So those very specific things I'm interested in.
Nice. Well, that was all we had time for, but please do ask our speakers questions when you run in the hallway track. And I think now we are going to go for lunch, unless Juho is trying to catch our attention. Juho needs to explain lunch to us. Okay, sure. No, it's not. Anyway, should we just say goodbye to our speakers first? Yes, we should. Thank you very much, Matt and Maggie.
Thank you. Thank you.
Yeah, it's a couple of things between you and your lunch. But so if you have a bag that has a tiny piece of tape, you could return it to help desk because we gave away a speaker gift. The second point, so I got some questions. What is it? I mean, it has a couple of purposes. So if you go in the forest and you fish, you get your fish, then you make a fire. So it's firewood. It's back scratcher. And I think that main reason why I had this made, and actually it's my design, so if it's crap, it's my fault. But anyway, now I try. Let's see if it works. It's like the first time I tried. Moment. It's stable. So it's a wrist saver, and it's improving the ventilation of your laptop. So you can put it under your laptop or whatever you want if you have iPad or something. But it is like actually, we just gave you a piece of Finnish wood, but I mean, but it's good. It's good. It's Finnish wood. So, and lunch, I think we go half a floor down at the restaurant. No, I think you're supposed to know something. And then I can tell a joke and then we go for lunch.
Did you just hand me a microphone and tell me to tell a joke before we... Oh my God. Okay, so I only... all my jokes that I'm thinking of now are either rude or horribly long. Okay, so there's this one joke that I like about Finnish people, and this will be useful for you if you are here interacting with Finnish people and you're not from Finland. And it's the old joke about how can you tell the difference between a Finnish introvert and a Finnish extrovert. Does anybody know this? Some people know this? So Finnish introverts, like they're very shy. So when they're talking to you, they will look at the tips of, their shoes. But if they're extroverted, they will look at the tips of your shoes. Anyway, thank you. And that's the one thing you never do to a person. You never give them a microphone and tell them to tell a joke. All right, have lunch.
I do have a mic.
It'll be a couple of minutes. All right, folks. We are about to start in a couple of minutes, so I'm just, as tradition holds, starting to speak to the microphone so people who will hear my voice and come in. So before we start, I have one sort of like a logistical announcement. So Mo, who is one of our presenters here, unfortunately he has been robbed. Somebody accidentally took the speaker bag, or actually no, nobody accidentally took it. Somebody was accidentally handed the speaker bag by one of our staff. So if you have the swag bag that you have from the conference, if you check the wooden, implement that Juho demonstrated earlier, if it's inscribed to Mo, then maybe you can return it and we can give you a fresh bag. But if not, then well, obviously keep yours. And if somebody finds it right now, can you make a noise and raise your hand, and then we'll all give a great big applause. Fun activities for the whole group while we wait. Yes, we are very professional here at Future Frontend Finland. All right, so let's get this show rolling. We are at time. So the next session will be about dynamic UI at the edge, and we will have a great presentation by two folks first, Mo Kazali and Samuel MacLeod. Mo works at Totle, Samuel at Cloudflare. Cloudflare, right? Yes, good. Nothing has happened since the last time. No layoffs since I last heard? No? Okay, great. And they'll be co-presenting. So without further ado, let's invite on stage Mo and Samuel.
Thank you very much, Yanni. Awesome. Great to have a crowd here after lunch. To the person who's robbed me, I will never forgive you. No, jokes aside. I totally understand. But no. Thank you all for coming around to this session. Me and Samuel were actually here last year at Future Frontend. Both of our first times in Finland, I'd say. I think so, yes. Yeah. It's a lovely time, honestly, and such a great first year and great to be back here. So last year we did separate sessions. I did a talk about design systems. Samuel did a talk about authentication and authorization on the edge, and we thought, why not just see if we can do something together and merge some of our different things that we do in our day jobs and see if we can get something cool out of it. So this session is called From Static to Dynamic, and we're going to talk about a bunch of different concepts and see if we can tie them all in together and do something interesting and hopefully leave you all with a little bit of inspiration to go and create something a little bit crazy in your spare time. So, as Yanni mentioned, my name is Mo. I head the mobile team at Totle. So Totle is a group of about 700 digital experts across France, UK, the US, and Casablanca. And I specifically work with a sub-company within Totle called BAM, which does mobile development stuff and has been doing React Native since 2016. So I'm very involved in the React Native community and try to see if we can find good ways to take React Native to the web, which I've been talking to Yoav about extensively, and he tells me that the answer is PWAs. So I may be reinventing the wheel a little bit.
My name's Samuel. I do nothing so fancy. I'm a plain old systems engineer at Cloudflare. I work on developer productivity and developer experience on the Cloudflare Workers platform.
And as you can see, his humility is far better than I am. Cool.
So we've come here under false pretenses somewhat. We'd like you to go to this website and buy some clothes. Or at least that is what we'd say if we'd actually built it. So this is a kind of fairly bog standard e-commerce site. It's got recommended products. Wait, no, I have a clicker, don't I?
Yeah, you do.
Okay, excellent. Featured categories, testimonials, and a footer. It's fairly standard. There's nothing complex here. You've probably all written sites like this or seen sites like this. And if you're thinking about implementing it in something kind of JSX inspired, so React, Solid, something like that, you might have a home page and then components for each section of the page. This is fairly bog standard code, nothing interesting. You'd write this, you'd ship it to production, everything would be fine. However, at some point, the PM, your clients, stakeholders would come along and say, actually, I want these sections rearranged. You'd grumble a bit, you'd rearrange the sections, and it'd all be fine. Wouldn't actually take that much work. And a couple days later, they might want to rearrange some more sections. And you can maybe start to see where this is going. You start to get bogged down in a lot of kind of rearranging of UI, work you don't really want to be doing. You want to be building complex dynamic interfaces. Instead, you're rearranging UI. And eventually, it starts to get even more complex. They might want to have specific state depending on whether the user is logged in. And you can do that, but it starts to get a bit more complicated. And then eventually, these animations are very slow. Eventually, they're going to want kind of very, very highly dynamic state based entirely on the user. So completely complex, completely custom layouts per user. And your house of cards falls down. This is not the type of stuff you want to be doing. You want to be building complex, interesting interactions. Instead, you're just rearranging the proverbial deck chairs on the Titanic.
And for some developers, it may just be mildly frustrating. For other ones of us, it might elicit slightly more aggressive reactions. And none of us like to do this in the workspace. So we're going to look at ways where you can prevent yourself from smashing your laptop, your Mac, whatever you have as your daily driver. And one potential solution to this is a paradigm that's been around in front-end development for quite a few years now. It's nothing new, server-driven UI. So the whole concept with server-driven UI is that you allow the server to define the layout of the page via some form of serializable data, so in this case JSON, and then you create a dynamic layout component on your client side that receives that JSON and can render the page dynamically and in any order that you want. So there's no more hard coding left here. And on the right-hand side, you can see an example of what that JSON payload might look like. It's got an array that's got a set of components. So in this case, let's go back to the e-commerce example. You've got a banner, you've got offers, and within each of those objects, it also defines the props, what you need to pass through to those components to render them accordingly. So the banner might take props for some contact information. The offers might have an array of the different items that are currently having a price reduction, and so on and so forth. And this comes in various different shapes and sizes. You can use server-driven UI for your entire page in your application. You can use it for sections of your application. Or you can even use it for certain components. So as an example, Lyft has used server-driven UI for just a single sheet within their mobile applications. It's a single component, and that's because there is a lot of different slight variations, and they wanted to be able to configure just that from the server as their business started to evolve and have different requirements. And so if we look at a very basic example of how this would look like in your code base, first thing that we need to do is we need to create a map between what the server is returning in strings within the JSON objects and what components they map to within the code base. So we'd import the components. This is not a production-ready code, so don't use this because it'll break all of your tree shaking. But you can use this with dynamic imports, and it'll work as expected. You would define a components map and say, when I get the string banner from my CMS or endpoint that's on the back end with the layout, I want it to map to this specific banner component in my code base, and the same for offers. And then we'd have a render component function. So this render component function takes in a config in the shape that we're expecting the server to return to us. It then looks at that config and says, what is the component you're asking me to render? In this case, it might be the banner or the offer, and then it basically returns that. Very simple, passes everything in through props to the already existing component. And so our homepage is a lot more dynamic suddenly. So if we look at the new implementation for our homepage, we have a loader to get the JSON data from our endpoint or our CMS, and then we basically just loop through the JSON data and pass it into that render component function. It can obviously be a bit more complicated, but in the example where we had just a one-dimensional scrolling sort of set of components, this is pretty much it, and you can get it to work. And so combine the JSON from the API and the CMS and the home page, and you have a fully layouted page that's customizable and dynamic and can have a lot of different benefits like personalization. And so it takes us to common reasons why people do server-driven UI. We've seen complex layouts and variations that'll change all the time. People oftentimes want to increase dev velocity because what you're doing is you're taking away a lot of that manual, small, tedious work that your front-end teams are doing and just moving that to another part of your stack. User personalization is a big one. Oftentimes, people start to reach out for server-driven UI when you have user personalization needs. And in that same vein, you've oftentimes got A/B testing requirements, and doing server-driven UI makes it incredibly easy to do A/B testing, not only on the web, but also on mobile, where you have native components, and actually shipping updates might be quite difficult. And lastly, we've seen if you've got those complex and fast-changing requirements, it's a good place to consider server-driven UI. But the one that I think is very interesting is around user personalization. And this is very much what modern front-end applications are expected to have. Every single app that you interact with has some level of personalization for you, whether that's going to an e-commerce site and it shows you the products that are most relevant to you, or it's even a single-page app that has some level of personalization and keeping a state of what you've done to try to make your experiences more streamlined and more smooth. So users really do want seamless handoff of state between sessions and devices, and sometimes this is actually quite minute, and they're very tiny micro-interactions, and we'll look at a few examples. And when we talk about state, that oftentimes includes ephemeral state, things like your search history, things like theming that you've set up in your application. You don't want to be setting these up every so often because it's not being persisted correctly and across different devices. So let's go through an example, and I think that'll make it land a little bit better. When I wake up in the morning every day, I usually start going through my mails on my phone. I'm walking around the house, getting coffee ready, sometimes lying in bed because I'm lazy, up till 9:30 when my work starts, and I jump into the first meeting. Not a good idea. And sometimes, I'll have an email that requires a little bit more attention and needs a little bit more screen real estate. So this was an email from a conference organizer. They needed some details from me. And on an OS level, we actually see this seamless handoff of state quite commonly. So anyone who's in the walled garden of Apple these days, they'll have the handoff feature. That means that your interactions will kind of be synced across different parts of the OSs. So you're viewing a mail on your iPhone, you open up your Mac, and there's automatically a dock icon at the bottom of your screen, and it says you can open up the mail from your iPhone. And when you do that, it's in the exact same state as you were on your iPhone. So there's a seamless handoff across devices in a single session. And then you can kind of continue through the flow as you wish. But this isn't only on an OS level, this happens on an application level, right? So in the case of, let's say, Google Maps, a common app that we all use, that state is consistently synced, and it's the same with most of Google's applications across different devices and across sessions. So this morning we were looking for directions to the Oodi. Anyone who's not from Helsinki here, who hasn't been to the Oodi yet? Raise of hands. Absolutely should go. Do not miss this opportunity. Best public library ever, hands down. So we were looking for directions. I get distracted very easily, I'm sorry. And when we looked up for the directions on the phone, when I opened up my phone, it was already there. I didn't have to search for it anymore. It was automatically synced without me even having to think about it. So I could just click on that button, and it was done, dealt with, easy.
But your backend teams are busy, and they don't want to think about this kind of syncing of ephemeral state. They want to focus on building new routing algorithms or building mail architectures. They don't want to focus on building syncing logic for which email is open in your client. And what if front-end devs didn't need their back-end teams to do this stuff? What if they could build the syncing architecture themselves?
And that's where the demo comes into place, right? So let's go through an example. We've started with maps. Let's just keep going with the maps example. So we've built a very basic maps example in React Native. The same would be applicable with a React app, so you might have different applications. And currently the state is separate. So let's imagine I've got an iPad here, and I've got an iPhone, and I want to actually sync the state between these. Well, currently that's not the case. So I can search for a location. In this case, maybe I want to search for Helsinki, and then do a search. Right now, it's not synced, right? So if I go into my search history here on my phone, there's nothing in my previous searches. I can search for London, and I can go to London here, but it's not going to show up on my iPad. So these are two very separate experiences. They're not synced in any way possible. Other things like theming. Right now, I'm viewing it in standard mode, but maybe I just want to view everything in satellite mode, but that's not going to be synced across the board. And so me and Samuel were thinking about, what is, as a front-end developer who doesn't do a lot of back-end, what would we want to make it easier, or as easy as possible, to simply take us from the front-end world and allow us to write back-end code, right? We don't want to be dealing with a lot of complexities that come with back-end development, but we want to find a seamless way that we can move some of the state over to a server somehow. And so we got thinking, and I'm going to open up some code here. Let's make sure my connection's still working. Good. Cool. So we got thinking, and we said, well, yes, that's a good shot. Yes. Back of the screen, back of the room, can you all see this code? Sorry? OK, well, let's see if we can make it light mode. Theme. Does everyone like solarized light these days? OK, cool. All right. Nice. So obviously, at the very top, we've got a bunch of use states, right? This is the way that we're used to. We have these hooks in React, and every other framework has their own set of primitives, right? That you can keep store and keep state within the client side. And so we're used to this use state API nowadays in the React world, where you simply create some state and keep that on the client side. But what if we could just, change use state to another hook and just call it, I don't know, use server state? And that could just automatically push that data over to some server that lives somewhere. Now, obviously, it's a little bit more complicated when you're pushing things to a server. Let's just give it an ID and say, this is my maps demo ID future frontend. And if I save that, and I reload my application, because it's what if I just searched here for London, let's say, as a location? And then on this side, I wanted to open it up, and it automatically had London synced somewhere on a server without me needing to add any extra code. So 2 words added, and it can suddenly sync, right? So that, to me, as a front-end developer, is incredibly easy to get my head around, because I simply need to add an ID to my use state so that it's globally identifiable, and then I just change the name of the hook, and it just kind of works. It feels very intuitive. It makes me want to just move as much as I can to a server, and it doesn't make me fearful of all of the changes there. So let's just go and add a bunch of more use states or use server states to this. One thing that we saw was the theming here. The theming is not synced across the board, so if I change this, it won't sync across the other one. So what if I just change this one to a use server state, and I just called this one map mode future frontend. Save that. Great. It's all synced with one simple change. Let's go through the process and just change more and more. It's really quite simple here. So let's just say I want to change the region that's currently selected. So region future frontend, let's save that. And now this one starts to get fun, because I can search for Helsinki, and not only will it navigate on my iPad, but it'll automatically point that towards the one on my iPhone. You can start to really break down what good UX is and really ruin the user experience with too much syncing, but we'll do it for a bit of fun. So that's synced. OK, cool. Let's change this back. And then just to make matters worse and even more confusing, let's just sync the query. And we'll call this use server state, and maybe we'll give it an ID of keylogger, because this is definitely an awful idea. And then whatever I type here is synced across the state. So I can kind of remove things, and it will be synced across the state there. So that's just a little glimpse into what we think syncing state should look like when you are a front-end developer and don't want to write back-end code. Now, how does this actually work, right? We've kind of shown you just a little bit of magic. We're obviously using a third-party library here that we've built, and just said, look, it works. And that's what Samuel's going to take us through, is how this actually works under the hood. And you'll realize it's actually not as daunting as it might seem.
This is a first-party library. So quick aside, I'm going to go through a couple slides from my talk last year at Future Frontend. If you've seen these before, avert your eyes. If you haven't, then pay close attention. Just to kind of set some groundwork. So the speed of light is slow and your users are global. I like this catchphrase because it's a good catchphrase and it's also quite true. If you're in Helsinki, or your servers are in Helsinki, and your users are in London, you're looking at about a 30 millisecond kind of connection ping latency delay. So that's the speed of light. It's the network latency along the cables, undersea between Helsinki and London. And that is time that's completely wasted before you even get to your application. So if your application is doing any rendering, it's doing any loading client side, is there any image, waterfall loading, you've already lost 30 milliseconds. And Helsinki and London are quite close. If you look at Los Angeles, it's 180. Tokyo, it's about 230. And then by the time you get to Australia, you're looking at about half a second before you can get anything to users, not accounting for anything that your application wants to do. So a different model of doing this is to run your servers on the edge, or to run your code on the edge, and just bring compute much closer to users. This is a map of Cloudflare's network locations, but every CDN provider has computers around the world. Fastly, Akamai, CloudFront all have things that kind of map roughly similarly to this. And the idea really is to just run compute as close to your users as possible. So you don't have any kind of network connection latency. All of the delay is stuff that your application is actually doing, useful stuff that your users want. So I'm going to quickly talk about durable objects. And durable objects are basically a way to have stateful serverless. And what do I mean by that? Traditionally, serverless, as you usually think of it, is effectively stateless. If you think about Lambdas, it's a request comes in, you do some data mangling, you might go to a third-party API, and then you return a response to users. But at that point, it stops. If you need to think about storing state, if you need to think about user application data, you need to reach for a third-party service. You need to reach for DynamoDB, you need to reach for RDS, you need to think about regions, you need to figure out if you're accessing the right region, if you have the lambdas in all the regions you need. It starts to get really complicated. You hear lots of buzzwords, you hear lots of words, and if you're anything like me, you kind of start to get a bit terrified, because I don't understand how any of that works, and there's too many concepts. And durable objects are kind of a simpler way of thinking about that. It's basically an instance of a JavaScript class with some storage, and that's all it is, and that's all you need to understand. Most of you will know how to write a JavaScript class. If you know how to write a JavaScript class, you can write a durable object. So this is a really simple durable object. You can see all it is a class definition and a function that stores some data. That's it. And you can write this, and then you can deploy it, and it will be close to your users, wherever it needs to be instantiated, and the data will be persisted and stored. This is obviously a fairly simple one. And then this is how we connect to it. But the actual durable object to support the use server state hook is really not that much more code. Because the really cool thing about durable objects is because you have this stateful serverless primitive, you have this long-lived process which can have connections, you can think about WebSockets. You can think about things that don't traditionally fit into the request-response model. Because for Lambdas and for most serverless primitives, you get a request, you do some stuff, and you return a response, and it ends. And that makes it really, really difficult to support things like WebSockets, which require a long-lived connection and which require much more time. But here, all we're doing is saying when a WebSocket message comes in, we store some data, and then we broadcast it out to every other connected client. And that's all use server state is. It just takes in updates and broadcasts them out to everyone else that's connected. And then the client side of this is really not that much more complicated. Your React code, the components, will send in updates to the use server state hook, which is client-side code. That use server state hook will say to the server, hey, I've got a new update, do something with it. The server will then broadcast that to every single device that's connected, and they will then go and update their own things. But those other devices can also broadcast, and then that will come back from the durable object, back to use server state, and back to your component code, and trigger re-render. And then going through the actual React code of this, we've got some boilerplate here for setting up a WebSocket connection. And then we have a local use state cache just for optimistic updates. The concurrency model here and the consistency model here, it's pretty naive. It's basically last write wins. You might want something more complex in a real application. And then we have a couple lines of code to take updates from the server, and then a couple lines of code to send updates to the server. But that's pretty much all it is. Any update that comes in from the server, we write to the local use state, and any set state that we get, we just write back to the server.
And this is effectively less than 100 lines of code, and that's 100 lines of code on both the client side and the server side combined together.
And half of those are braces and types.
So you can really get this to very minimal code that's running on the edge and to a very slight abstraction that will allow you to sync state like this pretty seamlessly, I'd say. And the thing that's important maybe to just take a step back here is this is not something that we would be looking to open source because it doesn't make sense to open source it. It's a very light abstraction. But the kind of fundamental concept that we want to get across here is you can write your own use server state hook and very easily create the right abstraction for the entire front-end team that you have with your authorization and authentication set into place, and with whatever sort of conflict resolution algorithm you want already in place, and then you can make it a really nice experience to move state from local to somewhere that's shared on the edge. And we think it's a really cool abstraction that more and more people should adopt. And so we've talked about ephemeral state that's represented as JSON. So this was things like our search history being stored in a JSON object. And they are then hosted on the edge within a durable object. But earlier in this talk, we talked about server-driven UI JSON. We said you can represent your entire layout and your entire application's state and how things are being rendered in some sort of JSON that lives on a server. What if we just put that server-driven UI JSON inside of a durable object? And so it turns out when you take server-driven UI layouts and you add some ephemeral state into them as well, then you can create some really cool real-time collaborative applications. And there's no better way to do it than a demo. So I've asked some very lovely people from both the speakers and one of the great people from the audience who I've known for a little while to come along and participate in this interactive demo. So please welcome everyone with a warm round of applause onto the stage. No. Fuck. That would have been disastrous. Cool. Come up. Awesome. So I'll let you go through and talk us through, Samuel.
Okay, so this is a video calling application that is potentially going to break disastrously, so be prepared for that. So has everyone joined? Excellent, okay. So we can see there are 5 users in the room. I'm going to join from this computer. And we can now see, excellent, lots of video streams. Now, there's a couple key things here. One is that this is themable, and that theme is synced across all devices. So these kind of confusing buttons here, you can change all the video to grayscale, and that will now be grayscale on everyone else's device as well. So if one of you could turn your phones around and show that. Now, what I was about to get to is that they can also control the theme, so clearly some people are exploring with the buttons. And this gets quite fun, because the theme is being controlled by effectively everyone.
This is Shrek mode here.
This is Shrek mode, yes. And this is Ghost mode. So that's one thing. The other thing, and this is straight out of a Black Mirror episode, is that you can vote your video participants. And the layout on the screen of the order of the icons is based on their score. So if I vote people down, they'll go down in the rankings. If I vote people up, they'll go up in the rankings. And the cool thing here is that this is live, synced across everyone. So this is layout driven from the server, but synced across all devices, and being able to be driven by all devices. Now, the next part of this demo is that we're going to try and let all of you join.
This is going to go poorly.
We're going to see what happens.
Yeah.
I've got a QR code. So if you would like to scan that, if you're using an iPhone, please turn off Private Relay. It somehow messes with WebRTC. But if you'd like to scan that and join the video call, and let's see what happens.
This will definitely break.
We have at most tested this with 5 people, so goodness knows what's going to happen when more than that join.
Oh, we've got audience attendees jumping in. Cool.
Cool, so I'm going to go back to, oh my goodness, that's a lot of people.
Andreas, I see you. I see you there.
So everyone on the call should be able to control the theme, and that should sync across every single device.
Oh, now we don't have any space. We didn't test it with this many people.
Oh, has it run out of space?
No, there's only a downvote button now, and no more buttons. So.
Okay, it may not be the most optimal mobile UI.
So we can start voting for people on the. Oh, and that's giving too many people too much control. Okay.
Yeah. Okay, so this is definitely starting to break down.
Cool, but you get the idea, right? You can all just jump on a call, control the layout together. Obviously, probably not with however many people are in this room, but we've got a pretty cool state, and everyone's downvoting each other, which is great. So the social experiment has proven that it would be not very good, so we can go back. Thank you all for joining this. Thank you all for coming on stage. Round of applause. Cool. So we've taken up a lot of your time. Let's quickly recap everything that we've gone through today. Firstly, we talked about server-driven UI. We know that it's a way that you can handle complex layouts that need to be dynamic and personalized. These are layouts that are changing quite rapidly and need to be personalized potentially per user and really tailored. We know that users expect modern and future front-end applications to have seamless handoff and sync state between devices and sessions. And we found a good way to store ephemeral state on the edge, and it could be a good option because it's incredibly simple for front-end devs to adopt, and there's very low latency. We've obviously used durable objects, but you can find other solutions that are simple to deal with yourself. And then when you take the server-driven UI aspect, you take the state that lives on the edge, and you kind of put them all together, we can create real-time collaborative applications without needing any complex backends. The call demo that you saw was basically WebRTC on one side and effectively the same use server state that we initially demoed, handling the layout and doing all of the customization. So all of these things put together, we think, opens up the door to create something really cool, and you can hack around with a bunch of your friends and see what you can build, and hopefully you don't build something as dystopian as we did. Thank you all very much for listening in. That is our socials if you want to stay connected or shoot us a message, and hopefully we'll chat with you all a bit more in the Q&A. Thank you.
Right. Thank you very much. Yes, you are excused until further notice. And now let's invite on stage Andreas Möller to set up his laptop while I fill time with very important information. Firstly, I'm really curious. Did anybody find Mo's little wooden thing in their bag? If you weren't here at the beginning of the session, this sounds like a really weird thing. But yeah, we accidentally handed Mo Kazali's speaker gift to one of you. So one of you has it. I'm not saying that you need to give it back if you really like it, but if you do have it and you accidentally took it, it is not your fault and we won't yell at you. But just check in your bag and see if the little wooden thing that we have given you is inscribed to Mo, and that would be lovely. Now, hopefully without further ado, as Andres is setting up, let me just remind you about the Q&A that's going to happen afterwards. So we're going to get all these folks back up here on stage, and we're going to have questions that you will ask on Slido. So that's the website sli.do using the code FF2024, so FF2024 on sli.do. And then, you will basically rank all of the questions based on your voting, and we'll ask the most pressing questions. So yeah, if you have any questions about Mo's and Samuel's talk, now is a good time to put them in when the talk is still fresh in your mind. And then we'll be speaking to them. And do you need help? No, we're good. I think we're good. All right. Well, I think without further ado, let's give it up for Andreas Möller.
Thank you very much. So I want to actually start off with what Mo and Samuel talked about in the previous talk, and especially this idea of server-driven UI. And there's one aspect of that I find particularly interesting, and it's actually not the same that Mo really liked. I really like the aspect that by having this combination of your logic or your app and the config module, you're sort of empowering a lot of people that are not necessarily developers to actually participate in building your application. And like the live version, right? Not just feeding into developers, but literally on their own can go and make changes. And I think that's a very interesting concept and something we're exploring a lot at Totle. So maybe a short introduction. My name is Andreas. I'm the founder of a company named Totle, which is a technology I want to talk about today. But before we get there, I want to talk a little bit about the future of the web. So about, what is it now, a little bit over 10 years ago, we really saw a fundamental shift in how we build web applications. We went from using tools like jQuery, MooTools, whatever we used before, to using these modern frameworks that came out. And it really did change everything, not just how we build applications, but also the kind of things that we could build, right? And we've seen this monumental shift. Now, over the last 10 years, these frameworks have gotten better and better and better. And to the point where they're beginning to converge a little bit on a core set of ideas that are really, really powerful. So I don't know what the next big thing after React is going to be. Maybe it's quick, maybe it's solid. But I think I can make pretty educated decision that it's going to be component-centric architecture. It's going to have a combination of server and client rendering. It's probably going to have signals, and it will likely also have some sort of compiler. And so we haven't seen this kind of monumental shift that happened back then. We haven't really seen that yet. And actually, we're beginning to see a conversion of technologies. And I think when we look at what is the next big shift going to be, it might be less about what are the tools we're going to be using to build, or technologies we'll be using to build these things, and actually a little bit more about who are building them. And this is not an AI talk, just to be clear. And I think the question of having product managers be able to configure these things themselves without needing to rely on a developer is a good place to start. But I want to take that much, much further. So what if everybody on your whole team could actually directly contribute to your product and help build your application? Now, I'm not saying everybody is an engineer and everybody does everything, because obviously there's a lot of hard problems that you need engineers for. But there's also a lot of problems that you probably shouldn't need an engineer for. So why can't designers implement their own designs? Why do they need to hand us off Figma files and then we get it wrong and they come back and say, actually, that doesn't look anything like what the designer did. Can you please do it again, right? Why does marketers and product managers have to constantly ping us about changing labels on buttons, right? We shouldn't need an engineer to gatekeep the text on a button, right? Like that seems to be a simple thing that should be simple. The problem here is, of course, that I don't think the future is to rekindle the debate of whether designers should code. I mean, that's almost certainly also going to happen in the future, but I don't think that's the solution. So this leads to what I think is a more interesting question, which is the one that I've been working with for the last around 5 years now, which is when did we actually decide that a text editor is the best tool for creating visual applications? And I think for a lot of people, this idea of challenging code or text as the way we build application is quite foreign. Because for a lot of people, it's basically challenging what programming languages are. But I think if we look at what a programming language is, actually, I'm fortunate I don't need to explain what an AST now is, because that actually already happened in previous talks. But in short, it's an in-memory representation of your program in that language. So what a compiler actually does, it takes your source code, which is what you write, it creates this AST representation and then does a bunch of stuff, optimizations, etc., and then spits out this binary code that runs. So when we look at what a programming language is, we often look only at the source code part. But in reality, the source code is the interface for a programming language, and the whole thing is your programming language. So what I'm suggesting here is, what if we did this? What if we cut off the interface and just replaced it with something else? And in this case, a UI tool, a GUI tool that works directly with the AST of that bespoke language. And I realize I'm standing here presenting it like I had a big epiphany and invented all this. Obviously, this is not a new idea at all. The first example that I'm aware of is now this year 60 years old. In 1964, at MIT, they developed this RAND tablet where you could draw on a board, and you could create these sort of visual flowcharts. And it even had character recognition like 60 years ago. And this would execute, right? You could build programs this way and actually have them execute. It cost $18,000, so it never really made it mainstream. And that was in 1964 money, right? A more recent example is Visual Basic, which some of you might be old enough to work with. And here is a demo. Unfortunately, it's from the 90s, so the resolution is terrible. But this is a demo by Bill Gates presenting this as part of shipping with Windows. But the thing is, we never really made it to mainstream adoption. Like, this idea became popular, but it never really fundamentally changed how we build applications. Like code still is the dominant and really only way we build apps today. And if we have to look at why that is, I think my hypothesis is that there are 3 reasons why text and why code is still the dominant idea. And the first thing is flexibility. For a lot of these tools that have been built, they essentially work by limiting quite heavily what you can do. So they make it a lot more easy. They create these very high levels of abstraction. But as a result, you're also very held back in what you can actually do, right? And I think if you're picking a platform, you're going to pick the one that isn't eventually going to come and say, you can't build that feature. You'll have to start over, right? So we need the same level of flexibility in what we can build that you have in code. The other thing is collaboration. This is a big one. In code, we obviously use Git or whatever we used before that. And if you can't work together as a team, like it doesn't matter how good a tool is if it's a single-player tool, right? It's never going to scale. It's never going to actually solve the kind of problems we need. The first one, and I think this is especially relevant for the early days, is speed. Like it both needs to be obviously fast to build in it, but also more important, the end result has to be performant. It has to be able to perform comparatively to something written in code. And in 1964, where like hardware was very constrained, this was a huge problem, right? We didn't have the kind of optimizing compilers that could handle that kind of thing. And as a result, like it was always a little bit of a second-hand citizen. And so these are not easy problems, but they are like definitely solvable problems. A lot of them has already been solved for different kinds of technology. So I would like to show you what we've been working on at Totle, and our take on how this could work, specifically for web applications. And we're loading. Right, excellent. So let me just see. Here we go. So this is the Totle editor. So this is a visual programming language that has an editor. You configure, you basically build everything in. I say it has an editor. It technically has 3 different editors because there are different aspects of programming that it tries to solve. What you're looking at now is the visual editor. If you use something like Framer or Webflow before, this probably looks very familiar because both of those tools essentially solve that problem really, really well. The biggest difference, I think you'll notice, is on the left side here, you'll see everything we're showing here is just HTML. Totle is not about creating high-level complex abstractions on top of the basic platform. The web platform works really well. So this is mostly just an interface. And what you're seeing on the left here is going to be the output that the application is going to have. Like that is the HTML it'll render in the browser, right? On the right, you'll see our styling panel where we can go and change the style. And I wanted a little thing. This is actually not a particular relevant point, but I thought it was quite funny since the previous guys mentioned durable objects and how easy it is to sync server state. So since we're also running on Cloudflare, actually going and changing something like the color of the title here kind of just works and syncs across the network again, because these durable objects really does almost work like magic, right? That's not really an important part of my talk. I just thought it was really interesting that they mentioned that as something we rely really heavily on, right? So let's take a look at how this application works. I've obviously built a little bit ahead of time because I don't want to spend the whole time dragging images around. So what we have here is a very simple news app that fetches some news articles from a public available API, something called news data. And we can see here I have my API panel where I can specify all the information I want to send, like basically construct my HTTP request. And here on the right, it's returning this information. Totle is passing the JSON data so you can go through and see what's coming back, right? On my page, I can then go and take, for example, this list item here that represents our article. And I can go and say, well, I want this particular element to be repeated so that for every single news article, I want you to create another copy of this, right? And this sort of shows the second editor in Totle. So we had the first one, which is the visual, like the UI layout editor. And the second one here is what we call the formula editor. We kind of split up functionality, like programming into basically two concepts. Everything that's, if you're a functional programmer, this is what we call pure functions. Like this transforms data. I have an API that returns like a response, and I can sort of drill down into this and get my results out. And out, on the other hand, gets the final value. And I can also go and add more complex options here. I can say filter, and then say maybe I want to filter so only the items that actually have an image attached to it are included in this list, right? And so the formula actually lets you do very complex calculations, but in this relatively simple visual style. Now to show the other part, the final part of the editor, which is our workflow editor, I want to add a functionality to this app. So I'm just going to press the play button here, and we go into our interactive mode. And I've got this little search field here, but nothing happens when I type in it, right? So I want to add search functionality. So as I'm typing, it's going to dynamically update these results. Now, if I was to do that, let's say in React, the basic strategy here would be, well, I'm going to create some state. Then I'm going to grab an input field. I'm going to bind that to that state by saying the value and, well, in React states change in everywhere else input events, and then use that value in that state to fetch the data, right? And Totle works exactly the same. Like, as you say, there's been a conversion framework. There's a lot of really good ideas. There's no reason to change any of those, right? So Totle works on all the same principles. We did call it variables instead of state, but we can create here one we called search string. And I'm going to start with a default value that's empty. And then when I choose my input, I can go into attributes, and then under my value attribute over here, I have yet another one of these. These little FX buttons are sort of indicating you can use a formula. They're spread out all over Totle because almost anything can be dynamic. And here I can sort of map that to the search string. And then I can do the same with events. So this is as I'm doing my input. Now we did go against React here. This is called an input event as you're typing. So we did choose to stick with that. And then I can set, I want to set the search string. And this here is what you're seeing in the workflow editor. And this is basically a flowchart, not entirely unlike what the guy was drawing in 1964. You can add conditionals, etc. But essentially everything that has a side effect. Anytime you're going set a variable, call an API, update the title, any of those things, those are actions inside your workflow, as we call it here. Anytime you're just transforming data, these are formulas. And so here I can again use the formula to actually decide what data do I want to feed into my set search string. And again, I'm taking my target and value from this event, right? So everything here is like exactly the same way you would do it in React or quite a lot of other frameworks, just done with a visual interface, right? The last thing I need to do is, of course, inform my API that it needs to now actually search through this. So I'm going to open up this API right here. And our API interface here is very inspired by React Query, has a lot of the same ideas. So we call it auto-fetch, and it basically means it's automatically going to fetch the data when required. So if I'm going down in here to the query part of my interface, where right now it's marked with a Q, obviously it's dictated from the API. If I change this from the hard-coded value of AI to actually be a mapping to a search string, now if I'm going into search, and let's say we're searching for Frontend, as I'm searching, this automatically get updated. And so Totle works based on signals, like a lot of the new frameworks. So as I'm changing the variable, it realizes that the API needs to change. The API then goes, well, my data has been invalidated because they changed the search query. I need to now go and refetch that, right? One little thing we could quickly do before we start testing too much is add a little bit of a debounce value of 300 milliseconds. So we're not hammering the API necessarily on every single keystroke, but just actually updating at a reasonable interval. Now that I've done that, I'm ready to go and publish this application. And so Totle like most things today, works on a Git-like version control. It's not exactly Git, because our underlying AST model doesn't really fit too well with Git. But it's using all the same principles. So I was working in a branch. You can have infinite amount of branches, and obviously multiple developers can work on their own things. Everything here works just like you're normally working with code in a version control system, right? And I can add a little message, edit search, and I can go and publish my changes. And that will actually push them onto the main branch where they're live. And so now we can go here and say, I want to view my live app. And I can go into search and search for AI. And it's going to go and find news articles related to AI, right? So this is a relatively simple use case, obviously, a news site. But you can build a lot more complex things with Totle. I think where a lot of visual programming languages tend to be aimed either specifically for children, or a lot of times for either beginners or people who never really intend to have a career in programming, we really designed Totle to be for professional product teams first. So one of the other things we've built here is, oh, that's small. There we go. So we built this color picker, and this sort of showcase that you can build really interactive applications in something like Totle with a lot of fine-grained interaction and control, again, without the need to go and write code to do that. And this color picker is actually a package. So if you have a Totle project, you can go and install that into your project, and now you can use this color picker component. And of course, the community can build and are building a lot of these packages that sort of lets you, that you can share with everyone around you and basically build more complex things, right? The last project I'd like to show you is currently the biggest project in Totle. This is, wait for it. There we are. And so this is Totle itself. So everything you've seen today, the whole Totle editor and everything, is an application built in Totle. So right now you're looking at the main editor window here, running inside the main editor window. Yes, this does occasionally get really confusing when you're working on it. So we can see here, for example, our element panel here is the one we have here on the right. And I can double click into that and see all the different components that makes up this panel, right? So building something very large and complex means breaking up into 1,000 small components that you then combine again. And again, everything here, we didn't reinvent everything, right? Modern frameworks already taught us how to do this. You're going to have a lot of components. They're going to communicate each other through props and events or callbacks, depending on the specific framework. And again, Totle uses all those same ideas. Even our formula editor that we used previous to build these things, this is also entirely built in Totle, right? We're a relatively small company still. We only launched last year. But we're working full-time every day in this product, right? And one of the really beautiful things we've seen happening is that not only are engineers faster at building in Totle than in traditional code, which gives us a little bit of a speed boost, but the fact that our designers can go in the same tool and implement their own design, the fact that our marketer can go and actually build a lot of our onboarding flow, and change not just the copy, but it's actually diving into how to make a lot of these changes directly. Means that we sort of remove this engineering bottleneck where everything that always had to happen had to be, can you go and do this, right? We don't have Jira ticket wars anymore, because a lot of the time, whatever it is you need done, you actually have the opportunity to go and do. So that was my presentation of Totle. I hope you liked it. And you can go and try it today. It's free to try totle.dev. So if you're curious to play around with this and see what this kind of development could look like, please do that. And please let me know what you think.
Thank you very much. That was the sickest dog fooding demo I've ever seen. I was sort of thinking about it when you were demoing. I was like, is it possible that he's going to show that this whole thing is built in Totle? I don't know. I just got the vibe. Very well done. Very well played. All right. We're going to have Sam and Mo back here on stage. Maybe I'll help Juho. Yes. Let's not make this any more long and awkward than it needs to be.
That was that. Oh, I had to hard code in a block. But actually ask that question, it's a good one.
Yeah.
Yeah, please take a seat. Don't let me keep you waiting while I'm just single-handedly
Let me help you there,
carrying.
man.
Oh, thank you, Mo. Thanks for taking the hint.
Way to make
Jokes
us feel
aside.
guilty.
Oh, yes, all right.
Oh, you're very good at it.
There's a good set of beards here on the stage.
Yeah.
Yeah. Okay, so let's get started. First of all, thank you all for your presentations. Also, I thought it was interesting how much durable objects was sort of like featured across, these talks. Andreas, did you say that the collaboration here is built on durable objects?
Yes.
Yes. So there's a few questions about that. So let's maybe start with that, and we can talk about.
Before you do, how many levels of this Totle inception can you go into?
Oh, yeah, so I had to bring in, like there's a hard-coded limit of like it only goes 3 levels deep.
Okay, cool.
Because
It would be nice to
if
have a
you
Totle
don't have
within a
it,
Totle within a
and,
Totle.
Actually, my LinkedIn banner is a picture of that, of just Totle going, and it basically just kept going until it crashed.
Cool.
So we had to sort of put in a hard limit of saying you can get to 3 levels, which is the inception rule, right?
Cool.
So you can get to 3 levels and then no more.
Okay, cool. Sorry, honey.
No. Please talk amongst yourselves. We have time. We're just watching here. It's okay. Okay. So the question here, broadly is that does Totle support real-time collaboration like Figma? Yes, it seems to. If yes, how did you achieve it using which tools and technologies? And maybe I would also then ask, sort of on this, you showed a durable object demo of like basically syncing object from one place to another. But like, what are some of the sort of like real life challenges around building real-time applications with this? Andreas, would you like to start?
Yeah, so I mean, Totle does have real-time collaboration. It's not something we invested very much time in. So we definitely want to do more fancy stuff, like more interaction of live communication. In reality, we never work in real time together, because if I'm working on one feature, the other person's working on something else, and we want that to be separate branches, right? We don't want, live collaboration is basically everyone poking around at the same feature, and most of the time what you want is really async collaboration, right? So we do support it, like the updates are shipped. We've got a lot more stuff coming around that. We use, so Totle is hosted on Cloudflare, which we use both for server-side rendering applications. We use Cloudflare workers for that. We have a lot of data both in key value stores and different types of caching solutions with Cloudflare. And we use durable objects as the sort of immediate backend for the editor. So whenever you're connecting with a WebSocket from Totle to that object, every single branch has its own unique version that's globally the same, right? So if we're working on the same branch, we have a live collaboration session. If we're working in different branches, we have different sessions, right?
So in this demo that you guys built, for example, how would you handle things like multiple people editing the same state simultaneously on multiple devices?
Yeah, so it was obviously a fairly naive demo where basically just any update would come in and overwrite the previous update. But I think it kind of depends on your application use case. For a lot of cases, actually just the last update winning is enough. So things like Google Docs will have like a central sync server. Every update will go through that, and they're just kind of ordered like that, and that kind of works. But if you want kind of something slightly more dynamic, you can look into CRDTs and things like that, which will be able to reconcile differences, across different devices. And it really just depends on the consistency model your application needs.
And I guess everything bar the final update, the final demo that we showed, similar to what you were saying, it suffices by having some sort of just async updates. It's just making sure that things are synced across the board. It doesn't need to even be on WebSockets, right? It's just having a primitive on the edge where you can store some of that session data and then sync it across different devices. So there are some use cases though where something like a CRDT might make sense.
That makes sense. And then to continue the Totle example, you said that you typically don't work, synchronously on the same documents. But, how would you prevent overwriting someone else's work? Like, if multiple people are working on the same things. Any diffs tools or visual PR reviews, anything like that?
So for the version of live collaboration we have now, is fairly simple. Like we literally didn't want to add it, but it turned out it was so easy over durable objects that is almost like, look, I'm going to spend an hour and figure out, can we propagate live, because that would be cool, right? So it wasn't really in the roadmap or anything. It was kind of a side note. As a result, it functions the same way. Like the fact that the time is so fast from you make a change to the propagates, and because it's always local, means that we can actually kind of ignore some of the really deeper problems. But also generally discouraging people from doing a lot of live collaboration because it's not there yet. And the next level is adding in CRDTs to handle some of these sort of collision issues, right?
Yeah, this is a very interesting session. I just came to this conference from Athens where I spoke about durable objects. So this session is very much not sponsored by Cloudflare, but it seems like we're a bunch of enthusiasts here on stage. All right, let's jump into a different topic for a bit. Let me do this one first. How do you like to handle authentication for server-driven UI? Like, are there any particular patterns or problems around that?
I mean, it's very similar to what you would do for any other application. It doesn't really make that much of a difference whether it's server-driven UI or not. It depends on what you're, so let's take the example of personalization here, right? Every single user needs to authenticate, and then they'll have a custom set of layouts that are generated for them specifically. It just means that that logic will be handled by your backend. Now, it's not to say that, oh, you've moved some of this logic to the backend and it's suddenly magically gone from your entire stack. I personally don't believe that. I feel like I like to make the example of the law of conservation of energy and just change that to complexity, which is, you can't magically just destroy complexity. It needs to kind of be shifted from one part of your stack to another. And that's all that's happening here. But in some cases, that trade-off is worth taking a lot of that logic that you would previously handle on your front end for that authorization stuff and knowing which things to pull into the layout and just move that over to the back end, and it ends up making your front-end code significantly simpler. But in terms of the process, I don't see any major differences there. I don't know if you have anything to add on.
No, I mean, effectively, you're making a call to your server from the client, and however you're doing client-server authentication, the same method,
thing,
cookies, headers, MTLS, whatever you want to do.
Makes sense. So, beyond collaboration tools or something where, multiple people are editing the same document, are there any use cases for this kind of sync server states approach? Like here we saw like individual user session being synced between devices. Like that's one use case.
Yeah.
Then in Totle we see multiple people collaborating in the same document. But what else is this kind of syncing server state approach good for? Are there other patterns that you would recommend it for?
Do you want to go first?
To be honest, I think that kind of covers most applications. You either have a single user session or you have a session shared across multiple users. Yeah, I think that kind of covers most applications, to be honest.
I mean, I think like we were kind of hinting, though, in the talk, those micro interactions can make or break an application. I know a number of times where I've gone into like a modern application and there's syncing issues between the web interface and the mobile interface, and either they're not synced for whatever reason, and there's like minute differences in the UX, and it really messes with your head because you've been conditioned as a user for the last 10 years for all of these things to be personalized and synced across the board, and when it's not, it's blatantly obvious to you that it's not synced. So maybe it's a bit of a stretch, but I would say it's actually like a prerequisite of having a good, modern, and future front-end application. And I'll keep doing that pun until someone laughs.
Nice. Okay, so we have a whole bunch of questions about Totle, but before we get to those, let me close the chapter on this sort of syncing state thing. I think there might have been some sort of like misunderstanding around the statement that, sort of like edge or durable objects, fixes the issue with the speed of light. And there's a question about, how is propagation of state handled across the globe? How are race conditions handled? How, does this cause lag or latency or flickering, etc.? But I think there's a different answer to this.
Yeah, I mean, fundamentally, the speed of light is, you can't get around that. So if you do have a user in Sydney and a user in Helsinki and they need to collaborate with each other, you're going to have some latency. The thing that the edge helps with and things that kind of durable objects help with is primarily the kind of, the user session thing. So if you have multiple devices, your devices are probably close to each other geographically. And so they'll be talking to the same server very close to them. And that will kind of fix the speed of light problem there. Or if you have, a bunch of people in an office collaborating, or you have a bunch of people geographically collaborating, or a bunch of people in a chat room, say, that are geographically relatively close. this will fix the speed of light issue there. But fundamentally, if you have someone in Australia and someone in New York, they need to talk to each other, there's going to have to be a round trip there. We can't really get around the laws of physics, unfortunately.
Yeah.
I actually, because obviously we use durable objects and had a bit of the same question, but I think what I think is the coolest part of durable objects is the fact that it's not centered around a data center. And it'll dynamically relocate that object if it sees that to make sense. So the fact that we live in different time zones actually solves part of the problem. Because it says when your team in Australia is working on something, well, they're going to be roughly, like they're not going to be an exact opposite side of the planet because they're probably asleep, right? So in reality, it does always move it. And that object, if it figures out that it's not in the closest data center to all of the connections, it'll relocate that object to a different data center dynamically, right?
Samuel, is that something that's available now? I remember when I last looked into this, that was more like a documented...
I'm actually not sure if that's available yet.
Yeah,
I have to double check that.
Yeah, sorry, I don't mean to...
It's on your marketing page.
No, exactly.
It was definitely in the initial blog post.
So this is where
it's on the website.
This is where I prove that Cloudflare is not sponsoring me or this session. Sometimes their marketing can be a little ahead of the implementation. Yeah, which is, of course, undesirable, but sometimes happens. Okay, let me do a few quick-fire questions about Totle. We have a lot of these, so we can sort of go quickly. So firstly, how does Totle handle accessibility? Like, is there any affordance, like particular affordances for accessibility?
So the short answer is it handles it kind of the same way that HTML does, is then you have the full power to do all of it, but right now we don't really do much for you. So it's one of their, like building a tool like this, there's always a million things you could add in. Like you now have this platform to build incredible, useful tools into your workflow. And I mean, accessibility is one of those, right? Validating, first of all, just basic validation in real time, showing you, you added an image and it's lagging an old attribute or anything like that. But there's a lot of places we can take that. So we have big plans, but we also have a team with a long list of priorities. So right now, it's the same way as if you're working with anything else. We're kind of, for the moment, leaving in your hands. But you have all the same flexibility. Like you can do anything in HTML or in Totle that you can do in HTML to add this kind of thing. Right?
And what about internationalization? Is that something that you support in Totle? Like if you have different UI languages for different...
Yeah, the editor is not localized in any way, so that's very much still English. But the applications you can build, and again, like Totle very much just piggybacks off the web standard whenever possible, right? We kind of have a principle of like, we're not going to change it unless we can make something that's like a lot better, right? So if you want to build in internationalization, you can use all the same APIs that are available in the browser. You can use whatever third-party system for internationalization. We use Contentful for our blog, etc., and it has pretty good internationalization and localization support. Maybe not according to the TC39 people working on that. I think their level is a little bit above what everybody else is doing, but for the common folk, I think they do really well. Right?
So the solution is to load the UI content text from a CMS? Yeah. Makes sense. Okay, one more question about basic hygiene stuff. So testing, how do you test Totle applications or applications built with Totle?
Yeah. So this is a really good question. We get it quite a lot, and we don't have anything built in around testing. And obviously, you could use any automated testing system. Like at the end, it spits out a web application, so you can run anything you want against that to verify. What we found is that we didn't need it as much as we thought we would. So we're still obviously testing a lot of things. We have some automation in place for verifying. But the fact that you got this instant feedback, not just when working with the UI, but also when working with formulas. Like it's very comparable to programming with a REBL, which is, depending on what language you've worked in, is either completely foreign to you or completely standard. But this idea of like, for every line of code you write, it evaluates that and shows you the result. And Totle works the same way with live data. So every time you update a formula, it'll show you the output and essentially run that through. And that actually means that a lot of like the normal unit testing you would do to sort of verify as you go becomes less relevant.
All right, a few more Totle quick fires and then we'll go back to server-driven UI. So is the working area in Totle an iframe?
Yes, it is.
Great, that was quick. I like that. Let's keep that pace. Yeah, a lot of compliments about the dog fooding, which I also I'm very impressed by. Can you? Yeah.
I would actually like to talk about, because the funny thing is that it almost sometimes sounds a little bit like a gimmick. But the point of that wasn't really hear everyone see what Totle can do. It was actually that I was getting to a point where I felt like I had something that worked. This is like way before Totle became a company, right? I felt I had something that worked and I could do demos. But you're always sort of in this like, but does this idea scale? Like, what happens if I'm building something large? And so it really started with me trying to prove to myself that Totle worked before anyone else.
It also happens to be an absolutely killer demo, you know. Yeah. You know, just the benefit. Yeah. Okay, so how vendor locked am I if I use Totle? Like, of course, the UI itself is, you know, bespoke, but like the output that it creates, can I then start to hand edit it and etc.?
Yeah, so Totle does not generate code in any sort of readable format. Like right now, it's more of an interpreted language. It's easier to see Totle as a bespoke programming language with the output of HTML, CSS, and JavaScript. But those things are, at the moment, interpreted by a runtime in the browser and not actually spit out to a final result. So at the moment, you can only run Totle applications through our, like, that are hosted by us. We are looking at changing that going forward so that you can also self-host your applications. So that's something we'll announce at some point this year. We also support like exporting, like any component, like the date picker you can see, can also be pulled in as a web component. So every component built in Totle is compatible here, and you can just grab that into your existing like JavaScript or whatever environment you're running in. And as such, let's say you wanted to move off Totle, or even better onto Totle. You can do that gradually by basically saying, I'm going to start adding in more and more, move more and more app over to this Totle web components, and eventually then go and say, now I'm going to actually switch it over, right?
Nice. So just to confirm, since this answers a question here, like you can publish just components from Totle and integrate them into an existing code base, so it doesn't, the whole app doesn't need to be built in Totle.
No, it doesn't. And we have a lot of users actually that are mostly doing, like a lot of agencies that are doing a lot of Webflow sites for their customers, but are like hitting these limitations of what Webflow can do. And this ability to just drop in a web component built in Totle that basically solves everything for that particular area. So it makes their life a lot easier, right?
All right, that's nice. Now let's give Andreas a moment to breathe from all that quick fire and then go back to the server-driven UI stuff. Firstly, were you trying to indicate me that you have an answer from the team?
I do. Unfortunately, durable object relocation is not yet available, although it is planned for the future.
Yes, maybe you can, somebody can open a PR, the documentation.
It is in the documentation. It is in the public docs.
Okay, great. Makes sense.
Admittedly, it's a footnote, but still.
Yes. Okay. Yeah, but that's funny though, because like I remember the first time I heard about durable objects, I also had the impression that that feature was available, and so I don't know, it's kind of like stuck into the, you know, the zeitgeist. Okay, so back to server-driven UI. There's one question which I really like, which is, would server-driven UI benefit from a new type of tooling to support this type of development? Like, what is the real sort of like state of the art in terms of you want to build apps like that? What tools do you use, and what is sort of needed? What's the gap?
I think in practice, what you often see it is people use sort of headless CMSs for that type of thing, and they just output the data in the right format and then architect their code base around that output, and they defined their component boundaries well in that space. I've thought a lot about this, especially around mobile development, because this server-driven UI concept gets a tad bit more complicated when you're dealing with mobile apps, because you can kind of render native components in any layout that you want, but then you're dealing in the mobile world with bundles being out of date, so you have a version of the app that doesn't support a new component, and your server's telling it, render this component, but that component doesn't exist in version 1 of the app, but you launched it in version 2 of the app. So it gets a lot more complex, and ultimately, what I've landed on is there's a real good opportunity for some CMS to come here and become sort of server-driven UI first and mobile first in that capacity, and handle some of these edge cases, some of these slight behavior differences that you might exist. I mean, one common reason that, let's say, Airbnb uses server-driven UI is because they've ditched cross-platform as a technology, and they've actually decided we're going to abstract a lot of that behind into the server-driven UI space. So they have very similar looking components, but they're written in different technologies, but they can still handle the layouting together. I think there is probably a space for tooling, but it oftentimes ends up being that people build it bespoke, and it's not standardized, and there's a lot of edge cases around it. So that's kind of where my head is with that. RSCs are an interesting one as well. So I've gone into a little bit more detail in another talk where I go just into server-driven UI. And RSCs are actually, I think, a subset of server-driven UI. So the whole concept of server components is in itself, when you just tell that story individually, it's not actually a very comprehensible, understandable story. But I think when you put it in the context of server-driven UI, it actually starts to make a lot more sense.
Yeah, we actually have a specific question about that, which is that, instead of home rolling, on the client, the rendering framework for server-driven UI, and then like the JSON payload format, could you implement this on top of React Server Components payloads? Yeah.
So the way that I look at it is right now, and I'll try to go through this as quickly as I can. Right now, what you're doing is you're computing a lot on the server, and you're calculating all of those layouts, but then adding all of the props and the data that's necessary to render your full page, and then sending that through one big JSON blob. Okay, that's a lot of data to compute on the server before you send that response back. So your FCP and your TTI are going to be not very good. So what can you do to combat that? Well, what if you just sent the layout only, and then each component was responsible for individually fetching its own data, and that could potentially be a good optimization, and so you can start streaming in components. All right, what if we take it one step further? The next step that we can do it is, what if we just fetch those data for each of these individual components on the server individually, made a database call, and then serialized and sent those components that were rendered on the server across the board. And I think that's where it fits into the story. It's like the end state optimization. But then you still need some level of flexibility in terms of the layouting and which components get rendered where. And I actually think when you use server-driven UI plus RSCs, it helps set the component boundaries quite nicely, because you have to think about that, and you don't make the mistake of accidentally converting your entire tree to client components because you've put a use client somewhere far up and you've not thought about how you lay out these components together. So I think they go very much hand in hand, and it's just a continuation of one another.
Yeah, I think, to sort of like, just to riff off that point, I don't know if this is a question or a comment, but hopefully you have something to add to this, maybe Samuel. Because, Cloudflare seems to think durable objects is like a data product or a storage product. I mean, if you go to the Mark website, you need to go to the storage category and find it under there, next to D1 and R2 and, R3 and all that, R2. But then for me, it's a compute product, right? Like it's you deploy your custom code that lives in the same place where the synchronous state exists, which actually gives it like an interesting quality where, like the code and data sort of like coexist in like a very, like an easy to think about program way. So could a durable object be your, essentially your RSC server, your React component, server component server, where the logic is co-located with the state that is actually shared between the clients?
Yeah, absolutely. I think I saw on Twitter that Sunil had managed to get the Remix server running in a durable object the other week, as pretty much that same thing, rendering RSCs in a durable object. But I think one thing that server-driven UI kind of falls down in is that the name is server-driven UI, which implies there's this server-client boundary. But really, it's about kind of separating the layout data from the layout code. And it doesn't really matter if that happens on the client or in a server, in a durable object, or whatever. It's more that you can kind of change the layout logic on the fly, almost. So even if you're rendering it as RSCs in a durable object, it's still that same kind of separation.
All right, that makes sense. I'm gonna do one more question regarding, sort of Cloudflare durable object-y things, and then we can hop on to a different topic. So this question, which I hope you understand, is how different is the edge approach from cloud-indexed databases? So I'm assuming this is something to do with replication, like to different cloud locations.
I'll be honest, I have no idea what cloud index databases means.
All right, I don't really know this either. Does anybody, do you want to specify what are cloud index databases? Anonymous? Oh yeah. Right. Did you hear the question? Okay, I will repeat to the best of my ability. So basically, in the same way as you have like IndexedDB in the browser, there are some data sync solutions that you run these IndexedDBs in the cloud, and then you sync the state from between client and server. And this seems like it's a very similar approach to as what you've implemented.
Yeah, absolutely. That sounds very similar. Durable objects are kind of more of a primitive than a high-level product, and so you can absolutely build that type of thing on top of durable objects.
Nice. If we didn't get the answer quite right, you can come and ask afterwards. All right, let's see. Let's do another Totle quickfire round. We tried to put these themes sort of like in a thematic way where we would have a lot of shared things, but Totle turned out to be such a very specific topic that I feel like our esteemed colleagues here can't really have a lot to say about it. I think you're the ultimate expert. So
it's great. That's all I can say about it.
Yes. Let's do this.
I mean, we can make up some answers if that's helpful.
Yeah, let's say, yeah, okay. So for every Totle answer, I want Samuel to also make up an answer.
Good.
Okay, great. So yeah, how well does Totle handle version controlling? Is it built on Git or other version control approach, or?
Do you want to?
Yeah, so Totle has excellent support for subversion, and it's really key that we go back to our roots.
Yeah, Samuel is like a large.
Close. So this sort of was a long rabbit hole at the time because obviously I knew right away that I needed version control like Git, and I spent a lot of time hoping that Git would be the solution, but I never found a way to make Git entirely run with a custom diff algorithm. And since Totle essentially stores everything as large JSON documents, I needed a custom algorithm for diffing, and as a result I ended up having to do a whole custom version control system. So it is based on me spending almost a month diving into how Git actually works, which is a fun month to use, by the way. Definitely recommend it. And then essentially replicating all the same style logic in procedural SQL in Superbase. So it's running in stored procedures in Superbase version of Git.
That sounds insane.
I really had to tell myself many, many times, there's no way this is the smartest idea, but...
And you're trying to convince people to put their data on this? Maybe you shouldn't tell them all this.
No, it's the Superbase going to eat it all. It's the future. No, so the real reason was the basic idea of this sort of blockchain, if you will, approach of how Git stores, where every commit references the previous one, and actually finding out what the common shared ancestor is based on walking back this chain of commit hashes or commit shares. Really means that doing a traditional lookup and trying to find out what's the common ancestor actually becomes quite difficult. So you either need to fetch an enormous amount of data or you need to make like a lot of requests. And Totle, you never really have to worry about commits. We don't ask you to commit. What it does is actually runs on a 10-second automatic timer. So any updates you do within a 10-second window gets bashed into a commit. That also means we have a lot of commits, and performance is something we have to take care about, right? And the fact is that a stored procedure can just do a ton of really quick fire database lookups to do things like finding common ancestors.
I mean, it sounds like you've kind of implemented a version of event sourcing for, like, you can create the state of a Totle application through a bunch of events that are stored in a database by replaying them to some degree, right?
Almost. So Git isn't quite event sourcing because it never actually, it doesn't store the diff. It stores whenever you update a file, it'll store the new file, but then the actual whole file structure tree
can be compared.
So if I'm changing one file, it'll essentially, I can have a whole new snapshot of my files, but for that new snapshot just points to the old version of all the other files, right?
But do you keep the snapshot run? So could you revert to any arbitrary old version in the history?
I can go back to pretty much when the Totle editor started. Yeah.
Nice.
Our UI for this and our tooling for this is still very basic, right? So we're going to add a lot more, but the underlying technology allows us to do all this, right?
Do you want to go first?
What about branching and like different branches per user?
So you can have as many branches as you want. Right now, we added in a limit where you can only branch off the main. So we don't really support full Git-style branching. And again, that's something we could add, but we did it a little bit intentional as in saying, let's try and and push people in one direction. A lot of our users are also not programmers. So there is a little bit of a case that if you give them complete free range, you're adding a lot of support for yourself. So there's sometimes where we sort of held back and say, like, I don't think we actually I don't think we need this. I don't think this is necessary. And I think trunk-based development in most cases has sort of been accepted as the norm anyway. So that's the only thing we allow for now. If we figure out there's a reason to add like more freedom around branch creation, then we can add that in.
One thing you mentioned, performance, just a couple minutes ago. I'm curious as to like the exported code. If you run any benchmarks on comparing a React app that's built or whatever other framework with the code that you've generated from Core Web Vitals, Lighthouse Score, like how does it perform, I guess, comparatively?
We haven't done any like real one-to-one studies. But generally, I like to say the performance is quite similar to Next plus React.
Okay.
And of course, there's a million different ways that can differ based on how you build either of those things.
And is it all going to be client-side, or can you move part of it to be server-rendered before or statically generated ahead of time?
So we do server-side rendering of everything.
Okay.
All the pages. You can then pick in whether you want like specific APIs to be part of that server-side rendering.
Okay.
So maybe I want this to be fetched, this data to be fetched on the server as part of that rendering, or maybe I specifically don't. Like if you have APIs that you know are slow, it might make sense to render it first and then go and do the request afterwards, right? So the users not hang.
Cool.
But so everything is server-side rendering. There's still a lot of opportunities for optimizing. Like basically Quick, I think, is leading the way on what this strategy should be. And one of the nice things about having a bespoke program language is that Totle, the language features underneath are really, really simple. Like there's not that many things you can do because we don't need syntactic sugar when there's no syntax. So it's a very, very simple language, and as a result, optimizing it is generally a lot easier than like JavaScript, which is a terrible language to try and optimize for. Right? Like that literally, as I say, there's a lot of PhD student bodies that's been thrown on that fire. Yeah?
So speaking of the language, like how powerful is it like in terms of like conditionals? There's a question here, like does it have feature flags and A/B testing? So I'm assuming if you use a third-party A/B testing framework, you can integrate that. But like, can you render completely different types of content or app dynamically based on,
Yeah,
feature flags?
I mean, in terms of flexibility, the easiest way to think of it is probably something like a framework like React, right? And it actually has a lot of the same both capabilities and limitations, right? There are things that React doesn't do, where you go, I'm going to go and write this in JavaScript that has nothing to do with React, right? And Totle is in many ways the same way. There's a lot of browser APIs that are not natively supported, but it's really easy to write a module or package that uses those, and now you can use them in Totle, right? So I think in many ways those are kind of, like there's more or less a one-to-one. And in terms of capabilities, the most complex project I've ever built in my life, without any close second, is Totle. Like that, the complexity of that application, I think we did count it. At the like worst case, we sometimes have 2,000 components on the screen at the same time. If you're the person that like opening everything on a large app, right? Like there's just a lot, and it's all dynamic because the whole side tree of everything, like that depends on the data you're loading. Like almost every part of it is extremely dynamic, and there's a ton of components working there. So it really does give you the flexibility to build like anything you can imagine. And again, limitations are similar to React. Like if you want to build stuff in Canvas, generally it's not React. Like with the asterisks, of course someone built that. But generally, it's outside of the sort of realm, right?
Nice. Well, we do have a few more questions, but we don't have time to get through all of them. So I'm just going to ask the one that I am the most curious about, and then we'll finish on that. Why is it called Totle?
I don't know. My wife came up with the name, and I had gone through a million different ideas of what I wanted to call it. My daughter's suggestion was finmad med flæskesteg, which is Danish and mean a thick sandwich with pork. And they were like, okay, I like this idea. This is good. She was 4 at the time.
Okay, that makes more sense.
So I like this idea. It's like, okay, but that's a bit long. What if we reduce it down? And I realized, damn it, Figma beat me to it. So we ended up with Totle. as a name. There was an early version where I wanted to call it Web 3, because I had this idea that it would be like, well, we had Web 2 where everything is built by Facebook, and then Web 3 is like now more people can build, and then it turns out someone kind of hijacked that.
Yeah, it's always a little too late to get names.
Maybe it's Web 4 would
Maybe
be,
you should call it Google. Okay. All right. Well, that was all we had time for. Thank you, everyone, and thank you for all the questions and participation. Let's go have some coffee, and we'll be back here in a half an hour. Thank you very much.
test.
Hello, hello, hello. I see people still drinking coffee back there, but I'm gonna keep making noise to attract the crowds. Don't know if it's gonna work. Oh yeah, conference days are tough, like afternoons. Are we all still awake? Yeah, kind of. Luckily, we have super interesting subject. Well, all of them are, but maybe a little lighter one for the afternoon. When AI meets design, and our first talk is from Thais, who's been speaker in our conferences for many times. Yeah, 3? Yeah, 3 times, yeah, and we love her. Her talks are always so intriguing. It's about how design, now development, what? Influence design. She's a designer at TomTom, like she's one design system Marvel. And I mean, I think we could start. Please give up for Thais.
There we go. All good. Thank you for the introduction. Welcome, everybody. Hope you enjoyed your coffee. I certainly did. The day started early and with some very heavy subjects, and to be honest, to me, very tough to understand, since I'm a designer. So let's end the day with a bit of a lighter topic, and I would like to bring to you this design and development synergy, and how it has influenced our world, my world of design, when interacting with developers. I assume a lot of you in the room are. So let's get started. The digital product design landscape at TomTom has a lot to do with map data. And as a designer in TomTom, we basically bring that data, things that developers are constantly working with, the SDKs, the APIs, we bring that into the visual and the interaction to the end user. So our day-to-day experiences in TomTom is basically, as a designer, involves a lot of aspects of how to visualize this information. But you might be wondering, TomTom, are they still around? So for those that live in Europe for a long time, back in the 90s, or I would say early 2000s, TomTom was really big because they developed, invented a little device that we would have inside our cars. I'm originally from Brazil, so I didn't really get to know TomTom as a brand like this. But of course, things have changed since smartphones became a thing. But that meant the company just had to evolve, and they're always moving towards the future of mobility. So it started off with the sat-nav, and it evolved into the real traffic data that they started collecting. In 2009, we had the first sub-500 device in car, embedded navigation solutions, and in 2011, we had traffic indexes introduced. Moving forward into 2015, we launched HD maps that helps us with automated driving, really on the forefront of how we are doing driving these days. In 2018, that's where it's interesting for you guys. That's where the SDKs and APIs came in, and we started making it that anybody could develop with this map data. In 2021 is where it became interesting to me, because we introduced the TomTom Digital Cockpit, which is the in-car experience that I'm going to show you more about. And we are very proud at TomTom that last year we launched the Orbis Maps, which revolutionizes the idea how we bring proprietary data and open source data into the map industry. So TomTom is about navigation maps, HD maps, and maps for assisted driving technology. It is also about the real-life traffic and live service data, and a lot to do with EV services as well. And these are all interesting aspects for you to know, because it's where then a designer at TomTom will start having the challenges in how to make this visual in an interface. The navigation SDK is basically bringing all the data together for you to use in your different applications. And the digital cockpit, the in-vehicle experiences. Moreover, we collaborate with a lot of brands that are very known around the world, and that's how TomTom managed to keep itself relevant for the past 30 years. In the end, as industry evolves in any sector that you're in, the partnerships will enable you to continue being relevant in this world. So I would like you to take on a ride, since we're talking about maps. And in this ride, it's going to be in Amsterdam, where I currently live. So I'll take you through a little ride around the city center. But there are 3 things I would like you to take with you during this ride. Remember that the development terminology is useful to your designer colleague. We basically need to speak the same language. So don't be afraid to share with your designer colleague terms, words, and overall processes that you are constantly working with. Second thing I would like you to take away from this talk is design systems should really be called design systems. It's not fair to have such an important aspect of digital product development being called only design, since it really involves the developer and the designers in the team. And finally, if you want to get stakeholder buy-in for whatever you're working with, you can get that more easily if you have a lot of visual examples. And that's where your designer colleague can really help you with getting your ideas across to the people that will actually have the money to afford your ideas. So let me show you the designer's role. And that is a big spectrum. It ranges from moving pixels. You probably came across one of your colleagues like spending hours deciding if it's 1 pixel up or 1 pixel below. It moves from that to actually problem solving, right? We have to come up with ideas and interactions from the issues that we want to solve. And that involves a lot of design thinking. So design thinking is a very interesting methodology that was brought by Tim Brown. Well, he didn't really invent it. They made it more popular. And it's really this triad that we have to constantly keep in mind as designers. And ideally, anybody in the company actually should have that in mind. You need to consider the user desirability for what you're producing, the business viability, and the technology feasibility. So you need to talk to your business owners and the people with the money, like what is it that you can invest on? You need to talk to the developers to know about the technology and the issues that you might encounter with that solution. And ultimately, you need to have the user in the center of what you're doing. And at TomTom, we take this role as a designer with the mindset of a design thinking, and we mostly work with these principles in mind. So this is all the background and the theory behind the day-to-day tasks that I will walk you through as well. So we design for driving. That's very relevant in our specific industry, because actually we don't want our end users to be distracted. So the less information on the screen, the better, because they need to really be focusing on the road. And that is the most important principle whenever we are coming up with solutions to representing that data. We also aim for lovable experiences. In the end, for any product, digital product that you're working on, the end user needs to love that, so that it becomes enjoyable to interact with your product. And that goes also for the fluidness of the interface. Things need to interact with each other seamlessly. And you can imagine, in a very complex product with many steps, you have different designers working together, different product teams developing those things in parallel. And so things really need to communicate to each other and fluid nicely. So that is also one of the principles in the back of our mind. And we try to balance the consistency and the adaptability of our interfaces. And that's where design systems is really important. But why do I care about this synergy? A little bit background about myself. I graduated in product design in 2012, and I've done from all things like designing a chair to actually a product made of plastic. I don't quite remember what it was. But very interesting course where you get to see a little bit of industrial design in practice. But the web kind of always drew me in. And I'm lucky and glad to be in the tech industry because it does give the opportunity to actually go beyond, especially with AI and the way things are evolving now. And I care about that. In 2019, I was lucky to join a design systems team. So I understood now this idea of technology and design really coming together and speaking the same language. Also, coming from Brazil, English is not my first language. I learned it as a second. So it kind of feels like computer languages and other languages are a fun thing to do for myself. And it's also what Zach is going to talk about later with the Finnish language. So all this is because I think design and development will really go hand in hand in the future. And in our previous talk, we could even see how new tools are being developed every day to make that transition even more come close together in the future. But ultimately, I think if there was a meme to represent me, it would be more or less this one. I feel like starting from a designer, and by no offense if you're a designer, I don't think any less of you, but working with design systems is kind of the ultimate one. So let me show you a little bit about the processes that we have inside TomTom. It's a combination of different methods and frameworks. So what I told you about the design thinking is like what we have in the mindset of our daily tasks. But really, it's interesting to see how we try to combine this with our daily activities of working in a team. And you probably come across this graph before, and where we have these phases of constant iteration. And a lot of keywords that developers are also familiar with, of course, being agile and a lean startup process to work with. So we do have that at TomTom as well. We have this phase in which it needs to be defined normally by the business owners or the product owners, where what is it that we want to achieve? We need to empathize with the user. And then there's a lot of ideation, a lot of attempts and tries. And the tools that we have today really allows us to get that very fast. And eventually, we hand it over to development, and we get to see that in the end product. So breaking it down a little bit further, if we were to think in a streamline how it would work, it's basically this. We have the problem to solve and outcome definition. So obviously, always start with why and don't waste too much time not knowing what the problem is because you're just not going to get the result that you want. And there's a lot of ideation, a lot of measuring the impact and learning from it. Eventually, we agree on the hypothesis and solutions, and it's ideally to have a developer involved in this process as well at all times because a lot of the technical issues can actually influence these decisions. And this is the continuous discovery phase that we are working with. We are validating these things with prototypes, and our design tools allow us for creating more or less prototypes that work, not perfectly, but it gets us at least to a good stage, to finally go to development and deliver. We don't want to waste too much time developing things that haven't been validated with end users, and that's where your designer colleague can be really useful to speed up the process and save on costs from development. And here are some of the tasks and activities that our designer colleagues at TomTom will go through. We iterate and collaborate to create these successful design solutions. We have some designers in our company called interaction designers, and they're the ones really focusing on the wireframing. Really, what am I button going to press to do A and B? And we don't worry too much about how the interface looks like at this point because we want that delightful and fluidness incorporated on the actions. From there, we get the visual designer to actually start putting it into the end results of our UI. So high fidelity and prototypes come from here. There is a lot of iteration between the two types of designers as well, because a lot of the times when you end up with a visual design, of something that was mocked in a wireframe, it impacts some of the decisions from the wireframe. You might not have enough space because that button is bigger. So this is where that continuous discovery process also happens between ourselves. And that's where we have a lot of reviews and alignments to have this validation of, is this working? Do you agree? In the end, TomTom has about 60 designers, so that's a lot of people working in parallel and pretty much on the same product. And so we need to make sure that things are aligned. And finally, a lot of user research. So of these 60 designers, some of them are dedicated user researchers that they will define the problem and they will recruit testers to put these ideas into practice. And here we have a picture, actually, in an in-drive car. It's an interesting setup. They have about a tablet with our product, a phone with our application, cameras everywhere, and then we ask a person to drive from A to B and see how they interact with that interface. Very safely, of course. And with all this, we also need to do the handover. So the designers prepare all those files together, and I will tell you more about the tools later. And this handover is then that step of delivery, where the developer can then continue with the coding and putting the data now in an interface. And that's where the TomTom's design system comes in. It's in the handover process, and a lot in the visual design process as well. Because the TomTom design system is basically a tool set that enables both designers and developers achieve these end results, these end design results quicker. It's the foundation. So if you're not familiar with design systems yet, and let me call it dev design systems, because I think I'm going to cone that. It is a tool set that is composed of libraries, documentation and guidelines. You really need those. The coded components, obviously, that should match these libraries that normally are design assets. And in our case, our design system is also a white label solution, and we also provide customization tools with it. So more on the white label. This idea of white label is basically the fact that TomTom is selling a product for other companies and not for end users. So even though our designers are thinking about people like you and me driving in a car, TomTom's actual clients are the car makers that are going to implement that product in their dashboard. And so the design system needs to be one that can be easily customizable. So if you think at it, it's like one template, but many ways to fill it in. And you have there an example of a button, the classic design system example. And ideally, we should be able to achieve all these different results without having to touch code, hopefully. So the components can be personalized to a certain degree. There are some things that cannot really be done, even though the client wants it. But those limitations shouldn't stop for quicker time to market when implementing our product. And that's, those customizations are possible because of these points of customizations. So they are properties that enable the style flexibility while the component maintains its core functionality. You might have seen these elements also being called design tokens. And that's actually something that in the design system industry is coming up more and more, because we are now adding this layer of abstraction in how we design and code to think in a way that it should all be solved with these exchangeable strings, let's put it this way. So all these little points should reference a specific style that could be swapped for anything else. And in our design system at TomTom, we have a token structure to set that up. We actually separate it in 3 layers. We have the global layer, the system layer, and the component layer. So the abstraction itself of the UI can be defined in tokens, and they can just be random or words that describe exactly what you're seeing on the screen. But we actually make it that you can have these layers of abstraction to achieve different results in more comprehensive way. So that actually we don't want to allow anybody to just decide that a button is blue, but the switch is pink because they wanted to. There should be a system in place also for the harmony and the consistency of the user interface. And basically, these tokens reference the colors, the fonts, the sizes, spacings, the shadows. Moreover, what you get to see, and this is a screenshot of our asset that designers get access to, basically, it's more or less the design tokens that we have documented, because they are now accessible through a feature in our tool. The feature is called Variables inside Figma. And here, the designers can have a look at what we want or what our system has available to them. But they don't really have to think much about this, because once the design system is set up, then they can just move forward with putting together the screens that they need. We also provide all the resources. So in our case, our design system is for Android specific, since the automotive industry works on Android, which is a shame for me. I have a lot more experience with web in my past, in the past companies that I worked at. So the Android brings an extra level of complexity when thinking about design systems, but nevertheless really interesting to work with. And we also provide templates for navigation. So we go beyond just giving the basic switches and buttons and inputs. We actually provide templates for designers to put together these screens much quicker. And here's a screenshot of some of these components documented. This file, in essence, again, the designer, my designer colleagues are not really gonna look through it much unless they really wanna know more details about the design system, but they get as a resource when they are implementing their final designs. And here, an example of our templates. Moreover, we also provide in our design system a reference UI. So these are ready designs, or very, what we call hero shots of some of our interface screens to kickstart any step of future features that we are putting together in our applications. So our designers get to have a starting point, and these are some of the examples of the designs that we have. And basically, they need to extend these steps or define even more details for the handover process with development for the prototype. So it's handy from a design system perspective to just give them ready guides. And also for them to be familiar of what are other consistencies that they should maintain in terms of interaction, positioning, layouting. In the end, there is a lot that the design system cannot do for the designer. They still need to put things together on a screen on their own. They need to know the spacing between things. So having ready designs helps them maintaining that consistency. And what's more interesting about working with design systems in a challenge like the one at TomTom is the fact that we are working with different screen sizes all the time. We actually don't know how big or how small the screens in our clients' cars will be. So we take responsiveness to the next level when thinking about this design system at TomTom. Let me show you some of the tools that we have. Figma, you're probably very familiar with, I hope. And for those who are not too familiar with Figma, this could be interesting for the next time you're going to be talking with your colleague. Oh yes, I have to carry this out to the next. 1 second. If I go here, yeah. Because it's not mirroring my screen, it's just, there you go. Oh, no, this also works. Yeah, perfect. Cool. So this is the Figma interface. And like the tool that we just saw in the previous talk, very familiar in a lot of aspects, right? And somebody even had on the Q&A a question like, is Totle supposed to replace Figma? It's an interesting one, also from my perspective, to find out, because it feels like, as a designer, every 2 or 3 years, we're having to learn about a new tool and get used to it, and yeah, basically get to interact with different solutions that the industry brings to us. So just to zoom in, for you to be familiar, and I think this is a good thing to share to anybody that needs to work with a designer, look at their tools. Try to familiarize yourself as well, because they're going to give you files that live in this kind of tool. And at least if you know their terminology and what they work with on a daily basis, it might give you some empathy on also how to interpret their designs. So we have, for example, these panels. From a design system perspective, they will basically use these assets tab to drag and drop anything that they need for their designs, for example. Right, so we get these little elements that we start to put together on the screen. We also have on the right panel the more details about the style aspect of these elements that we're working with. We get a prototype tab. So just for you to have an idea of what is it that we're working with every day. Figma is essential for the work that we do at TomTom. We moved previously from working on Sketch, yet another platform. But I guess what is nice about Figma is indeed the collaboration aspect. So that one, with a team of 60 designers, it becomes crucial that you should be able to comment, that you should be able to even drag things around if you have a different opinion or a suggestion on how a design should go. And we also have, for TomTom, a thing called Map Maker. So not only working with the UI of interacting with maps, we also need the map itself, the data, for those designs, for true representation of the product that we're working with. And this collaboration with development meant we can now bring this map to inside Figma in a much quicker way. We would have before to rely on simple screenshots from a destination and try to work on top of that. But now we have a plugin that actually brings that directly into Figma. And I'd like to show you a quick video of Map Maker and all its capabilities. So this is the idea. Not only we want to bring the maps inside Figma, we also want to enable our clients to customize the map to full extent of their brand, with a lot of features, using their own style. They can define some they can start from some ready maps and with some selected types of data. They also get to choose their own colors in this interface. And they get to customize their icons for point of interest or anything that is inside a map in a very straightforward way through this website. We can also add 3D landmarks, and this is all the data that is now provided by TomTom. And so we also get to style it in more detail through code on this map. And I guess this is the bit where the AI meets design. It's not a feature that is quite there yet, unfortunately, but definitely where we want to go with AI, that it would assist us to define those colors. In this example, it was like, give me a winter-looking map, for example. And here's where we brought this to Figma because of the plugin. All in all, to be able to achieve, or to be able to bring maps inside the tools that designers work with, and also to enable our clients to get these maps to their style. So the design system teams that I work with at TomTom has some responsibilities. We basically provide this full package. What I showed you on the assets, these are the Figma libraries. And we also provide the coded components for the developer colleagues to put together the product. We also have to have the guideline and documentation. But because we are a white label, we provide support as well, both for internal alignment and external clients when they are in the phase of implementation. And like MapMaker, we are constantly looking for tools and ways to bring together the two worlds. We also found more recently a way to extract those design token values in a JSON format and directly input that into code. So the handover process being even quicker. Not so much having to say, hey, this primary color changed from blue to red, but actually I can do that in Figma and just send it over in a file through GitHub. It's basically the toolbox for internal and externals to work with our products. And in the end, this is what we want to achieve. We want a screen design like this that TomTom provides out of the box to be adapted to look completely different in any case, alongside with its maps and all the experience, so that an adoption of a navigation application can be done seamlessly with our clients in any screen size. And it's really all possible because of the design system. That's why I'm very proud of it. Of course, our designer colleagues working in all these beautiful experiences have all the credit to be taken, but it is because of our little components and design tokens that we give to them that they can achieve it so quickly and easily. And this is the point where I like to make about being visual, right? You're now able to see that what the design system is capable of because of these screenshots. So make sure to enable that. If you want stakeholder buy-in, include that in your presentations and in your workflow. So as we are arriving at our destination, and this is called New Market, a very cool location in Amsterdam Center, close to Chinatown. Here's what I would like to share with you. Design and development have some common terminology. I put here together a word cloud that I thought, yeah, it's relevant. These are words that I use every day. Accessibility, and I'm sure you have to think about that as well. Component, I mentioned a couple of times, but actually, I might even refer to component something different than you might think as a developer. To you, maybe a component is actually a full block. To me, it's really just a button. There's specification, something that we provide from design perspective. We need to, in the handover process, give you a file with all those details. Where goes what, and what do we want to achieve through this? Tokens. You might have used, I think tokens comes from development. Yeah, and now we adopt it. Now we have a thing called design tokens. It's our word now. We have review, variables, release, architecture, scalability. All these things are common terminology in our day-to-day work as well. And I guess it's because we are now working so close together to achieve digital product designs that it makes sense. We all speak the same language. And in a product-led and custom-focused world, we need this diverse, collaborative, and cross-functional teams, right? The business, the right thing to build, and the building it right, as well as building it fast, that sweet spot in the middle is what you want, no matter what product you're working with. And so having similar terminology, understanding each other, having empathy for each other's discipline is very relevant. So get to know your designer. You know, share your processes, your terminologies, and your workflow. They are very interested in what you do as well, I'm sure. So I hope that with this glimpse on how TomTom works and what we have inside our design team gives you some inspiration, and maybe even if you need to work with map data in the near future, that you think about TomTom. Thank you. And if you want to get in touch, don't hesitate.
Thank you, Thijs. Before you go and make a TikTok video about your feelings after this speech, remember that we have a Q&A session after Zach's speech. So remember to put your questions to Slido. So for those who haven't been here all day, it's sli.do and the code is FF2024. Thank you, Thijs. I'll see you in a minute.
Thank you.
Or two. Yeah, so our next speaker, Zach, please come up here to set up your computer because I don't want to stay here and talk too long. Zach is how he describes himself as a Renaissance polymath. Sorry, I have no pronunciation on this word, but I warned him that if his setup takes too long, I'm gonna reimagine his whole life. He's a medical doctor, a pianist, a composer. Is this the moment when I start to come up with new things? No. He's gonna talk about learning Finnish. I mean, I could joke about Finnish language the rest of the day, but it gets really boring at one point, especially for the Finnish people. Does anyone have any experience on Finnish? I mean, non-Finnish speakers. Astrid, how long have you tried to learn Finnish? Okay, nice. Well, maybe Zach's way of learning language is going to be the one who actually breaks the bank then. Okay, so for those who were here in the morning, when Jani was talking in a welcome speech that our MC's work here is to make you feel uncomfortable, he was mostly meaning me, because he's a seasoned speaker and lived in London forever, so I think he can keep conversation with a rock if he wants to, but I mean, I'm really traditional Finnish person, so for me it's, I mean, we don't want to waste words, right?
Oops. That's not what we...
How does it look, Zach?
I think we have two screens. And that's not what...
Okay, one port missing. Doesn't matter. Doesn't matter. Zach, how are you feeling?
Let's see. Now?
I think we're
Almost.
Almost there. Meanwhile, give it up for Zach.
Now. Nyt. Okay. So, Finnish companion. Let's see. Now, yes. Sorry for the long setup. So, I'm going to talk to you about the Finnish companion and the whole experience and adventure that led me to actually create this platform called the Finnish companion. When I first moved to Finland, I actually met somebody who had been 15 years in Finland, yet didn't speak a word of Finnish. And that really got me curious on why. If you talk to anybody who has been learning Finnish, they would describe the experience as this. It's a complete nightmare, they crucify themselves, they jump off the cliff, it's a complete nightmare. And according to the United States Department of State Foreign Service Institute, who actually has a ranking of how difficult languages are, Finnish happens to be one of the most difficult, a little bit after Arabic, Chinese, and Japanese. And the reason is because there are inefficient and scattered Finnish learning resources. There's not one go-to Bible. If there are some people here who speak Spanish, Italian, French, or German, you might actually be familiar with those books. There's a very overwhelming conjugation. You can add, double a letter, it becomes a complete different meaning. You can take out a letter and it becomes another different meaning. So it actually is very important. And then there's very challenging phrase construction challenges. If you take out two dots, actually things can take also other meanings. And depending on what you mean, the word that follows also changes. And there's also very limited practice opportunities. Not only Finnish people are very nice, but introverts but they are also so nice, they talk to you in English when you talk to them in Finnish. So the solution for someone like me who has moved to work in Finland was to learn Finnish very fast and very quickly. And the way for me to do that was kind of a gym buddy that helps you lift a heavier weight long enough so that you can actually develop the force to lift it by yourself. This is literally the Finnish companion. You have just enough muscle so that you can do it by yourself. But concretely, it's a website and an app that's been designed. And as Thais was talking about design thinking, I had the chance to also work on design thinking on the medical side 11 years ago. And I got to get familiar with how you need to understand the need of the final user. Back in the time it was doctors, in order to make something that is really relevant to them. So I applied those same principles to the Finnish companion. And the Finnish companion is 4 main blocks. It's a dictionary and a conjugator, reverse conjugator, word breakdown and pronunciation support. There's a very unique tool that allows you to practice and practice and practice and practice and do drills of conjugation until they become second nature. So it's called sisu drills. And then there's a Finnish TV real-time translation tool on the browser. And then there's teacher tools as well. So let's look, for example, at one of the features, word breakdown. If you know this and you can read it, you're a champion. This is the longest word in Finnish. We take it, we put it on the Finnish companion, and we go from this to this. Lentokone suihkuturbiini motori apumekanico aliupseeri oppilas. You take another word. We can put it again in the Finnish companion, and it becomes easier to read. Terveyskeskusmaksu. The reverse conjugator is also a very, very useful tool. It turns out that when I was working at the hospital, when I moved to Finland, I was reading at the screen, and there were so many words that were already conjugated, I couldn't figure out what they meant. So I would try to go on a translator, I would try to look them up, no results on dictionaries, because I couldn't even know what's the stem of that word, what's the origin of that word. And there was no tool that did that. I looked for books. There were no books that did that in 2022. So I made it myself. You can put any word in any form, and it actually tells you what it's coming from. You write kavelivat, and it tells you it's the third plural of kavella. This is another example. You can type any word. It can actually conjugate it. So you type, for example, you type tehdä, minä, hän, and past, and it says hän teki. If you want to know how a word is conjugated, then it gives you actually the template. Sisu drills. So sisu drills is where I actually started to play with Vue and trying to make components. And as Thais has said, and I remember the first time that we spoke, she did ask me actually, what do you mean by component? And for me, back at the time when we were talking, this was a component. And the idea was that the app would generate words and asks you to conjugate them. To be more concrete, let's see if this works. Internet. Okay. Connectivity. Now. So you get to choose what you want to practice. These are the words that I would like to conjugate. And it gives you similar words. So punainen, nainen, keltainen, and so on. There's also feedback with sound and icons and colors and so on.
Korotusta.
And so on. Etc. If you make an error, then it blocks the input. So I did that just for me. But it turns out things were getting in another dimension, which I didn't know. I started to make other components as well in terms of how to structure a sentence. So I would actually generate generic word, and I would have to place them in the right place and pick the right word. And then Finnish TV subtitles. When you move to Finland, turns out that there's a very fantastic service called Yle Areena. It's free Netflix, because it's paid by taxes and public money. But most of the Finnish content is actually in Finnish subtitles, eventually Swedish subtitles. And that's an issue because they speak very fast, and it's written also very fast. They speak in dialect, murre, and it's also in murre, and you're trying to keep up, and you don't know what's going on. And it actually becomes a challenge if you're someone who has just moved to Finland or is learning Finnish. So, again, I was curious, and I ended up doing this real-time subtitle translator, which worked actually on the user's browser. So it was browser extension, had nothing to do with Yle servers or anything, and started to play with my own translation model, and turned out that it was doing very well. So Finnish Companion is actually a free tool to use, and it is meant to be a social enterprise and a not-for-profit with a very, very long-term goal and sustainable goal to make Finnish more accessible and affordable to people who really want to learn it or have difficulties and challenges to learn it. And it's also built on certain values that are, at least maybe we share them, but they are very, very personal to me. And that's minimalistic and useful design, meaning no bloatware, no ads, and please no gamification. Please no locked levels for the user to use. If he wants to jump, he can jump. Those were kind of the values. There's a certain business model that's mostly built around sponsorship, grants, and consulting. And turns out that the Finnish Companion was a winner in one startup competition that in a very surprising way because it was not expected to win, and it actually ended up being all over the press, and that helped a lot. Now we have about 3,000 unique users monthly for a not-for-profit platform that didn't have any users 5 months prior to that. It was something very rewarding. So the question now, how did it happen? Turns out that Tuuli, when she was trying to introduce me, she said that she didn't know what to say. And I do indeed describe myself as a polymath or as a multi-potentialite. But the reality is that embracing different fields and multiple disciplines to actually transfer certain skills to another field and apply the same logic to improve it or innovate is actually fun. I'm a medical doctor. I used to work at Google's Singularity University in Silicon Valley, and I've been actually a professional pianist and composer since about 20 years now, and speak many languages. So there were actually pre-existing ingredients. And that's the thing that I'm not a professional coder. I didn't go to university to study coding. but I have been coding since I was a kid on BASIC and Atari. And then I started to use Delphi. So if you're looking for some replacement on visual drag and drops, you can try Delphi. And then I started to get into PHP 4, and then Front Page, and Dreamweaver, and making websites, and then interactivity with Flash Player and Director. It was a very exciting time back then. And the other aspect is professional pianist. But here's one thing. The common point between pianists, tennis players, and special forces is that they have something that has a neuroscientific basis where they have to repeat and repeat and repeat and repeat until it becomes second nature and it becomes automation. When you see a professional pianist on stage playing a very difficult piece as if it's second nature, and you wonder how does he do it with his eyes closed, and he doesn't even look where he's putting his fingers, and he gets it so right and it's very fast, that's actually because there are hundreds of hours of rehearsal nonstop every day for several months. And it's the same for tennis players and special forces. They've mastered the skill of going from nothing to becoming extremely proficient. They've mastered that science. And that's the pre-existing ingredients. You have coding, and there was some personal experience as a neuroscientist and medical doctor, and the art of piano. If I was a coder and not a doctor, probably I would have done something, but I wouldn't have really understood the neuroscientific basis. If I was a neuroscientist who didn't know how to code, then I wouldn't have been able to do it. So it slowly evolved, and that's how it started, actually. Those were the few first weeks when I was in Finland. I had a Google spreadsheet that had a Google script, and it was just doing Google Translate when I was in class. And then I would have this Google spreadsheet, and then later it evolved into an Airtable database, which I would put into flashcards. And then I developed my own plugin so that they sync into this database. And it started to become kind of a system. And then I built my own linguistic engine, built another engine as well. And this one would do very fast conjugation, reverse conjugation, as well as dictionary. The dictionary data was compressed into binary format, serialized into binary format in Kappa and Proto, so that it's really, really fast. I really cared about speed for some reason. And then there's the Open API now that's public and can be used. And it actually, you can type any Finnish word, and it returns the readable version. So the endpoint here is readable. And then there's the Mac OS. If you're familiar with Mac OS Spotlight and Alfred, then this is kind of the equivalent. I call it Finnish Companion Ninja, because you're on the computer and the keyboard and you really want to do something very, very quickly. So you can do the reverse conjugation, you can do conjugation, anything that Finnish Companion can do. And it's shortcut on your operating system, not on the browser. This was built actually with React using, what is it called? Forgot again. Not Ionic, Electron. Electron is using Electron, and the bundle is about 500 megabytes. So it's a challenge, and I'm thinking to move it to something else. And this is also another approach using the same kind of approach as Notion, for example, where you would select the text, just press a shortcut or click on the bar. It would immediately do the translation. And then you would take a word, just add a suffix. It will give you the meaning of it. You can, and this is just on the keyboard while you're typing on your text editor or Word browser. For example, you can type anything, and then you would do real-time translation. Then you would take a word, And you're like, okay, could you please tell me the meaning of it? And you will get the dictionary definition. And then you want to conjugate something, but you don't know really what it is. So you say EEN by Vistyksen, for example, and so on. So I think that was with my, yeah. You get the point. And then a lot of people actually would recommend you, if you want to learn a language, to listen to the music of that language, to learn vocabulary. Turns out it's not because you listen repetitively to that music. It's, of course, because of the melody, but it's because you listen repetitively to it. And if it's a very viral music, then it adds even more. And that's another component we were prototyping with translated lyrics. And this is mobile compatible as well. So if you're a foreigner and you really like this and you keep in your mind "en pysty päätä," you would know that it means I can decide. So you're actually learning through the song. But the specific thing, the neuroscientific basis around this is that it's music under 1 minute. They have to be viral, crunchy music that really, really makes you want to listen it again and again and again. So it's good mini dopamine highs, so to say. And then there's also a mobile floating button. And the idea is that because Finnish is very challenging, then you have to surround it from every situation in your life, whether it's TV, whether it's on your mobile phone. So just by clicking on the bubble button, you actually get a quick window that you can prompt. You can even do the same as conjugation, punainen and partitiivi punaista, and do reverse conjugation or conjugation minä, past minä tein. And this is the browser extension for Yle Areena. So some of the actually TV shows actually don't have English subtitle.
No niin. Sitten voitte pikkuhiljaa alkaa oikoa käsiä, venytellä vähän se ja virota sieltä ihanasta loppuun. Maksukanavalta.
So you can actually change the language.
Se paketti, joka voi ennen kisoja, se oli tarjouksessa. Se oli jotain 20. Se oli jotain 20. Eli paljonko se oli? En mä muista.
This is real time. There's no data kept or there's no data kept or anything. It does multiple languages. And then the design system. It turns out that I don't claim that this is a really, really professionally done design system, but it's slowly shaping into a design system now where we're looking into different parts, for example, as how would the drill look like. And turns out that we can, you see here that if someone types something correctly, but if they type something incorrectly, there's a red button as well. That is logged. And that is also kept in the user's profile for analysis, and they will know exactly where they're making mistakes so that they can address that directly. So we went from pre-existing ingredients of coding, medicine, neuroscience, and performance to actually building a Finnish learning ecosystem that's made of a core engine, a platform API, and additional apps, and a design system of components and what I would call tiny components. And this is the discussion that I had with Juho and a couple of other engineers 2 days ago during the workshop as well, where we discussed AI for front end. And it was very interesting discussions, and we had some thoughts. But this is, if I quickly switch here, what I would call the AI salad bar of ingredients. The idea is that you have tools that are available to you and then that you can just snap and reuse. I don't personally believe that there is one tool that is the holy grail. I think it's literally like a salad bar or sushi bar. You pick what you feel like in the mood and what will do the job. So for example, in terms of AI models, right now, it seems that GPT-4o and Claude 3 and Gemini are doing well. Each one of them has their own specificities, of course. There's a very, very interesting thing to watch, I think, called the small LLMs and the tiny LLMs for the use on the edge. I think those are also going to be very interesting because they are small in size and are pretty fast. You can, of course, rely on UI frameworks as you want them, and each programming language for its own niche. This is kind of the experience that was learned, at least through the Finnish companion platform. I don't believe that you can build front ends with Rust. I think also you have to iterate very quickly. And in terms of iterations and AI, I think Streamlit is a very good platform to use if you want to build very quick widget. It's not reactive, but very useful, as well as Lightning AI. And those are kind of what I would describe as tiny components, or components to augment your app. There's the Notion-like intuitive UI, where you have this bar that shows up, and you click just on that magic button. Actually, if we go here to the Finnish companion, to the SISU drills, and then let's say we pick up a verb, say present first, indicative, and then say verbs that I use when ordering at the restaurant. So this is typical of a Notion-like kind of UI that would go back, and then you would I would like to practice exactly these verbs. And that's you go.
Minä tilaan.
And so on. And then I think there's the chat UI, of course, and the browser extension, the tiny bars that I mentioned, the auto-suggest bubble as well, Alfred-like commands as well, like the one that is here, so anything. I don't know. Any suggestions? Huh? Salmon soup. Lohikeito. And then if we take lohikeito to the readable, lohikeito. Salmon soup. So the Alfred-like command palette. And then last but not least, I think those ghost predictions that you can also use to augment your apps, similar to Copilot and Gmail Smart Compose. And you can use them on any of your user interfaces. I believe that that's also the future. The challenge is that how you're going to get the suggestions behind. That was the very interesting topic that we had 2 days ago, and we were kind of like looking at the models that we can use and so on. You can use, of course, obviously LLMs, but you can also use your own models. But the bottom line is also that you don't necessarily need to focus on LLMs. LLMs aren't the single source of truth. They are not a magic bullet. You can use your own algorithms and so on. That's the engine, the linguistic engine that the Finnish companion depends on. And also, LLMs can be very malicious. In fact, there was a very interesting cyber conference a couple of days ago at which I was, and turns out that malicious LLMs can actually also help you make malicious code and malware. So things to keep in mind is that you also have to take now into consideration that there are people who are using now LLMs to try to break into your apps and your servers and try to tamper into that. So this is one example, which I did just today when I was looking at preparing the presentation. This is a normal ChatGPT. Doesn't work. And then very simple formula. Turns out that he gives you the recipe on how to make it. Same GPT, same account. So you should take that into consideration as well, that there are malicious people who are trying to actually actively look into vulnerabilities. So I think the Finnish companion today is a learning tool. It's a design system. It's a mindset and a methodology, and a not-for-profit organization with a very specific purpose. We'll be releasing the Ninja app, the Alfred-like, very soon. The Android and the iOS app are going to be out as well. The Julia Arena browser extension also is going to be out. And then taking into consideration the Finnish dialects, which is the next level. That's another level. But I'm really glad today to be here with you and to share with you this adventure and story on how the Finnish companion came to be. But I think more importantly, and I know that you are very tired, but one thing that you have to remember once you leave this room today, especially for our international people, is that you have learned how to pronounce the longest word of the hardest language ever. Lentokone suihku turbini motori apu mecanico ali upseri oppilas. Thank you very much.
Thank you, Zach. While Juho is setting up our Q&A chairs, please do stick for a while. It's not gonna last too long. We have 20 minutes time, so let's go through the. Okay. So we're going to go through the questions, and you can still send them, and you can also upload your questions or other people's questions. Please have a seat. Zach, you told me that when you moved to Finland, you lived in Kuopio.
Yes.
Is there anyone from Savo except Juho, of course, here? Yeah. Well, those who don't know, people from Savo, they are the twisted ones from Finland, and they do have a funny dialect. Have you considered introducing Savo?
I'm very happy that in Helsinki I felt that I was progressing. Yes, progressing in Finnish. So.
Okay, we'll give you a breather. There's quite a few questions for you, Thijs. And I think that there was quite a few related to how do you kind of measure the success, and can you use AI to measure if your, design was a success or not?
Successful. Yeah. That's a very good one. We haven't looked into AI to help us in the design process as much. I personally use it in the chat format. We do have an internal setup. We call it Chatty, like our own internal chat GPT. And so in my day-to-day work as a design systems designer, I might use it as a way to find content that I need to know about a specific component, for example, or just ideas on how to document actually what we have. So I think it speeds up that type of process. But when it comes to measuring, in the end, it's a lot about analyzing data. And I think we might still be afraid of the hallucinations. Because, yeah, how then can we be sure that we can trust that it's analyzing the data correctly? It's very nuanced, right, when it comes to user testing the designs, which are very personal. It's a lot of the times it's a taste. I like where it goes, or I like this color. So yeah, how to bring AI into that, it's not something we did. But for the maps example, a feature that we want to look into then is having the AI help us come up with very pragmatical things that are common sense, like winter colors would be several tones of blue. Therefore, as a designer, I don't have to waste so much time now thinking of like 50 shades of blue. The AI can do that for me. So I think that it will be a first step before we even use it for measuring.
Yeah, and you have to think a lot about security, right, when you're talking about automotive. Sorry about my pronunciation.
Yeah, automotive, yeah.
But is there some legislation that you have to consider when you're doing the design?
Interestingly enough, we are looking into having conversational AI for our application itself. And so the way I think TomTom is going in the future is more like you interacting with your car to be able to do the action in the screen that you wouldn't have to do it, so you can keep your hands on the hand driving. So that would be the case of, take me to a nice restaurant, or show me where the nice cafes are around. And that would be like conversational. So I think in that case, if there are legislations specifically to like how much interaction or how much a driver could trust an AI to assist in navigation. If our team that is working on conversational AI is looking into that, unfortunately, I don't know much about. I would be also curious to know, actually. But those are the thoughts that I have for now. Like, I would probably have, definitely there's going to be something about, like, how much can we trust the car based or that is being built with AI?
Yeah, for sure, we're not there yet.
No.
And as Zach mentioned, there's like malicious models as well, so you have to be quite careful. Well, this was kind of related to the topic, but this got so many upvotes. So there are specific standards. Are there specific standards that car UIs have to legally fulfill?
Yeah, to legally fulfill, what I've been looking to is mostly the accessibility. We have a lot of guidelines. There are for web, so the WACG has all those specifications. You know, the elements in the screen should be accessible for keyboard navigation, and you need to have everything inserted in the code. And when it comes to the automotive, a lot of that goes out the window because, well, there's no keyboard interaction in a car, right? Everything is touch screen. So I think when it comes to what we have to be more concerned about is color contrast, size, and touch areas. So those guidelines are the ones that are more or less written in a document that we have to follow as such. And everything else is the design principles that I shared. Basically, the designers in TomTom have to be aware that the steps to take with that interaction need to really avoid the end user, being too distracted while driving. And we have a concept of, for example, there are some elements in the interface that shouldn't be interactable at all when the car is running. And therefore, if you try to pull up a keyboard to search, so you're there driving and you want to quickly search on the map, how do I get to the shopping mall? The keyboard won't pop up. You will get like an empty state saying, nope, you have to be stopped before you can search or type on the keyboard. So I think those guidelines are basically what we have to more or less adhere to.
Yeah, thanks. Back to you, Zach. People are really excited about this. I mean, they didn't know this kind of tool exists, and now everybody knows it's super easy to learn Finnish, move to Finland, go work for our sponsors, everything is now possible. But do you think that techniques used for developing Finnish Companion could be useful for learning other languages?
Yes, the short answer is yes. But my focus with the platform is only for Finnish because it's very difficult. And the goal is to make the language accessible, but yes, you can of course use it. And I've been thinking about actually open sourcing the platform so that it can be used by the community or anyone who's interested in developing for Spanish or for Italian or Japanese and so on.
I need it for Dutch. I live in the Netherlands and I still don't speak it. I've been there 10 years, and but I definitely did not dedicate that much time like you did.
Yeah, maybe you should also consider moving to Finland since you visit us every year. What is in Amsterdam, anyways? Yeah. Okay. I don't know why this was so popular question, but Thais, I noticed word sprint among the use terms. Do you use Scrum in the design team?
Yes, we do actually. I think because a lot of our designers are embedded in product design teams and they have the sprints. But actually when I added that to the word cloud, we kind of stole the word sprint for our own. We have a thing called design sprint, which is basically a sort of workshop setup that you go through the process of creating something new, but very quickly, like within 3 days, you identify the problem, you come up with ideas, and you make a prototype, and it goes really quickly. I think Google is the company that sort of started the design sprint idea, and it's a process we often use as well.
Yeah, this is not in a questions, but this is my personal interest. When you talked about components. And I think for developers, when we create front-end developers, when we create a simple component, I think the most time I spend is to thinking about name for the component.
Yep.
And naming, it's painful.
It is.
Do you do that for your developers? Do you offer them this is really usable component naming?
That's a good one. I think coming up with a name is tricky, and it needs to follow a system. So it's easier when you set those things up in the design system level. And actually, we're getting even to more challenging points of naming something with the design tokens, because now we need to come up with these elements that reference something, and we need to give their names. So as descriptive as possible is basically the guideline when coming up with a component name. And it does happen sometimes that if the designer didn't define the name, the developer will go ahead and think of one, and sometimes it just doesn't match. Sometimes, somebody calls it a tooltip, but somebody else calls it popover. And those things are tricky. So it's like, I guess it goes a lot with languages as well, right? In the end, you have several words that mean the same thing. And how does your system handle that? Because do you have words with same meaning? How is the translation going to work?
The naming the components?
No, I mean just in general with languages in Finnish, right? So you have a word in Finnish that means something.
Yes.
And your system needs to know oh, you mean this thing and not that.
Well, it's a model. It's a translation model. So it's based on an open source translation model, and then we kind of added more and fine tuning on it with more data that had been scraped. But then if it's a dictionary, then it's very literal,
right.
Which means that if you say, for example, kuusi, then it will tell you that it's number 6. It will tell you that it's the moon. It will tell you that it's like a spruce. It will tell you that it's like all of those suggestions that come from a normal dictionary.
Right.
Yeah,
And how do you name your components?
The components, I actually name them by, that's a very good question. It's by parent underscore and then whatever follows. But it's very easy because the platform is based on Nuxt 3. So it has very nice component folder level organization, which I found very intuitive. But then now we're moving to another platform for other reasons, mostly authentication and security.
And that's probably going to influence the names again.
Yes.
Right. Yeah, I think in the end, the tricky part is really making sure that whatever platforms either discipline is working on, they use all the same name. So if it's called tooltip in code, it should be called tooltip in my Figma asset. And that's a lot of the struggle happens sometimes with, just mismatch, and then you're not sure if you're talking about the same thing.
Yeah, I have to say that I miss the times when there was still Sketch, and then the designers would deliver the design to Zeppelin or something like static one. So I could rely that this is decided. Now when I get a link to Figma, every time I go and see it while I'm developing, everything has changed, and I do it all over again.
Yeah, that's true. And that's where, unfortunately, the development process hasn't been completely adopted by design yet, which is the idea of branching and merging. Figma does have that feature, but no designer uses it because I think they just didn't really understand. But it's where I find that it's struggles like this would be avoided because, if you want to modify something that has been delivered already once, you need to branch it out and merge it back in and have a change log. And but no, designers like to just be like, you know what, no, I changed my mind. Let's do it again.
I think we should switch roles on a day for a designer and developer and see our struggles, because we do, have those both sides.
Yeah.
Zach, are you planning on using AI as a tutor that can automatically generate your learning plan and schedule, or adjust training based on spaced repetition?
Yes, I've been thinking about this, and it's a very, very big question whether Finnish Companion is going to become a learning method, because I've been very cautious about not being and not falling into the gamification trap. And once you get into generating a curriculum, therefore you need to have the student to be motivated. So far, I'm being very prudent and conservative to keep Finnish Companion as an aid tool, as a support tool, so the student or the Finnish learner goes to it willingly and intentionally, and it's a support for the teacher as well, that the teacher can share links for the sisu drill session, and they go and practice those verbs. So, but for conversation and generating content, yes. It's already used for generating, for example, the sisu drill suggestions, but then we're now working on also generating short question answers, multiple choice questions and simple choice questions for UKI test preparation as well, so that students can actually do drills, so that they can walk into the UKI test, which is the Finnish B2 level, or C2 or A. I don't remember the levels, but B2 is the most wanted one. So yeah, we use them for generating that. Yeah.
There's also someone interested on. Oh no, it got lost. Sorry. That what other language resources used by Finnish Companion? Like, how does it know all the quirks of the Finnish language?
Yes, that's a very good question. It's actually open source data. So that's number one database that was used was Wikipedia. And to be very accurate, Wiki Dictionary. But then the thing is that it was very challenging was to actually extract the data from Wiki Dictionary and parse it. It was a long work. And then that was the English Wiki Dictionary, because there's also a Finnish Wiki Dictionary. And both have English to Finnish, Finnish to English. That was the English Wiki Dictionary. And then the Finnish Wiki Dictionary has also English to Finnish, Finnish to English. So there was a lot of work, but now it's kind of, a big database. which later was optimized and optimized and optimized into an actual serialized binary that's in Kappa and Proto, which is like super fast serialization and deserialization standard, which is really good. Yeah. So that's how we use it to get the dictionary data and words.
Nice. People are often super interested in like really practical tips that they get out of these speeches. So are there specific tools or techniques that are useful for interaction design?
For interaction design, I guess Figma is really the main tool that, with a good library, like a design system in place, that you can quickly put ideas together and put it in the front of users. So in our case, because we're designing this UI for car navigation, we have also at TomTom tablets with a pre-installed version of our application that we can quickly iterate. Or if you don't have the application that you're working for in a working device, what Figma does is actually enables you to make prototypes that you can click around with. So interaction design is really about like putting it in front of somebody and having them interact with. So the added challenge for us is that our end result is not in front of a computer screen, unfortunately, but for a lot of the people that work with websites, then really don't be afraid to just sketch something quickly together. And even if it's not interactable to much extent, at least you start getting an idea of where the person would want to click. If where you thought that the component position is adequate, that they would go for that. And other than that, yeah, there's a bunch of tools in terms of creating interactive prototypes. A lot of them are paid versions. And our interaction designers at TomTom would probably be able to tell you more about those. I'm really dedicated to the design system aspect. So for me, really Figma is the tool for interaction design.
Zach, have you used any designers with Finnish Companion, or how do you come up with that?
Yes, the graphic design, yes, but the actual component, it was myself as well. Of course, I had some additional people who would help me when there's volume with certain data or something. But when it came to components, it's usually myself who plays with the sometimes it's Vue, sometimes it's Svelte, sometimes it's just based on the mood, really. But it's just like get things very quickly, build very quickly a component, try it and see how it fits. It's literally like building Legos and kind of sketching something and see if it makes sense or not. Does it meet this need or not? That's how, for example, I came up with this Buzz song with the lyrics. I was like, okay, well, actually it could be really useful. So every time I would be in the public transportation, I hear those Finnish songs and I can't really know the lyrics. I was like, okay, well, maybe I should do that. So it comes also based on inspiration as well. It's kind of like composing as well.
Yeah. Do you measure anyhow of those interactions, or?
I don't measure the interactions, but I do measure basic website statistics and which page and so on. So I keep a look at that, and I'm pretty happy with at least Sisu drills. And there's the other one, which is audio loops. I didn't actually show it. I realized that I forgot to put it in the slides. But audio loops also, where you can type any phrase you want, and it would literally repeat it for 10 times or 20 times or during 2 minutes. You actually get to pick that, and you put a playlist, you put your earphones, and you're walking, going to groceries, in the bus, and it's just repeating that and hammering that in your brain until you get it. Because trust me, you will need repetition with Finnish language. And also auditory. It doesn't have to be that you sit on a chair and study it or do it on your phone, consciously. It can be also passive. And that also, the brain learns also when we're focused on something else, but there's sound in the background. It's still picking up. So
During sleep as well?
No, not during sleep. No.
Ah, shame.
No. I think at least some point there was, back in the day, talk about like people are different learners. So some people need the audio and some people need the visual.
Yeah.
So do you have some kind of combination of that?
Yes.
Yeah.
Actually, it's part of the design system. We have the Kuva drills, so it's the same thing where it shows 4 pictures, and that need actually came by doing some of the design thinking sessions in Kuopio with an agency with a very impactful local NGO that helps foreign immigrants and refugees settle very well in Finland. Turns out that I was focusing on the desktop version of Finnish Companion, and I just realized how completely I was far from what I should be doing, what's needed, because I spoke to this Finnish teacher, and she told me 80% of my students are migrants who come, they don't speak English, and they don't speak Finnish, and they just speak another language. How am I going to even teach them? And it turns out that we were kind of like brainstorming, and there's this Kuva drills that pronounces and then shows 4 pictures, and then you have to pick one, and then it's literally learning by error. And there's also a spaced repetition algorithm behind that brings the pictures, again, that you're getting wrong more often, and so on. So there's that. The browser extension is more visual, for example. There's the auditory one. Sisu drills is very tactile. So I think so far those are kind of like the different ways of learning.
Yeah, and you said, you showed the setup of the testing, like there were so many screens and stuff, but is there other way that you collect feedback?
So with end users, mostly in the car, and some interviews. So sometimes we do have tests set up that is just on the computer screen, and we invite them into our offices, and we give them a task to complete, and we see how they would go about imagining a car situation. We also have a couple of setups in the office that is an actual dashboard of a car, so we don't have to be inside a car to try it out things. So it's really cool, especially from with specific clients, because then we know exactly their dimensions, and so we get like a sample of their screen.
Does it honk?
That's a good question. I never tried that. And other ways of testing, well, the design system itself, I actually make available this Figma file I have to anybody in the design community that wants to experiment with it, because in the end, my end users as a design systems designers are designers from my team or from my clients' teams, because it's a white label. So for me, it's important to get their feedback also like on the usage of those elements, those components, if the color, the token structure makes sense. So I send out this file and reach out afterwards to find with a few questions.
Yeah, there's still at least this one question that is avoided a lot, because I think this is a headache for all the developers. So do you have to think about legacy devices as a designer?
Yep.
I have understood that TomTom widely supports older devices.
Yeah, definitely. In the car industry, the challenge is the fact that those manufacturers are stuck with a lot of hardware for a long period of time, and whatever we sell needs to accommodate for that. So in a design perspective, we have to take that into account when we are coming up with new solutions or interactions that we want to propose for the product, because for some clients that might be interested in that solution, we will have to think backwards compatibility on that Android version, on that screen size. So definitely something that we have to look into. And one way we avoid having the issue that you were having with coming up to Figma file and everything changed is the fact that we provide specific final designs. And we don't call it final, it's called design specifications. And that's more or less set in stone. Once that has been handed over to our developers, whatever we work on is a separate thing. So we don't work in a branching methodology or in the similar way that Git does, but we do try to sort of make it a screenshot of what happened in that period of time because of backwards compatibility issues that we might have in the future.
Yeah. I know, Zach, the Finnish Companion is not really tied to any hardware, but do you have to think about these?
Or you just keep adding?
In terms of specifications or in terms of?
About legacy devices or legacy, maybe.
Actually, yes. Legacy devices, yes, because we have to be mobile compatible. And as I was talking about that teacher, for example, in Kuopio, users actually have old Android devices, for example. And it was actually, I realized how horrible the platform was looking when I looked at it in an old Android. I really looked, not good. So I had to rework it and rework on some of the JavaScript manually and so on. So yes, look into that. Except that, I think we did use also, I've been trying to use now actually Object Pascal actually as a replacement for the Electron version of the Alfred clone, because the bundle of 500 megabytes just doesn't make any sense. And I did make a small prototype which works also. I think coding something in Object Pascal is quite interesting. But that's old language which works pretty well actually. So, and it's a safe language. I don't know if, I think it's been in the news quite a lot a couple of weeks ago that the White House had announced some of the list of the languages that are safe to use, and actually C and C++ were like a no-no. So it was a big push for Go, for Rust, for Java, Swift, Ada, C#, and actually Delphi and Object Pascal. And they were actually noted as safe by the White House. And there's a big push towards that.
It's incredible what medical doctors can do nowadays.
Yeah.
I always said that the doctors of the future are data managers.
Oh, really? Oh,
I've always thought that.
Yeah.
Fair enough.
Maybe the AI will save our health for.
Well, especially when robots will be able to do like surgeries a lot in more detail than a human would ever be able to, right? The preciseness of laser.
Yeah. No, lasers are really good in terms of precision because they are predictable. Robots, I don't think I would trust a robot in surgery, honestly. And they cost a lot, actually. It's the cost thing. But yeah, LLMs in medicine, I don't think are, they can be useful in summarizing data. There's the whole issue of privacy and like the server's location and so on and where it's located, but they can be used for summarization and everything, but I don't think anyone would trust it definitively as a diagnostic tool. I actually was talking to the Google Med LLM team a couple of weeks ago, and we were talking about how it could be used, and right now they are very clear and strict about the fact that it should not be used for diagnosis. So you can look it up, you can kind of use it as an aid tool, as a co-pilot, but you are not to use it as a final diagnosis from there and just pick it up.
Yeah.
It's just like autopilot.
Yeah, but it still kind of leaves the risk of error to the person using the tool, like someone using, Copilot, and I don't feel like checking this too much. I'm just gonna to the production.
Push the production. Yeah.
Hey, thank you so much, Thijs and Zach. Let's have one more. Thanks for these amazing speakers.
Thank you.
Thank you. Thank you, everyone, for sticking this long. Tomorrow is a new day, and we start at 9, so remember to be early. It's going to be choose your own adventure. First, we don't know what's the adventure, so you have to come and find out. Have a great evening, everyone, and see you tomorrow.